have Day Zero chairs, who does an amazing job, Shruti and Urbi, both sitting together, very interestingly. So big thanks to them. The first starting was very strong. We have Sarani Bhattacharya, our poster chair. Ayan is still hard at work in PhD clinic, doing all those things in the background. And we cannot thank enough the local organization, IIT Hyderabad team, and first and foremost, ACM India. Niyati could not be here, so this is what she looks like, and she sent a message. She told that although she is not here physically, but her soul is with this event. We put a lot of effort with all of you in this event, and we are excited to start it. So finally, thanks to all the volunteers who are keeping random hours, meeting our demands and doing a fantastic job. And you will actually see them that they are wearing now some volunteer badge. So it is a big round of applause for them to start with and others. One quick note about the badges. So if you haven't got those, you should go to the registration desk and pick the badge that applies to you. It actually is meant to be an icebreaker so that people know who you are. Now, to the first event of the day, our first keynote. And to that end, let me, perfect. So with this, I'm really excited to welcome our first keynote speaker, Professor Nitin Saxena from IIT Kanpur. And Nitin Saxena completed his BTech CSc and PhD from IIT Kanpur. He was a scientific researcher in CWI Amsterdam and a faculty in Hausdorff Center for Mathematics, Bonn. He joined CSc IIT Kanpur as an associate professor in 2013, and currently he's a chair professor. He's the founding dean of Wadhwani School of AI and Intelligent Systems and the founding coordinator of the Center for Developing Intelligent Systems, an IITK center, which is now famous for solving the real e-governance problems at scale. Nitin's work appears in the premier research venues globally. He has contributed to the areas of computational algebra and complexity, which he is going to talk about. And more recently, he has been involved in the development of AI and practical cryptographic protocols. He has taught many courses, has created many online platforms, and regularly gives talks to inspire the next generation mathematical areas of computing. And he has a lot of prize, which I will not tell, except for one, Gödel Prize, which we all know and were extremely inspired from. So I welcome Nitin to the stage, and thank you for being here.
So this is how to. Can you shift from there? No. Let's try again. Okay. Yes. Sometimes. Yeah. Okay. Thank you. So first of all, I want to thank the organizers and IIT Hyderabad for this event. I think ARCS started around the time I was doing my PhD. And I came at least once in that year. I think it was in IIT Madras. So I'm happy that ARCS is going strong even after 20 years. So what I will present in this talk is a collection of concepts which I've been interested in for multiple decades. So most of these things are algebraic and they fall in the area of algebraic complexity. But then you will see a sprinkling of practical things and other areas. In fact, many, many areas. You can interrupt and ask me questions. There will be no details. It's only a collection of assorted problem statements and ideas which hopefully inspire you in algebraic ideas. So what is the fees? We start with the question, what is computing? So in this era of ChatGPT and LLMs, I think these kids will say that computing is what ChatGPT does, right? This is all you see, and it seems to know a lot. Whatever you ask, it can compute and tell you. You can just ask, and it can even actually write programs and then implement algorithms for you, right? So in this era, it has become very advanced, but 100 years ago, it was not that advanced. So for example, Turing wondered about this question, and he gave a model for all kinds of physical processes which humans can design, which they can call computing. And he actually gave a mathematical formalization, which is now called Turing machine, which is very simple. So it has a finite control, and it has a tape, which is basically the hard disk, primitive hard disk. It is infinite. So the control is finite while the memory is infinite. And then this can be used to actually model any kind of algorithm, any kind of computational device. We are not aware of anything which cannot be simulated on this. So he postulated a very simple, most general mathematical model for computing. And the Church-Turing hypothesis says that everything that we see or we do can be simulated on this, except, of course, we are not very sure about the brain, whether everything that the brain does can be simulated. That's an open question. So algorithm for us is, and computing in general is anything that Turing machine can simulate, and you can think of it as like a computer program. And it is a Turing machine or algorithms, the property is that every step is very simple and it is highly iterative. So it iterates on simple operations, and then in the end, after a long time, it solves something big and surprising, right? So LLMs also are, every step is very simple and trivial, but then overall, when it is billions of operations or billions of gates, something magical happens, and then you wonder whether it is truly intelligent. So this is what algorithms always are like. So I, in this talk, in my my interest for a long time has been not studying the Turing model, but studying another model which is more inspired by electronic circuits. So I'll define it on the next slide, because it's algebraically better to study that. So that is this model where you have in the leaves, you have input variables or constants, and in the middle layers, you have multiplication and addition gates. So these are the internal nodes, and then ultimately at the root, so this is a directed acyclic graph, and at the root, you get the output. Right? So in this case, the output will be a polynomial in the variables x, y, and w with coefficients coming from some field, or it can also be a ring. So it's a purely algebraic model, but anything practical can be simulated here. It's a complete model. In fact, it's more than complete. Even uncomputable problems can be simulated here because of some definition issues. I will not go into that. So this was defined by Valiant first. So just like Turing machine, there is this Valiant defined circuits and classes, which I study. And this is, in the end, I'll mention that this is very similar to also what the network architecture of artificial neural net is. It's also very similar. It's just that they use different terms there. They don't say addition, multiplication. They have fancier gates, which are inspired from statistics. So Valiant formalized computation and resources using algebraic circuits, and it gave birth to VP not equal to VNP question. I don't know how many of you here are aware of PNP question. I mean, if you are a CAC PhD, then almost everybody should know about that. And the algebraic analog of it is called VP VNP. So it's basically the question of, let's say you are given a bipartite graph, how many matchings are there? So it's a counting question. So the counting question, can it be solved practically? That essentially is the VP VNP question. But in framed algebraically, it's a bit more complicated, so I will not do it here. The question is of algebraic hardness. whether there are polynomials which cannot be computed practically. So algebraic circuit has constant constants, variables. So where are the constants? The constants can be put on the wires, on the edges. Okay, so when you put a constant 2 on the edge going out from x, then its effect will be multiplication on x, so it will produce 2x. So constants can be put everywhere, in the input or on the edges, on the wires, and then the gates are connected and the computation goes in one direction. And but the thing is that the difference from Turing machine in practice is that this model is highly parallel. So many gates are doing computation in parallel, right? So this is why traditionally in the 70s, 80s, this was the way to also model parallel algorithms. While Turing machine is highly sequential, there is only one processor, and that the processor is doing only one thing at a time. So it's completely sequential, but this is completely parallel. And the notion of resource here is, the notion of resource here is the size of the graph. So the bigger the graph is, the bigger the circuit is, the harder the problem is. Okay, and based on that resource, we have a number of complexity classes defined, which is there on the top right corner. So VF is the set of small formulas, then VBP is the set of small algebraic branching programs, then VP is the set of polynomials computable by small algebraic circuits. And the small refers to size as a function of number of variables. And remember that this model computes a polynomial. It is not just saying yes or no, it is actually computing the function itself. Formally, it is computing a function. We are not setting values to the variables, right? So it's a very powerful device. And then we have these more complicated things. So VNP-C or VNP is this, it is something which we currently don't know whether it can be computed in practice. The practice is kind of analogous to VP. So whatever is practical, that's in VP, and whatever is in VP, we call it practical. But above VP, things become hard, and those are the open questions, whether they are actually hard. In fact, in this, we don't know whether these classes, any of them, they are different. So it may happen that all of them are the same, or all of them are different. So these are open questions. So that's the central question being VP not equal to VNP. And there is something which is even bigger, which is VNP bar, which is the approximative version of VNP. So in algebraic models, we can also add the power to approximate. And then we get approximative versions of all these classes. So that may be too much for this talk. So in general, my work has been to study circuit problems across these classes and study those problems either to prove that they are easy or they are hard, and develop the relevant mathematics. So the holy grail is to de-fictionalize this fictional diagram, because here we are showing that the bubbles are getting bigger, but we actually don't know whether they are bigger, right? So this is a fictional diagram, and to actually make it real, you have to prove theorems, which currently we don't have proofs of. But progress, nevertheless, has been impressive, and I'll just mention some assorted examples. And the good thing is that this is something actually foundational, so it withstands both the quantum hype and the AI hype. So quantum and AI word, in the media at least, gives you the impression that there are no hard problems, everything can be solved. But that is not true. So if you study it systematically according to these classes or according to P and P, there are problems which are truly hard. They cannot be solved in practice. So making those ideas formal requires this machinery. And so for example, in AI, what they are solving, they may be NP-hard problems, but the input instances are special. So they are solving the problem on certain distributions which we care about instead of all distributions. But if you study all distributions, then the problems are very hard. So making these things formal requires these classes and these models being formalized. So it withstands the hype. If you actually separate two classes, then it definitely means that there are problems. In fact, most of the problems are very hard and they will take exponential time and they will never become practical, except maybe for some inputs and some input distributions. So the first problem I will take in this assorted list is something very simple to state. It is whether given a given a circuit in the input, whether it is the zero function, right? Which means not just that it is zero at some fixing of input variables, but it is zero as a function. So no matter what you fix, from which ring, finite ring, infinite ring, extensions, function fields, wherever, it always gives the answer 0. So this is the question of, we call it the polynomial identity testing question, or simply testing whether a circuit is 0. So identities are extremely important. So this black box is hiding one part of the identity, but I think you can guess what it will be. So it will be just, you have the sum of bi square. Similarly, the first factor is sum of ai square. So if you multiply sum of ai square with sum of bi square, then the product of these two sum of squares is another sum of squares. Okay, this is a foundational identity. It was discovered by Euler almost 300 years ago. And it results in a very interesting theorem, sequence of theorems, one being that any integer can be expressed as a sum of 4 squares. Okay, so identities have been very important in math. That is what actually almost any theorem in math expresses an identity. Okay, there is a left-hand side, there is a right-hand side, and then each have different interpretations, but they are equal. All theorems are basically of this type. And the computational version of it is PIT. Okay, you are given a circuit, and the question is whether the circuit, even after doing so much of computation, is it computing just 0 or not? So test whether a given circuit is 0. That's the PIT question. And it is open that, I mean, we don't have a deterministic algorithm, polynomial time algorithm for PIT, but practically it's a solved problem for a long time, because if you can flip coins, then you can solve this problem easily. You can just evaluate the circuit at a random point, random fixing of the variables, and if you see 0, then you have confidence that it is probably the 0 function that is being computed. And then you have to bound the error, but all that can be done. So it's a theorem that there is a randomized polynomial time solver for PIT, but there is no de-randomized or deterministic algorithm. So this is a central question. It is, in fact, related to the previous question of VP different from VNP. And the reason is that both these problems, they force you to discover new circuit properties. So whenever we discover a new concept for circuits, then those concepts help in both the problems, in understanding lower bounds and in understanding PIT. So for example, this identity, x plus 1 to the n equal to x to the n plus 1 mod n, this is also a famous identity. I mean, this congruence is related to some property of n. And that property is, can you guess? Yeah, this is a primality test. So this congruence is true if and only if n is prime. Okay, so this is a very roundabout way of saying that n is prime. Okay, so n is prime by definition when there is no number other than 1 and n which divides it and smaller than n. But then here something completely different is happening, because nobody is actually checking for factors of n. There is just this iterative process which is going on, which is just multiplying polynomials and taking remainder modulo n of the coefficients. And then if you get 0, then it means that n is prime, right? So this is a very interesting twist. So these are the kind of things that identities capture. This is what always happens. So based on this, we designed the AKS primality test, which is a de-randomized primality test. Okay, so yeah, primality testing requires PIT. That is the first congruence. If you want to check that, then you would have checked primality of n. Second assorted problem is black box PIT, where the circuit is given to you through inside a black box. You cannot see the gates, you cannot see the connections, edges. What you can do is that you can feed in input, which is fixing of the variables, and then in the output you will get an answer, which is say again a field element. So you can query as much as you want, and then the question is whether after polynomially many queries, few queries, if you have seen 0, then is the black box actually 0, right? So that is the question of black box PIT. It seems to be a priori harder than just the PIT question, because in PIT you can actually analyze the circuit details, but here you cannot. So that is an important problem. It again relates to lower bound questions, and it also, if you actually develop good black box algorithms for PIT, then it also leads to usually learning algorithms. Okay, so it's also, I mean, again, it's learning, PIT, lower bounds, they kind of interrelate. Another thing that happens with identities is a lot of properties of polynomials we discover and we rediscover and we are able to apply. So for example, higher dimensional rank concepts. So we have many theorems where we classify identities according to properties of incidence geometry. So we actually have proved new theorems in geometry because we wanted to solve PIT for a certain model. And so one higher dimensional rank concept is, say you are given 3 polynomials, x1, x2, and x1 square plus x1, x2. So are these polynomials in some sense dependent? So if you look at them as vectors, then they are independent. But if you look at them, if you are looking at an annihilator or an algebraic relationship between them, then there is an algebraic relationship, right? The third polynomial f3 is equal to f1 square plus f1, f2. So just by the definition, or in this example, it's clear that the third polynomial is actually a function of the first 2 polynomials, so there is a dependence. So this we call algebraic dependence, and we can call this an algebraic rank of a set of polynomials. So this is something more powerful than just linear independence. Okay, so these things we rediscover and we use them in PIT, and we prove new identities which are helpful for PIT. Like if I look at the dth power of a linear form x1 plus x2 dot dot xn, can it be expanded? So if you expand it completely, then you will get n plus d choose d many monomials, which are exponentially many. But can it be expanded in a more controlled fashion? So by controlled fashion, I mean you write it as a sum of product of univariates. So f1 x1 is a univariate, f2 x2 is a univariate, dot dot fn xn is a univariate. So that's a product of univariates. Can you write this dth power as a sum of few product of fi's? Okay, so this is a controlled expansion. It is not going at the level of monomials, because if you go to the level of monomials, you will get n plus d choose d. But it is still getting to certain, to an interesting level, lower level, which is product of univariates. Because originally the polynomial is not a product of univariate, so you cannot actually write it as a product of univariate, which is just 1. But can you write it as a sum of few? So we have identities, which I call the duality trick. So by duality trick, we can actually express this as a sum of few products of univariates. So these are interesting things. They prove interesting results in circuits, especially constant depth, like depth 3, depth 4. And finally, there is a concept that we discovered in circuits due to PIT, black box PIT, which we call bootstrapping. So bootstrapping is this phenomena which is very unique to algebraic circuits. It's not there in Turing machines or Boolean circuits. So what it is you prove a theorem for a very special model, and it implies a theorem for all the models. Okay, so there are many hundreds of models we have identified, which look very simple, but if you prove a theorem about them, then you would prove a theorem about VP, which is the class of all general circuits. So it's a bootstrapping phenomena. So for example, sum of squares is such a model. So if I can invent a polynomial f, explicit polynomial f, which requires a big sum of squares representation, then I would separate VP from VNP. Okay, so sum of square is a very simple model. But then if I prove an appropriate theorem for this sum of square model, then it is enough to understand all circuits. Right, so that is a stunning thing. I mean, you would be hard pressed to actually prove this in this 1 hour. It requires many techniques, but this gives you a glimpse into this bootstrapping phenomena, which is because of the structure that algebraic objects and especially polynomials have. Yeah, so then I changed the chapter. Any questions that you have till now? General or philosophical questions are also fine. AI questions are also fine. Although AI questions, ChatGPT can answer much better than me. Okay, so then I move to not just algebraic circuits, but algebraic algorithms in general. Okay, so what are the problems in computational algebra for which we have algorithms, and most of these algorithms have a utility in some application. So let's see some computational algebra tricks or assorted problem statements with algorithms. So first is this, you all must have seen in your engineering or numerical programming course, Newton iteration. So we have over the years a sequence of results where so Newton iteration is traditionally, like around 250 years ago, it was invented to to find a real root of a real polynomial. So you are given a univariate polynomial, just say in x, with real coefficients, and you want to find a solution x, which is also real. And you want to find it up to some decimal places. So, so the way it works is that it plots it basically tracks the curve which is plotted for y equal to fx on the two axes. And it starts with a lucky initial point, x0, which you have to guess. And then at x0, you draw a tangent. So it is basically tracking the curve, and where this tangent meets the x-axis, at that, let's say x1. For x1, you look at the value, which is f of x1, and then you draw a tangent there. So from blue tangent, you move to green tangent, and so on. And you can see in this picture, it's a proof by diagram that you will get the root, right? If you are in nice kind of curves, if you just follow tangent intersections with x-axis, then the tangent will actually take you to an actual root, which in this case is the red point. Right? So this is Newton iteration. You can see this algebraically, and then you can implement it very easily. It's basically just one step in the for loop, inside the for loop. And you can keep doing it till you have gotten enough number of decimal places, and it converges very fast. So there are all these theorems that it converges quadratically. So if you want thousands or billions of digits, then you have to run this for loop only for log of that. So it's extremely fast. So it's an amazing algorithm, and then we have now versions of this for multivariate circuit models, where the root again of x or I should say maybe y. So there is a multivariate polynomial where the variables are x1 to xn and y, and you want a root of y. So the root of y will be a power series in x1 to xn variables. That power series can be calculated. Okay, so Newton iteration has an algebraic variant which has been discovered many times. We also have a form which we discovered which we call all roots ni. And so it computes power series for the root of multivariate. So it works at the level of circuits. So it will compute a circuit for the power series. Because when you are looking at multivariate roots, the power series multivariate very quickly explodes the number of monomials. So you cannot just express everything as sum of monomials. So you have to always represent it compactly. And the only one of the good compact representations is this circuit model. So we compute the roots as a circuit. And then once you have the roots, you can also talk about factors. So you can also factor circuits like this. So that's the next question. So computing GCD, computing factors of a given circuit, given polynomial. So in the univariate case, GCD is this, right? So x minus 3 divides x plus 4. Does it? Well, not always, but mod 7 it does. So over a finite field, x minus 3 divides x plus 4. In fact, it's equal. And it also divides x square minus 2. So the GCD of these two polynomials is, there is a nice algorithm, which is probably the first algorithm humans invented. Right? This is the Euclid GCD algorithm. So it's a recursive algorithm, again a simple for loop with a simple step inside. So that will give you GCD, but GCD requires two polynomials to factor. What if the second polynomial is not available? What if I only give you x square minus 2? And then you want to find, from x square minus 2, you want to find x minus 3. Right? So that is the question of factorization. That's a harder question, of course. But fortunately, over the good fields like finite fields, field of rationals, we have fast algorithms. So given one polynomial, we can factorize it. So these are very classical results from the 60s and the 80s. What is open here is the question of prime powers. So what is that question? So you can ask for, so x square minus 2 factorization is the question of computing square root 2, mod 7. But then you might be interested in calculating that mod 7 square, then mod 7 cube, mod 7 to the 4, right? So what you are doing is you are writing square root 2 as a power series in powers of 7. With the peculiar nature that as you get a bigger 7 power, you consider it a smaller number. So 7 to the infinity is considered 0, right? So this is the inverted 7-adic measure, where the bigger the number, the smaller is its value, right? So this is called an ultrametric. So in that you want to write square root 2. So in this, so this is called the 7-adic arithmetic, or you can just, you might only be interested, because in computers you cannot actually express infinitely many things. So you will probably just want answer mod 7 cube, mod 7 to the 5, or mod 7 to the 10. So factorization in this arithmetic is currently open. Okay, even with so much of algebra that has been invented, we still don't know a fast algorithm to factorize polynomials modulo 7 to the k, where k is growing. Or in fact, yeah, maybe k is also constant. So just modulo 7 to the 5, already factoring a polynomial is, the only thing we know is brute force, which is exponential time. So that's an open question which I'm interested in. We have some intermediate results there. And finally, doing all this not only for circuit models. So for circuit model, again, you want to factorize mod 7 to the k or mod p to the k, but also in an approximative sense. So you might be interested in an approximative root. So approximative root is a root which makes your circuit tend to 0 in a very algebraic sense. So here, for example, two polynomials, x and xy minus 1. So if you want both of them to vanish, then for if x vanishes, then xy minus 1 will become minus 1, so it will not vanish, right? But there is a complicated way in which this also we can interpret as vanishing, because we can say that x is getting, as x gets closer to 0, y gets bigger and bigger, such that both of them vanish. So x equal to 0 and xy equal to 1, both are satisfiable in an approximative sense. So in a limiting sense, there is a limiting root, which is called an approximative root. So calculating these roots, or calculating these kind of factors, or even the approximative model itself. So what is it that a circuit model which is approximative can calculate? So these are big open questions. These are changing the model, of course, but in this new model, when we prove theorems, it actually reflects back on the original question of VP, VNP, and PIT. So this is where many results are being obtained in the last few years. Yeah, and there is no actual root here. So x equal to 0 and xy equal to 1 doesn't have an actual root, but you can still talk about an approximative root. So given given a list of circuits, is there a common approximative root? Right? That's the question. So this is a list of problems which are interesting, and some of them are open. So more problem statements or concepts. So this algebraic dependence which I mentioned before, right? These three polynomials, whether they are algebraically dependent, this you want to do when you are given a list of circuits in the input. So given, let's say, 2 circuits in multiple variables, n variables, are they dependent, algebraically dependent? This again is a question which we have not been able to solve completely. It is solved for characteristic 0, but for prime fields, it is still open. Then there are questions to do with morphism. So for example, you have 2 algebras, 2 rings, whether they are isomorphic, or if you have, whether say you have 2 circuits, whether they are isomorphic in the sense of linear transformation. So those questions are open questions. They are actually related to the question of graph isomorphism. So we know that these questions cannot be very easy. But these days you know that graph isomorphism has been put in quasi-polynomial time. So even that kind of development we don't have in morphism problems over algebras. There are root counting problems. So you are given a polynomial, count the number of roots. Okay, so for example, this here I want to count the roots of x square equal to 0, mod p square. Mod p, I know that it has only one root, but mod p square, it has many roots. So given a polynomial, even it could be univariate. So mod p raised to k, how many roots it has. Or given a set of polynomials, how many roots over the finite field it has. So these questions are related to something called zeta functions. So zeta function is basically, it counts the roots in a tower of rings. So it counts the roots mod p, then mod p square, then mod p cube, mod p to the 4, and so on till p to the infinity. So for each of this arithmetic, you count the roots, and then you store it in a generating function that is called the zeta function. And then you can ask whether I can calculate the zeta function in practice. So we have an algorithm which was, we have the first algorithm which is fast, deterministic polynomial time, works for univariate polynomials. It calculates the Igusa zeta function. And we have similar results also for finite fields, which is called Hassa-Wales zeta function. So there is a bunch of, much of math is actually focused on studying zeta functions of some type. The most famous being the Riemann zeta function, which is for prime numbers. But there are algebraic variants of it, so we study those in computer science. Yeah, any questions till now? How much time do I have? 5 minutes? Okay. Yeah, so I'll move to the last chapter, but you could ask questions about whatever I've said till now. Okay, so then I move to now engineering. Some applications of these in practical settings which I've been interested in. So first is in cryptography. So cryptography builds on, most successful cryptographic systems are actually built on algebra. So for example, RSA is built on number theory, which is modular arithmetic. So computing, again, working with primes. So the identity you saw, which said n is prime. So discovering primes, testing them for primality, and then doing exponentiation, modulo primes, and so on. Then the reason why RSA is secure is because there are no fast algorithms for factoring integers or for computing discrete log, right? So much of your internet security, WhatsApp, bank apps, etc., HTTPS, all of this is based on RSA, which is based on ultimately the hardness of factorization of numbers. So that is what your life actually depends on, right? It depends on just modular arithmetic. But there are fancier cryptographic systems which use curves, mostly elliptic curves. So there is elliptic curve cryptography, where there are two questions. So given an elliptic curve equation, like y square equal to x cube plus 13, modulo, I don't know what is the modulus here. Modulo p. So you are given this elliptic curve modulo p, and you want to count the number of roots it has. So how many x comma y's which are in fp in the field of p elements. So that is one important question which has a deep theory behind it, which is used in these operations that elliptic curve crypto system has. And second question is, which is a bit harder, and it has been used in many recent cryptographic schemes. It is to do with the isogeny of elliptic curves. So you are given two elliptic curves, and isogeny is kind of an isomorphism, but it's defined more geometrically. So there are isogeny-based systems. Yeah, so the thing is that some of these systems, they will survive a quantum attack, and some of them will not. Okay, so in particular, RSA, both the problems of integer factoring and discrete log, they can be solved by a quantum computer in polynomial time. So if a quantum computer becomes practical, let's say after 50 years, then you cannot use any of these apps which are based on RSA. So you will need a completely different system. So such systems are called post-quantum crypto systems. So what you have to do is you are not allowed to use abelian group hardness questions, because usually the questions about abelian groups, they will be solved by quantum machines. So you have to use more complicated geometries. So for example, lattice is one. So questions about lattice and finding vectors, shortest vectors or closest vector problem, SVP, CVP, those questions are provably NP hard. And NP hard questions are not supposed to be any easier on a quantum computer. So you have to rely on those computational algebra problems which are actually close to NP hard, even approximate, NP hard to approximate. So these are isogeny-based questions or lattice-based questions. So this is or even, I'm also interested in this multivariate roots of multivariate systems. So that question is again NP hard, and crypto systems or digital signatures based on them are unlikely to be attackable by quantum computers. So yeah, so these are systems which will survive the quantum hype. Okay, and finally, what happens in AI? So in AI, it is kind of these algebraic circuits because it's a heavily parallel computation which happens. But the gates are not as generic as addition multiplication, which I study. They are more specialized. So overall architecture, there is an input layer, there is an output layer. So input is your data, and output is are your tags. So your data is tagged with answers. and you want to learn these questions, given these questions and answers, you want to learn the model, what sits in the middle. So those are the hidden layers. So for example, these days LLMs are using around 100 to 200 layers, and they are seeing that going further doesn't help. So it's kind of a depth 100 circuit, you can think of it that way, but the width is very wide. So in 100 layers, they are packing around 100 billion to 1 trillion gates or nodes. Okay, so what are these 100 billion gates? So these 100 billion gates, so you can see it here in the dance of the neurons. So these are the various neurons. So these are the gates which are used in these 100 billion nodes, which is distributed over 100 layers in an LLM model, for example. So the first one is sigmoid. It is the most famous one. So it is 1 upon 1 plus e raised to minus x. So it's a real algebraic function. And it has an interesting history. I mean, why do we use this? Why do they use this function? So this is actually related to just some concept in statistics or probability in statistics. So it is to do with, simply probability is equal to odds upon odds plus 1, and then x, if you set as log of odds, then it will give you the probability. So it is basically coming from logistic regression. And so this is a nice function they use in statistics. And so ultimately, I think these people decided that why not just collect all those functions and put them in an arbitrary way in the hidden layers and learn the parameters. Okay, so these functions are, they are not just calculating answers 0, 1, but like algebraic circuits, they are computing a fuzzy information between 0 and 1. So they are actually calculating with real numbers. And then in the end, they do some truncation and they give answer of yes or no. In fact, they are calculating in the case of LLM probabilities, which are again just real numbers. So as you prompt a sentence, and then what LLM does is that it calculates, it gives on the whole dictionary, it gives a probability distribution, that after your prompt, how is it that the dictionary is distributed? Like which word has the highest probability, then second highest, third highest, and lowest probability, and then 0 probability. So it just when you give a prompt, the dictionary is actually reordered according to a probability distribution that is calculated, and then the most probable answers are given to you as answer after the prompt. So in that business, somehow, and we don't completely understand why, but somehow these functions, if you put them instead of addition, multiplication gate, it's more helpful. But the impact you will see only when you have gone to that extent of training, like at least billion parameters, at least billion gates or more. So below billion, you will only see random answers. That's not very helpful. So somehow some magic happens after you have trained on 1 trillion words, 1 trillion gates. Okay, then some magical intelligence appears in the system, in this ARN. So this is from statistical point of view. So it's actually like an algebraic circuit model, but there is a deep statistical point of view inside, which is making it work. Yes, these are also called, so in the literature, these are called activation functions. And in the algebraic circuit, they are gates. So so I have a center, and now we have created a school in IITK, which I should plug in here. So there we have been developing products, AI-based products for government agencies, which we train on real data, which can be data of citizens or of systems, very big. And then these things actually get deployed and used. So I think that's it. Yeah, thanks.
Fantastic talk. Thank you so much, Nitin.
Thank you.
Now it's time for a few questions.
Yeah, the audience was very quiet.
Yes.
Maybe they didn't get enough coffee.
I think we have the first question.
Hi, thanks for the talk. So somewhere in the talk, it was mentioned that, let's say, some machine learning system can solve like problems for some instances of interest, let's say, which arise in practice. So from the perspective of a person who is trying to design algorithms, like how do you think we should model these kind of instances? For example, instead of making an algorithm which works nicely on all kinds of inputs
Right,
of a
yeah.
fixed length, some more fine-grained kind of view on problem instances.
Yeah. So it's a great question. And any instance of your question, when you find an answer, you create a startup. So that's how it works. There is no general idea here. And usually you will find a client who will give you a problem, and when you will train a model for that and you will become good in it, it will be your startup. And then when you will try this model on some other problem, it will completely fail. So then you will have another startup. So yeah, it's basic because these problems or these instances, as you call them, these are generally, we are interested in only human-generated data. So whatever humans are doing, there is some statistical pattern, but it's very hidden. So what was happening in the 70s and 80s in ML literature, when, for example, perceptrons and other things were invented, so that was only the first layer, or maximum the second layer. So that was still understandable or interpretable in terms of this sigmoid, for example, that it is just odds upon odds plus 1, and you are the system is trying to learn the odds in the first layer. But now, since there are 100 layers, it is just statistics distributed everywhere, and it's not clear which layer is doing what, and certainly which gate is doing what. So some magical statistical properties are being stored in these neurons. Interpretation is hard, but surely it exists because it works. So the proof is the proof is in the pudding, as we've always known. So I hope that answers your question. It's not a detailed answer. I guess I evaded your question. Did you want to study it theoretically? Did you mean theoretical study of it?
For example, let's say I want to solve, for example, SAT solvers, right? So obviously, somehow they are able to, take care of instances up to thousands of variables. So like, what kind of 3-sat instances, for example, are easy to,
So I
something
guess,
along that way?
Yeah, I think I took you in the startup direction, but if you just want to study it theoretically, then per problem you have to create a theory. So the theories which apply to many problems, that generally, I think they have already been invented. So to do something interesting, you have to make your theory a problem specific or domain specific, and there are many distributions that people invent for a particular problem. So in the past, like hundreds of years ago, this Gaussian distribution was invented to study the practicality of mean and variance in any experiment. So that was a distribution which Gauss invented. And then Poisson invented something which is a more discretized version of Bernoulli. And now you can invent more complicated distributions. But it will apply to your problem. Yeah. So you need an insight from a problem.
Hi, I'm Christian, a PhD student here. So I have two questions. First is you discussed this technique of bootstrapping, and then you discussed that you can use like tiny circuits and some squares to like prove. So are there any like efforts in trying to use those techniques for like training deep neural networks? So you only train a certain class of functions, but it still extrapolates to like larger techniques in bootstrapping.
No, but what will the neural network achieve? Because the question there is to prove that no small representation exists. So if it doesn't exist, the model will not find it.
So,
So we are actually after a proof instead of a model.
okay.
Proof of non-existence.
Okay, it's not a proof of existence for like a smaller class.
No. Existence is not interesting for us. So because that's a lower bound question. So VP not equal to VNP is the question of something not existing.
Okay.
So something which doesn't exist, which has not been shown to an LLM, how will LLM help? That's the philosophical question about intelligence in LLM, right? That what LLM has never seen, what humans have never told LLM, how can LLM guess?
So, and my second question was, so you talked about activation function, which are like real algebraic and sigmoid and exponential. But has there been any work on like polynomial activations and how scalable they are? Like, is there any difference in capacity theoretically, or is it just like practically they don't work? That's why we don't use them.
You mean you want to, instead of these activation functions, you want to use something else?
Polynomial activation functions.
See, ultimately in real computation, everything is a polynomial and everything is an integer.
Yeah, but then these
So
are
they are
approximated
approximated.
Taylor series,
Correct,
which may cause some like, so. I mean,
No,
if-
hardly. Because Taylor series, the later terms will not matter.
Okay, got
So
it.
these things ultimately become polynomials. So, yeah, but if I write the polynomial version of sigmoid, I think it is not insightful. Because sigmoid has an insight from some PropStat course. So, which is why I think putting sigmoid, they put sigmoid instead of just the polynomial. But there is a polynomial, of course.
Okay, got
You
it.
can just approximate by a polynomial.
Got it. Thanks.
Hey, thank you for coming and giving the talk. I have two abstract questions. My first question is, yesterday we had a panel discussion called how to do good research, right? So I wanted your opinion on what is your advice for PhD students to do good research? My second question is, can you walk us through how did you get excited about all this? Can we go back like 30 years, 35 years in your life and tell us, look,
you are
how
going,
did...
you are going beyond the scope of the talk.
No, but I think it's very interesting to see people like you do this very, very foundational theoretical work when there is so much of hype on so many other things.
Yeah.
So I really wanted to understand where your interest is. How did you get this?
So first question is probably more relevant for the PhD students. So let me answer that first. So I was telling somebody yesterday after this job fair that to work in theory, I mean, actually it applies probably to other areas also, but especially in theory, you need a good mentor. Because, I mean, so maybe related to that question of good instance, input instance. I mean, there are so many input instances, you will just be seeing all of the input instances and never know what is important. So a good mentor has done that exercise and failed early in life. So there is some experience already with the mentor. So with a good mentor, you will be given the right input distribution or the right problem statement or the right area at least where, because as a student, what is your goal? Your goal is to identify a problem which is interesting to others, to you, and which is solvable in 3-4 years. Because I can give you 100 problems which will never be solved in 100 years. I have a list of those problems, but that you don't have enough, I mean, you have only finite amount of time in your life. So you have to satisfy those 3 conditions that, see, it's interesting for yourself, it is interesting for others, and it is solvable in 3-4 years. So for that, you need a mentor. So a good mentor will help, and then the two of you could look at these 3 points and identify problems and then iterate, because maybe there will be a problem that you will think is interesting, but it will be solved very easily. Then you have to iterate, you have to go back and look at some other problem. So I think it's just these 3 points and then iteration. So that's all which happens. But obviously when you iterate, you have become wiser. So there is wisdom which I am not able to quantify for this audience. There is some wisdom you learn from the first iteration, then you apply it then you do second iteration, you get wiser. So that wisdom you have to basically collect and record in publications. So if you focus on having some publishable quanta output, it will be good. Because students, PhD students actually don't appreciate, I mean, at least I did not appreciate in my early years, that writing it in a formal way so that other people can read gives you many more ideas. So you will think that you have written something and now it is dead. But actually that is not the case usually. When you write it, you will actually get more ideas. And when you present, like I present here, I get even more ideas. So activity is important. Yeah, so you have to be active somehow. This is more important in theory, because in theory, if people tend to just think, but thinking is not going to take you very far. You also have to act, and you have to, so basically you write, you publish, you present. So does that answer the question, or? Okay. And the second question, how did I get interested? Oh, so my problem always has been that I was only interested in one thing. So I had nothing else to do. So I was very focused since childhood, or at least class 8, that I'm interested in math and a certain kind of math. So all my greedy algorithms were to optimize this metric, that how do I spend all my time on my interests. So everything else was just a diversion. Which is not the case with most of the students, and students here or people here are even more dynamic, so they will be interested in 10 things. Now, how do they choose one thing? That I have no answer, because I have no experience. I have always been interested in only one thing, and so everything else, I take it in that direction. So if you have it in that, if you have this quality in you, then it will be easy. If you are interested simultaneously in 3 things, then I guess you just have to find out yourself what is the most beautiful thing you like amongst those 3. And probably one of them will be will have most beauty. And so, because that is what is long lasting, so your interest will continue in that for a longer time. Other things you can do to earn money, to get rich, to get famous. So there are many things you optimize, right? But for longer run, you will need to pick something which you like, which you think has the most beauty. Okay, thank you.
Thank you so much, Nitin. And for this news headline, for the last line, I always wanted to do one thing. Rest is a diversion. On that note, we'll close the session. There's refreshment outside, and we'll come back in 15 minutes. It's a short break, and then we'll have lightning talk session from the PhD students. Thank you.
Thank you.
It is going to be a fast forward and always exciting. To conduct this session, I may invite the Sarani. Please come up and take it over to you. Thank you.
Hello, welcome everyone. So we are going to start the lightning talk. There will be 60 talks today in the first day, and there will be 60 more on the second day. Though the posters of all of these 120 people should be up on the poster boards, which are just outside this auditorium. So if you have not put your posters yet, please, I request you to put your posters now, like after the lightning talk, once you are done with it, and then we can continue from that. So now, for the first session, I'm going to call the the people with the serial numbers 1 to 10 to gather around, and then we'll go from batches of 10 to go forward. Please don't wait to call your name, because it's not possible to call your name and then you come up on the stage, then you give the talk. It is going to be taking more time. So with respect to time, please be aware of your schedule number, and please be present near the stage. So let's start. Okay.
Okay. So the first talk, I want to invite Sumit Agrawal. Please come on the stage. Yeah, please, all the rest 9 students can make a queue near the stage so that it will be easy for, yes. And it is just a 45 seconds, so we need to hurry it up. Okay, you start.
Hi. Hi everyone, my name is Krishan. I'll be presenting about Neurus 2025 work. So in nature organisms, so there's an animation, it doesn't work. Anyway, so in nature organisms switch attention across tasks in milliseconds, like this butterfly, sipping a nectar by balancing on the stem. But we don't fully understand the neural mechanisms behind this, but we do know that one brain manages it all. So in AI-related challenges are studied as DIL, CIL, and DG, illustrated here by this butterfly in 6 different visual domains. But no single framework tackled all these 3 at once until now. So Mira, or Neurus 2025 framework, actually achieves state-of-the-art across all these 3 settings by leveraging memory to dynamically retrieve interest-specific model parameters to facilitate rapid task switching. So we equip transformers with Hopfield memory, enabling them to dynamically mix information from different domains, so even at test time and on a per input basis. So green is test and red is training, and these numbers indicate mixing strengths. So, but how do we leverage this memory? What do we store? What do we retrieve? How do we integrate into architecture? To learn more about this, please visit our poster 105. Thank you.
Hi everyone, I'm Manashini, PhD student from IIT Hyderabad. We work basically on improving the scalability of blockchains. So one of the major bottleneck is transaction execution in the block. So for that, there are a lot of DAG-based schedulers where dependency information is used to do parallel transaction execution. So in this work, what we did was we used coloring of the graph to rearrange the transactions in the graph so that we can extract maximum throughput from the transactions that are present in the block. So we do achieve 2 times speed up on average compared to the current parallel transaction executions. But if you want to know further details, you can come to my poster 71 and we can discuss. Thank you.
Good morning, everyone. My name is Yashira Stogi. I am PhD student in IIT Hyderabad. So I am working on Byzantine fault tolerance in GPU-inspired shared memory model. As Byzantine fault tolerance is very much explored in CPUs, but there is very less work when it comes to GPUs. As GPUs has very unique property, like its feature, like within a warp, all the threads work in synchronous fashion, but across the warp, they work in asynchronous fashion. So please do visit to my poster 62 if you are curious to know how we utilize this property and make it work. Thank you so much.
Hi everyone, I am Amit Sharma, PhD student at IIT Hyderabad. Today I am going to present my work titled Efficient and Accurate Tensor Compression or Recursive Sketching. High order tensor appeared naturally in multi-model, but computing inner product scales exponentially with the tensor order, making it infeasible. Existing work compresses tensor while preserving inner product, and their variance grows exponentially with the tensor order. Our idea is simple but powerful. Exploit the inherent Kronecker structure in CP decomposition and apply recursive sketching. Our method preserves norm and pairwise inner product, and our work completely removes the dependency on tensor order and also improving runtime. Later we extended this method to DT decomposition. Our work is recently accepted at AI Stat 2026. If this sounds interesting to you, please come to our poster. We will be happy to give details to you. Thank you.
Participants from number 11 to 20, please gather near the stage, please.
Hi everyone, my name is Abhishek Gupta. I'm working in AI Center of Excellence Healthcare, which is funded by Ministry of Education. So basically our work focuses on coronary artery segmentation from CT coronary angiograms, which is a crucial step for the diagnosis of coronary artery disease, supporting stenosis and flow analysis. So in this study, we have compared the two NN unit-based deep learning models, which are actually trained on the publicly available image case dataset, where we have 100,000 CTCA annotated. So we have trained it on 800 images, and we have kept 200 images for testing. The baseline model was standard 3D full resolution NN unit, while our proposed approach used ResNet encoder unit, which includes further deeper residual encoder blocks for better feature extraction. Our work shows that residual encoder unit loss consistently outperforms the base model, achieving a die score of around 0.84% compared to the 0.82%, along with the improved IOU and lower volume error. So this work is accepted in European Congress of Radiology, Vienna. I'm going to present it in March. And if you are curious about this work, please do visit poster number 99. Thank you so much.
Hi everyone, my name is ARCS, and here I am presenting our work on level-free adaptation of Indic printed OCR. So OCR is a cornerstone technology for document digitization, but often it struggles in domain shifts scenarios, like if you have a different fonts from your training data set or physical damages. And here in our work, we propose a semi-supervised OCR method that adapts and improves in new domains, but it does not require human annotations at traditional methods. It leverages its pre-trained model and without any human annotations effort in the loop. And in this work, we have benchmarked our method on both Indo-Aryan and Indo-Dravidian languages, and the results reflects that it has a capability to improve on other languages too. And we are happy to discuss more on this on our posters, and you can visit with us. And do visit our posters number 100 to discuss more on this. Thank you.
Hello everyone, our poster revolves around the Indus Valley script civilization, and we have developed one tool which deals with different kind of GitHub repositories. So we have developed one tool which compares the 7 scripts with the Indus Valley script, and it basically deals with the SparkQL query. So if you have a keen interest in understanding the different kind of knowledge graph as well as the ancient scripts, you can visit us at 119, poster 119. Thank you.
Hello everyone, I'm Neha from IIT Madras. So my poster is about this problem called range avoidance, which is as follows. We have a multi-output circuit with fewer inputs and more outputs. So there's some string that does not appear as an output of the circuit. And the problem is to find one such string. And why is this problem important? Because it connects a lot of central problems in complexity. For one consequence of this would be, a polyrhyme algorithm for this would de-randomize BPP. So there are several approaches for solving this. We introduce a novel approach using hypergraphs. So if you are interested about this, do visit the poster 50.
Hi everyone, I'm Priyadarshan from BHU. I'm presenting an approach to protecting one of the most vulnerable network, Internet of Medical Thing. As medical devices become more interconnected, they have become more primary targets for cybersecurity attacks like DDoS. This can be literally endanger the patient's life by disturbing the health services. The existing traditional system failure to get the high dimensional data. And for this solve this problem, we introduce one hybrid model, MLP-GRU. In our model, one branch of MLP handled the static traffic patterns, and GRU branch handled the temporal patterns. So we tested by using one CIC-IOMD data set. And if you want more details, you can visit to the poster number 37. Thank you.
Hello everyone, I am a research scholar at IGT2W and an assistant professor in Maitri College, University of Delhi. So I work in the area of biomarker prediction using explainable AI. Diabetes is actually a growing epidemic, and identification of crucial biomarkers which help us identify it early and prevent progression into micro and macrovascular complications is very, very important. So my work revolves around identifying such biomarkers So do visit my poster number 22 if you are more interested in the topic and how to create trustworthy, transparent models for diabetes detection, which provide insights about the biomarkers. Looking forward to seeing you all there. Thank you so much.
Good morning, everyone. My name is Amresh Kumar Singh, and I am a PhD scholar at IIT Jodhpur. My work focuses on abstract visual reasoning, particularly solving Raven progressive matrices, that is RPM, using deep learning. These problems require understanding hidden relational and compositional rules purely from visual structures without any language. So existing models often overfit surface patterns and struggle under distribution of shifts. To address this, we proposed a model, PatNet, which integrates PAN for multi-scale feature learning with iterative deep predictive reasoning blocks that model relational dependencies between context and answer panels. So our approach achieves state-of-the-art performance on all the variants of Raven. Thank you so much.
Good morning, everyone. I am Vivek. I am from IIT Hyderabad. I am a PhD student there. So my research work mainly focuses on 3D scene understanding and editing. So we generate a particular scene graph for every scene to understand how the orientation of objects is. And based on that, we'll be performing few edit operations like insertion, deletion, and replacement. So using the generative AI models, we'll be generating new objects that are to be replaced or to be added into the scene, and also we'll find the optimal location where these edits to be performed. So we have designed an algorithm for that, and we have few comparisons with recent nerve-based methods, and our method was performing better. So to know more details, you can visit the poster number 102. Thank you.
Good morning, everyone. So in combinatorial multi-arm bandit, at each timestamp, learner basically select a subset of arm and get feedbacks into two forms. The first one is semi-bandit feedback, where the reward of each arm is observed, and in full bandit feedback, where we only observe the cumulative reward. If learner only focus on the reward maximization, it will lead to unfairness and biasness, right? So we need to select arms in such a way that everyone should select proportion to their merit. So in full bandit kind of feedback, when we don't even know how much each arm is contributing, how do we ensure the fairness? So if this question interests you, please visit our poster at number 23. Thank you.
Students from number 21 to 30, please gather around the stage. Okay, next.
Okay. Good morning, I am Somnath. So we propose IP3O, a new approach to safe RL that incentivizes safety before constraint violations. So this leads to more stable learning and better convergence, as we have seen, and also better reward and safety trade-offs. So we have performed experiments on safety gymnasium and Mujoko tasks and seen good results compared to other contemporary algorithms. Please visit post number 12 for a more detailed discussion. Thank you.
If Hari Chandana from IIT Hyderabad is here, please come near the stage. Your talk is next. Okay, next.
Hello, myself Abhiram from, myself Abhiram, I'm from IIT Jodhpur. So I'll briefly present our work, model parity aligner. So the core motivation of this is you have a large vision language model which performs better but has higher computational requirements, whereas small vision language models are perform subpar to the larger counterparts, but they are faster in inference and training. So we wanted to enhance the small vision language model so that the performance of the small model matches the larger model. So we try to achieve this without the requirement of human labeled data. So inspired from our paradigm of a teacher-student, where teacher teaches the student of the stuff that student doesn't know, right? So I don't want to teach something that student already knows. Right? So here, the large model acts as a teacher and the small model acts as a student. So we try to identify a knowledge gap between these two models and train the student model only on those knowledge gaps. So to know more, please visit the poster. Thanks.
Hello everyone, my name is Abhishek. This work is on game playing agents. So many recent game playing agents using a lot of image data have memorized how to play in different situations, and they have worked pretty well in defeating human world champions and achieving superhuman performance. However, they are categorically different from how a human would play a game, and they have some disadvantages like being very sample inefficient and not being able to play game variations. We take a different route here. Instead of feeding a lot of image data, we pose this problem from the lens of a human playing the game for the first time, and this has few advantages like ability to play on different game variations like changing colors and all. If you would like to discuss more, please drop by our poster 110. Thank you.
One more announcement. Anup Kumar from ISI Kolkata. If you are here in the auditorium, please come near to the stage. Thank you.
Hello everyone, I'm Anakha from IIIT Hyderabad and I work in Sanskrit Computational Linguistics. My paper is a survey on Sanskrit Computational Linguistics and the digital infrastructure for Sanskrit. So what the survey does is catalogs all computational tasks undertaken for Sanskrit, right from word segmentation to poetry analysis, Ashtadhyayi simulation, and so on. It provides a brief background on how the subfield of Sanskrit Computational Linguistics itself came into existence. It highlights the challenges in processing Sanskrit, such as phenomena such as Sandhi, Samasa, and so on. It summarizes the digital infrastructure that is there for Sanskrit so far, and also the resources and toolkits that are there for Sanskrit. It also identifies the gaps and future directions that are possible in the subfield of Sanskrit Computational Linguistics, and also talks about the disadvantages in each task. So what basically it does, it serves as a single entry point for anybody who's looking to venture into Sanskrit Computational Linguistics and wants to know more. So my poster number is 118. If you'd like to discuss, please visit. Thank you.
Hello, I am Amol Kulkarni from PL Government College of Engineering, Latur. I am here to present my portable 3D biosensor, ECL sensor, which works on principle of ECL. When chemical reaction happens, light is emitted and that will be captured with the smartphone, and the brightest image will be taken with the computing algorithm, and the brightest image pixel brightness will give idea about the amount of analyte, glucose or lactate present in the sample. Okay. For more detailed discussion, please visit poster number 28. Thank you.
Quick announcement for Garima Modi from IIT Delhi. If you are in the auditorium, please come near the stage. Your talk is next in the line. Thank you.
Hello everyone, I'm Venkat. I'm a PhD student at IIT Hyderabad. So in this work, we address the problem of binary similarity, how we can determine if two binaries are similar or they do a similar function, and can you search for a given binary code among a large pool of binary codes. So here there are several problems that we address, like how do you compare binaries compiled by using different compilers, using different compiler optimization flags, targeting different architectures, and we achieve the state-of-the-art results while highly improving the scalability. If you are interested in the approach, if you want to discuss more details, please do visit our poster. Thanks.
Hi, I'm Sumukha Bharadwaj. I'm a PhD student at IIT Tirupati. So this work is essentially about a problem called PIT, or polynomial identity testing, where as input you are given an n-variate polynomial over a field f, for example the real numbers, and you have to determine whether f is identically 0 or not. So that is, no matter what values you plug in for the variables, the polynomial always evaluates to 0. So it has a wide range of applications, and this problem has been widely studied. So our result is that we give a polynomial time randomized algorithm with a non-commutative twist. So to know more, please talk to me. Thanks.
Hello everyone, my name is Ranjita and I'm a PhD student from IIT Hyderabad. I work in the area of systems and network with Dr. Praveen, and my area spread across programmable data plane and host network stack monitoring in the cloud and congestion control for RDMA Rocky B2 networks. So this poster falls under programmable data plane that actually brought in a paradigm shift in how the networks operate. So from being a passive packet forwarder, the programmability transformed the network devices to intelligent traffic control systems that could achieve enhanced performance. However, the same programmability also opened up a surface that made it vulnerable, and in this work we come up with a framework that would help mitigate the attack for these systems. If you're more interested to know more about the work, please drop in at board number 30 at my poster. Thank you.
Hello everyone, myself Garima. So have you ever wondered that you have multiple applications co-executing in your system, but most of the applications are working fine, but one application is hanging? Like I have faced that. So there are many reasons why this could happen, but one of that is that all the applications are trying to contend for your shared memory. So we try to propose a contention management scheme for shared caches, and do visit my poster number 59 if you want to know more in detail about it. Thank you.
Thank you. Student number 31 to 40, please come near the stage. You are next in the line. Thank you.
Hello, myself Devajyoti Majumdar. I am from ISER Bhopal. My work is around code mixed humor and sarcasm. In this setting, as we know, the LLMs are resource constrained in a code mix setting. That is why we propose an idea of native sample mixing and multitasking. As shown in the slide, this is a multitasking architecture where we use the auxiliary task, and we see an significant improvement in the areas of low context length as well as the misspelled words. If you are interested about this work, please visit our poster, poster number 66. Thank you.
Hello everyone, I am Dipesh from IIT Kanpur. My research focuses on hardware security, particularly on timing side channel attacks on network on chip architecture. So NOC-based architecture are efficient on-chip interconnect to connect different components on system of chip, but their shared hardware nature is vulnerable to timing side channel attacks. In our work and tracer, we basically exploit the contention between the packets of AES and attacker to infer the cache hit miss behavior of a L1 private cache that is being used by the AES. And as a result, we are able to reduce the key search space from 2 raised to power 128 to 2 raised to power 8. If you find this work interesting, please visit me during the poster session at poster number 79. Thank you very much.
Hi everyone, I am Haradhan Ghosh from NISER Bhubaneswar. Today I'll talk about my research on UMAP. So this work is accepted on CC Grid in the last year. And in this work, we design a UV-assisted authentication protocols for Internet of Vehicles. Because there are many authentication protocols which are overhead and there are some security flaws. So to manage the security and the overhead, we present this work. So to more about the technical details of this work, please feel free to visit my poster, and my poster number is 26. Thank you.
So hi all, I am Rajdeep Ghosh from IIT Kharagpur. I work with Professor Mainak in the field of usable security, looking mostly in the security-related concern in open source ecosystem. In our recent work in Usenix Security 25, we looked into NPM, the largest JavaScript package manager, and we uncovered more than 100 times security issues that do actually exist based on the SOTA methods of tags. Using mixed method studies, we also uncovered the various factors that help in resolution of the security issues. We have our poster at poster number 72, where we can talk and discuss more about the results and the implications. And apart from that, I'm also working on building systems that help developers to help and resolve the issues that are reported effectively. Thank you.
Hi everyone, I'm Gunang. I am a PhD student at IIIT Hyderabad.
So I'll be presenting a recent work which was accepted at ISIT last year. So this is about the conditions for equality to hold in fractional subadditivity of submodular functions. So submodular functions are set functions that exhibit a diminishing returns property, and they satisfy subadditivity, that is the value of the function of the ground set is at most the sum of the function values over any partition of that set. And this property naturally generalizes to fractional partitions, and this generalization is known as fractional subadditivity, which has many applications. So in our work, we provide the necessary and sufficient conditions for equality to hold in fractional subadditivity, along with some applications. So if any of this sound intriguing to you, I encourage you to stop by my poster, which is number 45. Thank you.
Hi everyone. So language models struggle in medical domain, not because they lack parameters, but because they lack the right vocabulary. Medical words are often broken down into multiple chunks, which hampers the encoding of the word and also degrades the generation quality. This over-fragmentation stems from the phenomenon of vocabulary mismatch. Now, in our work, which is accepted in the findings of ACL 2025, we benchmark the efficacy of vocabulary adaptation strategies to mitigate this issue of vocabulary mismatch, with a special focus on instances where we see higher concentrations of this over-fragmentation and presence of domain-specific words. To know more about this work, please visit my poster number 83. Thank you.
Hi, my name is Genia. I'm from IIT Gandhinagar. I've recently submitted my PhD thesis. So during my PhD, I worked on the broad theme of complexity theoretic or algorithmic study of problems defined on graph classes that are defined on groups. If you ask me why this graph class, why this is interesting, in my defense, I would state one of our recent results that says that if you take any isomorphism invariant problem on these graph classes, they are not hard. And in here's poster, I'll be talking about one such problem, the graph isomorphism problem of some graphs defined on groups. This is based on a paper published at FSTTCS 2024. If you want to know more about the results or anything around it, please visit my poster number 43. Thank you.
Quick announcement. Student name Pramit Bhattacharya from IIT Kanpur. Please come near the stage. Your talk is next in the line. And also student from 41 to 50, please gather near the stage. Thank you.
Okay, good morning. I am Sandeep from IIT Jodhpur, also associated with Flame University, Pune. We have been actually working with understanding how to interpret the music sheets, basically, which is difficult for a beginner to learn. And we have come up with a framework which basically understands what are the music notations, what are the durations, which the keys has to be pressed. And we have integrated this vision part with the AR/VR part in order to give a more realistic experience of learning music. Okay, if you want to further query about my work, you can come visit my poster 111. Thank you.
Hi everyone, I'm Kinshuk from ISC Bangalore. So more often than not, you want language models to abstain or refuse to answer things that are not meant to be answered. But as a developer, you have a few ways to achieve this goal. But how do you choose what's best for you? So as it turns out, existing benchmarks meant to study refusal don't help you here, and you end up comparing apples to oranges. So in order to avoid this, we built a benchmark select, which leverages a knowledge graph. So apparently a knowledge graph gives you a nice way to compare these techniques and offer a fair comparison. So in order to learn more on what we find and how a knowledge graph makes all this possible, I encourage you to check out our poster number 86. Thank you.
Good morning, everyone. Myself, Malya from IIT Ropar. So imagine multiple people recording the same live event on their phones. So we have different devices, different noise levels, and different start time. So how do you precisely align these audio recordings? So to know more about this topic, please visit the poster 107. Thank you.
Hi, everyone. I am Hassan from IIT Bombay. So in this, we propose a new setup in which we combine low-shot learning, domain generalization, and rejection of outliers at test time. Yeah, and this work also we propose efficient prompt learning technique as well as a new way of synthesizing open samples to create a better closed class boundary. And we also find that our model does well across the 5 domain generalization benchmark. To know more about the work, please visit the poster number 97. Thank you.
Hello, I'm Shruti Marlapnawar. So in this work, we had looked at linear convergence of decentralized Fed average algorithm for PL objectives. So if you look at the graph, I mean in practical settings, the decentralized Fed average algorithm, the convergence is much faster than what is observed in the theory. So in this work, our aim was to provide theoretical explanation for this linear convergence without making any strict assumptions like bounded gradient and bounded variance, which are generally made in this kind of work. We have also validated our theory on multiple data sets. So if you're more interested, if you want to know more about this work, you can visit my poster. Thank you.
Hi all, I am Vipin, a PhD scholar from IIT Kanpur. So while Netflix content creation team was developing new daemons for Stranger Things, their application development team was facing one such daemon due to scalability issue, and that daemon was fault sharing. So fault sharing is an artifact of invalidation-based cache coherence protocol like MESI, and we develop protocol extensions to fix fault sharing on the fly. To know more about our work, you can join poster number 63, leveraging cache coherence to detect and repair fault sharing on the fly. Thank you.
Hi, I am Prasita from IITM. I work in the area of DRAM security, and DRAM we know is a critical component in modern computing systems. And in DRAM, the data is stored in these tiny cells which are arranged in a grid of rows and columns, as you can see here. But as the technology scales down, these cells become tightly packed, leading to electromagnetic interference in the normal operation of the cells. So this interference made the DRAM vulnerable to a serious security threat, and we call it as row hammer attack. And row hammer attack exploits the fact that when a DRAM row is repeatedly accessed, it causes corruption of data in the nearby rows. So our objective is to design mitigation strategies against row hammer attack that has less impact on cost, performance, and energy efficiency. And for that, we propose a new technique called selective subarray isolation. And how we mitigate row hammer attack with this technique, please do visit our poster 74 for more details. Thank you.
Hello everyone, I am Pratik from IIC. GPUs have limited memory capacity, but even as applications continue to demand more and more memory. And this leads to the oversubscription of the limited GPU memory capacity, which has performance implications. In our Micro24 work, we showed how we could use static analysis to glean semantic information of GPU's memory access patterns and use this to provide almost close to optimal GPU memory management. So please visit poster number 65 if you are interested in discussing further. Thank you.
Hi everyone, I am Swarnalipa from ISI Kolkata. I work on Fourier analysis of Boolean functions over finite abelian groups. So here in this talk, I'll be talking about this problem. So we are given query access to a function f, and a function g is known to us. It is a promise problem. So the isomorphism distance between f and g is either less than equal to epsilon or it is greater than equal to epsilon plus tau. So the problem of this problem can be solved using m to the power 8 by tau to the power 8 many queries. And here m is the spectral norm of G. The previous known bound was m to the power 24 by tau to the power 24. It has been improved to m to the power 8 by tau to the power 8. And these results also hold for finite abelian groups. Thank you.
Hello everyone, I'm Sultanat from IIT Madras, and I'm here to talk about my work Tesla, which is not a car, it's a trusted execution environment developed for legacy applications. Why legacy applications? Well, because a lot of critical sectors like banking still rely on old legacy software that was written decades ago, and it's not very easy to change this software. However, existing trusted execution environments demand modifications, which makes them incompatible with these legacy applications. But with Tesla, we propose a trusted execution environment that is compatible with these legacy applications and also solves the limitations of existing TEs, like their huge performance overheads and their lack of support for secure I/O communication. And if you want to know how we have done all of this, please drop by my poster 73. Thank you.
Hi everyone, I'm Samida. I'm a PhD scholar at IIT Delhi. Our work centers around graph edit distance, which is a metric to quantify the dissimilarity between two graphs. It is an NP-hard problem, but finds applications in graph retrieval, cheminformatics, and more. Our work GRAIL leverages LLMs and automated prompt engineering guided by an evolutionary algorithm to generate programs for accurate cross-domain generalizable and interpretable graph edit distance computation. It was accepted in ICML 2025. To know more, please visit my poster, which is at number 87. Thank you.
Quick announcement, student name Shiv Bhushan from IIT Kanpur, please come near the stage, and student from number 51 to 60, please gather near the stage. Thank you.
Hi everyone, my name is Shombit Bosh and I'm a PhD scholar from IIT Kharagpur. I'm working in NLP, mainly in highlights and summarization, and I will be discussing today our recently published work in EMNLP, which is introducing Spotlight, a novel approach for generating captivating key information from documents. So mainly we are aware of two kinds of information distillation approaches. One is summary, which acts as a substitute for the main document, and the other is the one which we are actually working on, which is Spotlight, which acts as a gateway for the user. And my poster number is 114, and I will be happy to discuss further with you. Thank you.
Hello, myself Anupam from IIT Gandhinagar. So our work discusses an issue called commit spoofing in GitHub, where anyone in GitHub can impersonate it as you and can push any content on behalf of you without you being aware of it. So it also leads to other issues like typo squatting and email theft. So here we discuss why this happens, why the current solution is not good enough, and we discuss the alternative solution. So in case you want to make your GitHub account safe, kindly visit poster 70. Thank you.
Hello everyone, my name is Shivbhushan Tripathi, PhD scholar at IIT Kanpur, working on container live migration. This work identifies a core issue that causes a high service downtime during interhost live migration. Existing approaches that applies at VM does not work well for container because of the differences between VM and container. We address this with PC Live, which rebuild container at the destination in a pipeline fashion. This is inspired by VM migration, but totally redesigned for containers. With the PC Live, we reduce the service downtime. Please check out our poster for more details. Thank you.
Hello everyone, my name is Shubham Kumar Nigam. I am from University of Birmingham postdoc. This work is published from IIT Kanpur, and work is on legal AI field. And the name suggests legal segmentation, where we segment the legal document in structured format. So you can see in the picture, the document is very unstructured format, and our task is to how we can segment into the structured format. Then we can use in the several downstream tasks like summarization, prediction, and several other tasks also. So for the results part also, we have like a rhetoric llama which is trained for this specific task, and this work is published in NACL 2025. And this work also supported by the Bharat Jain as well as the Research I Foundation from IIT Kanpur. Thank you. Please visit our poster for more details in poster number 82. Thank you.
Hello everyone, I am Sastha Srinivasan. I am a PhD candidate at IIT Delhi. Primarily, my work involves around trying to find the gap between the technological elements and ecosystems and the way in which care is actually practiced in reality in India. In this work, we basically try to understand what is the digital divide that is separating technology used by older adults, and then we repurpose a smart TV so that we can natively take their interaction with it as a means to identify their health and well-being and social connectedness. If you find any of this very interesting, please feel free to reach around poster number 92 or anytime during the event. Thank you.
Good morning, everyone. I'm Siddhartha from IISc Bengaluru. I'm a PG student. So I have two figures to show you here. So this is a geometric approximation problem. So here you can see some circles and devices. So each circle represents the coverage area of a wireless transmission antenna, and each device icon is a user's location. So when a device lies inside multiple circles, there is signal interference, which we want to avoid. So the left figure shows excessive overlap among the circles, which is undesirable. So the primary question is, can we achieve better wireless coverage with less interference, as in the right figure? So we prove hardness results and design approximation algorithms for this problem. So please visit my poster 38 to see how geometry helps us design such interesting algorithms in this domain. Thank you.
Hello everyone, I am Kishalay Das from IIT Kharagpur. In my PhD, I worked on AI for, so in my PhD, I worked for AI for materials. So today I'll be presenting the work that is TGD MAT that got accepted in ICLR 2025. Here we introduced a novel approach for generating 3D materials using text-guided joint diffusion model. TGD MAT is the first model to connect natural language understanding and generation of 3D periodic materials. It outperforms existing state-of-the-art models in accuracy and generability with reduced training and inference cost. So please visit our poster number 2 for more technical details. Thank you.
Hello everyone, I am Shubhadeep from ISC Bangalore. So I'll be presenting my work, Partially Blinded Unlearning. This was accepted in AAAI last year. So unlearning is the problem of forgetting information corresponding to some subset of the training data. This is very useful in privacy preserving ML. So I will give you just some glimpses of what the poster will consist of. So you will see a Bayesian formulation for the unlearning problem, some theoretical upper bounds of the unlearning objective, and some metric-based performance evaluation with a scalable algorithm that is scalable up to LLMs. Also, what you won't be seeing is the epsilon delta guarantees for the unlearning problem, and the broader concept for getting it's not explored here. So if you are interested, please visit my poster at poster number 9. Thank you.
Hi everyone, I'm Shweta, PhD student at IIT Bombay. So I'm here to present my work that appeared at Micro 2025. It is Drishti. And in this, what we do is, from the last 2 decades, many replacement policies were proposed, and they all use a reuse predictor and a sample cache, but they evaluated themselves on monolithic LLC, whereas in many ecosystems we have a sliced LLC, and when we implemented it on sliced LLC, we see a decrease in effectiveness, and through Drishti, we try to find some missed opportunities and enhance the replacement policies on sliced LLC. And just to add, Drishti is one of the best paper candidates at Micro 2025, and if you like to know more about it, just visit at my poster. Thank you.
Hi, I'm a research scientist at Dolby Labs and a PhD student at IIT Jodhpur. This work was accepted in CVPR 24, and here the idea was the text-to-image models are seen to generate unwanted concepts like obscenity and copyright content. In order to unlearn those concepts, we noticed that the adjacent or correlated concepts are also forgotten. If you want to know how we manage that and all the and how we build the adjacency set, please visit our poster. In another work which was accepted at ICLR 2025, we observed that deepfakes and AI-generated content are now across all the modalities, image, videos, and audios. To solve this, we proposed illusion, and if you want to know more about it, please visit our poster at poster number 89. Thanks.
Hello everyone, I'm Vaishnavi Vishwanath from Chennai Mathematical Institute. This was work done with my advisors, Srivatsan and Patricia. So the setting is of model checking, which means that we are given a system and a specification, and the question is to verify whether the system satisfies the given specification. We work in real-time setting, which means that we have timing constraints to also take care of. If any of this sounds interesting to you and you would like to know more, please catch me or visit my poster, number 55. Thank you for your attention.
Hello all, my name is Hanuma. I'm from IIIT Hyderabad. In this research, we explored the motivation do LLMs adhere to the label definitions that we provide, or they solely rely on the internal representations that they are trained on. To understand this phenomenon, we conducted different experiments such as knowledge conflict, definition integration, etc. And as per the results, the interesting result is that when the domain is very general, model rely only on the internal representations, but when the domain is very niche, such as medical or finance, etc., it relies on the information that we provide. Please stop by the poster number 80 if you want to discuss more on this. Thank you.
Hello all, my name is Vijay. I'm a PhD student at IIIT Delhi. I will briefly explain the slim sense. So ISAC at its core defines the coexistence of sensing and communication by sharing the existing Wi-Fi infrastructure. However, the current system utilizes entire available bandwidth and sending the packet with a high sampling rate. By sending only 200 packets per second can reduce the communication throughput by 40%. So it is not practically reliable. So we ask a question that we can achieve this sensing with only a part of bandwidth. We design the slim sense in a way that we select the optimal resources for sensing and rest for communication. With the slim sense, we achieve more than 90% resource savings for communication. If you are more interested in practical ISAC and spectrum-aware Wi-Fi sensing, I would be happy to discuss more at poster 33.
I'm Sumit from IIT Kanpur. I'm currently doing my PhD in Praise Group and working in Qualcomm, Hyderabad. In this work, we took up a very interesting problem of generating what are known as what come next puzzles. Like over here, I show 3 puzzles. And it would be nice if, like maybe during the poster session, if you can tell me which one was generated by a computer and what was like synthesized by a human. So we explored the like traditional program analysis techniques, program synthesis techniques, and constraint solving to generate these interesting, like appealing puzzles. It has 2 parts. One is program synthesis, and the second part is that it's completely data-driven from user feedback. So do visit the poster and let's talk more on research.
Thanks to all the speakers and the chair. That was intense and inspiring for all the future researchers. Now we move forward and we invite our banquet sponsor, Mahindra University, to share few words. Professor Arya Kumar Bhattacharya, Dean Research, Mahindra University. Sir, please come to stage.
Thank you. So it's a bit of a transformation from hardcore technical topics to knowing about a university. Obviously, it's a bit of a shock. So anyway, so the topic is Achieving Research Excellence at Mahindra University, a glimpse from inside. And this is me. So this is a panoramic view of our university. There's a lot of greenery, but the greenery has a little bit reduced in the last few years. And this is showing the back gardens of MU, possibly more colorful. So I'll quickly go over a few slides which tells about some of the, you can say, facts and figures. So the purpose is to educate future citizens for and of a better world. I would just like to mention that the purpose of this presentation here for 15 minutes is really to encourage you to kind of see Mahindra University and then decide if you would like to be with us. That's the idea. Of course, I'm aiming for PhD scholars. So schools and centers. So we have got a number of schools and centers. The most important of these, I would say, is the Ecole Centrale School of Engineering. Important from the point of view that it is the oldest and the largest of all. Then we have other schools like School of Management. Then we have got School of Education, School of Law, then Center for Life Sciences, Center for Sustainability, and so on and so forth. So gradually they kept opening. And we have currently got, we are in the process of starting School of Liberal Arts. There's a Center for Artificial Intelligence and Center for Public Policy, which are in the process of coming up. When I look at, there's no point in going through all this entire list. We have got a whole lot of undergraduate programs, predominantly BTech, a good number of BBA-related, law-related courses as well. Postgraduate courses are primarily MTech and also a few MSc courses, then MBA, LLB, and MA in education. Then also Master of Design. And PhD we have got in almost all the branches. The number of students, obviously, as you see, the number of departments, number of centers has grown. So students also have increased from 1368 around 2020, when it just became a university. In fact, we are the first private university in Mahindra University, in Telangana state, sorry. And in fact, we started functioning from 2014 as a school of engineering. And 2020, formally, we were the first, you can say, the state university, which was granted as a university in Mahindra, in Telangana state. So 2021 onwards, now today we are at 2025-26, about 6,300 students, and the numbers are, as you can see, we're gradually increasing, and we propose to go up by about another 1,000 in this year. These are a kind of total number of faculty, which is, you can see, around about 350, and I would say about half of them are in engineering, and the major part of the others are management and law, also life sciences. I've actually got more detailed presentation on research activities, so I'll talk about it a little later. Now, we have got very decent gender diversity. Probably the least is in School of Engineering, where we have about 40% from the female gender. And overall, it is about 44%, because the other schools have got even higher percentage of females. We have got academic partnerships with a number of universities. Probably one of our most important partners are Central Supélec, that is you can say there's an École Centrale group of institutions in France, and Central Supélec is one among them. And so basically that's what we do. And many of our students actually go abroad for their last semester, or even the 7th and 8th semesters outside. And also many students come from outside to do their internship, full semester internship for research with our faculty in our university. Elements transversal to all undergraduate degrees at Mahindra University, irrespective of which branch they are doing it. So there is some degree of AI and training, AI training and data science, digital humanities, which includes media, communications, etc., entrepreneurial mindset, and also emotional intelligence and leadership. We also pay importance to communication, creativity, critical thinking. Then we have a number, as I was talking about, number of centers and schools. So we have Center for Entrepreneurship and Innovation, which is actually supported by this Atal Innovation Mission. Then we have School of Management. We have School of Law. So there are a lot of fine details which I'm trying to bypass, but just to be aware that it is there. The School of Design Innovation. And we have quite a few other schools also, which I'm not referring to here. So there's a School of Digital Media and Communications, which is one of our last major schools that have come up. The Center for Sustainability, in which we are just starting courses from this year onwards. And this video, actually, I'm bypassing because right now I'll not be able to play it here. When it comes to research, because I am trying to talk about research activities. So we have got totally about, from our start around 2015, we have got about 1,233 publications, I think. Yeah, you can see the cursor, sorry. So out of them, some are in journals, some are in international conferences, and some book chapters. We have got about 80 patents. And because École Centrale School of Engineering is the oldest, so the maximum number of publications also are from the École Centrale School of Engineering, then the School of Management, School of Law. So School of Management also has got a number of good publications. Sponsored research, currently we have more than, I suppose, about near about 50 lakhs totally. And this is actually the approved projects. These are in financial terms. Maybe finance alone is not good enough to know the technical depth of a project. On the right side, we have a whole list of funding agencies. Now, these are actually sponsored R&D programs. I have another slide for consultancies. So among the funding agencies, we have Department of Science and Technology, Ministry of Electronics and Information Technology, and so on and so forth. ANRF is there, and then there are foreign institutions also. And then we have research-based consultancies, which also includes a number of various companies which include defense and also private companies, both MNCs as well as Indians, and of course government organizations as well. Plus, we also have something which we call as internal research projects, which are funded from internal funds. And again, I'll speak more about it, but basically the maximum funding allowed for any project here is about of the order of 10 lakhs. And preference is given to new faculty who have just joined, but then we even look at senior faculty who have got very niche ideas about something which is innovative and fund them as well. So I'll try to go over this. Research and development are priorities and methods. So research and development is a key identifier and differentiator of our university. And all our faculty are doctorates from prime institutions. Many of them are postdocs also, and enter these portals only when they have an intrinsic drive and motivation towards research, and nearly 50% of their time is invested in research. So what we try to see is, first of all, is that we select faculty who are, we test them for their passion towards research, and we also spend, they are allowed to spend 40 to 50% of their time on research, the balance primarily in, obviously, teaching, and to some extent in administration. And what happens is that as the person grows, say, in seniority, the percentage of time spent on administration increases and on teaching reduces, but research remains about 50%. Internal research funding, this is just what I was talking about. Internal research funding of up to rupees 10 lakhs is given to new faculty with interesting ideas, as well as experienced faculty with novel ideas in niche sectors. All faculty are supported with significant, this is the cumulative professional development allowance, CPDA amounts, in every block of 3 years. And this block actually will increase the amount also. And this is not only for faculty, but also for doctoral, PG, as well as UG students are financially supported for international conferences. So further, we also, when any faculty publishes patents or even papers, gets external projects and consultancies, they're also rewarded appropriately. And we have, through the year, about half a dozen major international conferences sponsored by various global bodies. And these are organized on a regular basis in different domains, including computer science and AI, electric vehicles, photonics, metamaterials, pure and applied mathematics, etc. So before I go on to the last slide, I have actually missed out. I think there was something else which was missed out in this. I'll just talk about that. I would just like to mention here that since we are talking about there's an ACM conference, so obviously we have also got a Department of Artificial Intelligence and Computer Science, as well as there are others who are not necessarily in this department, but working in areas related to AI particularly. And we are doing a lot of frontline research in different topics of AI, which obviously includes areas like computer vision and natural language processing, then AR, VR, XR techniques. Then we also use areas like, for example, we have inverse design of materials. We have generative AI. Generative AI applied in generative AI, we primarily work on diffusion models, but we can work on anything. So there we are actually using various kinds of things, including, say, as I said, inverse design of materials in physics-informed neural networks, other kinds of things, as well as we are actually also doing many problems for industry, particularly manufacturing, as well as for aerospace and other sectors. So broadly, these are the areas, but we have also some area where we are weak, which we want to strengthen, and that is the area of cybersecurity, particularly the area of overlap between cybersecurity and AI, which is actually a very niche, I won't say a niche area, which is a major area, but then we are weak in that, and we are actually looking for people in these areas. As I said, we do a good deal of work in generative AI as well, and in practically all the entire span of AI, we are working and doing different kinds of activities. A later version of this, which spoke about the next major conference that we are coming up here. We are actually organizing a series of annual conferences, the International Conference on Emerging Techniques in Artificial Intelligence. This is sponsored by IEEE Computational Intelligence Society. The next one is coming up in August 19 to 22nd. So you are all invited to that, and you can also publish papers. And this is actually, we have got very good review system. And we are also trying to get ranking for a conference because it has been running for the last 5 years. We started in 21, and we had on-off between online and offline and online and offline because of the COVID period. From then onwards, this is the 6th version that is coming up in 2026. I think that's about it as far as the slides are concerned. I do not know if you allow questions. So if anyone would like to ask me something, I'll be more than happy to try to respond to you. It's okay, that's all right. Okay. Yes.
Is there a rolling deadline, or is it, do you have a cycle?
So it is, we don't really have any deadline.
Okay.
So you can consider it as a rolling deadline. And in fact, we now in our website, we have got the HR address where you can send the application for anyone can send it. What I said is, I focused on AI because this is the conference for that. But then we are looking at, as I said, we have got so many schools and so many centers. So we are looking at applicants in all these areas.
Any other question? Okay.
Yes.
So please catch Professor Bhattacharya during the lunch and all. I'm pretty sure that it's about. So let's thank him.
Okay, thank you very much.
Thank you for your support and being part of ARC 2026. We will be looking forward to for your support in upcoming ACM events. Now we'll move forward. And before that, there is a quick announcement for tomorrow's poster. Please put your posters in the allocated stands. And also, who are going to give lightning talk tomorrow, if you have any concern, please coordinate with our volunteers and do cooperate. Now we move forward, and for that we invite Professor Geetanjali Kale, Chair of ACM Women India, for the welcome and opening remark. Thank you.
So good afternoon, and as she has given responsibility of welcome as well. So I take this privilege to welcome you all on behalf of ACMW India Committee. So it's a women committee of the ACM India. I'll tell you why it is required in my presentation. So, and congratulations to the all the ARCS attendee for getting your paper selected to present here, and nice presentation. So as we all are aware, ACM is world's largest educational and scientific computing society, delivers resources that advance computing as a science and a profession. So I'll not go much deeper. This is a little about the statistics. So around 1.1 lakhs of members, out of that 48% from USA, and we are contributing along with the Asia and Pacific Rim, 27% in it. Out of that, 70% are professionals and 30% are students. And in professionals, there is percentage of 50-50 of the practitioner and researchers. So now I'll come back to the W. And why W? Because everyone thinks, and even I have twins and they ask me, do you have any plan of ACM-M? So I'll just tell you just statistic of ARCS I'll show for YW. So see the participation in the ARCS. This is the statistic of today's session. So there are 49 girls have registered for the ARCS, and boys are 98. Okay, so I avoided the men and women word here. So see the percentage, 33% and 66%. Same is the experience with other events of the ACM. It is ACM India Chapter Summit, which is also the large gathering of the students. And in that, when we started, we had given a call at that time. We have general chapters and we have some women chapters along with the SIGs in the India. So when we give call as a general, so there was participation of 28 girls and 66 boys. So which was like 30%, 70%. Then we thought of opening it specifically for the ACMW chapters, and the percentage is 40-60 at least. So I'm sure you will appreciate there is need of W committee and some efforts towards women in STEM. With this, I'll just, as everyone is doing it, so I also did ChatGPT or Google of the percentage of women in STEM, and this is what the statistic I got from it. So see, the global workforce is 28.2% in this STEM. And even though the graduating, in India, graduating girls are 43%. However, at the leadership level, I think around 12% it is, and previously it was one-digit number at the leadership. So this is the need of the W committee. So we have started with ACMW in 2013, and it is for the supporting, celebrating, and advocating of women in computing. So we have a global committee, ACMW. Under that, we have 4 regions: Asia Pacific, Europe, India, and North America. So we are the second largest in ACMW chapter-wise. So we have 2 professional chapters, active chapters I'm adding here, because many times people or the motivated groups start with the chapters. It is active for 2 years or so, and after that it became like dormant and no, battle is not passed on to the next generation. So that chapters are not considered. These are active chapters, and we are doing well at the global level as well. So this is our committee. I'm chairing the committee. Vice chair is Alpana Dubey. She is here. And then Renuka Singhidatta from IBM. Alpana is from Accenture. And my committee has Jayashri from Microsoft, Mini from Cochin, Sriparna from IIT Patna, Manik Gupta from BITS Pilani, Hyderabad, Neeta Thakre from Nagpur, Sachi, Uttarakhand, Sonia from Pune. So the diverse committee members from all the regions, and Exicom representative is Meenakshi D'Souza, who is the president of ACM India. So these are some of the activities of the ACM India. So research initiatives, as you all are research scholars, so PhD Clinic, you are students of PhD Clinic, Anveshan Setu, and ARCS. So similarly, the highlighted with pink, that is grad cohort. So similar kind of cohort is there, which is, I'll elaborate more in the further slide. It is the cohort of the researchers. And some of the conferences of ACM India, I'm not sure, maybe in the introduction it might be covered, but these are some of the conferences which happens in ACM India. You can have a look at ISEC and COTS Comed, Compute, and some co-sponsored conferences. Further, research awards, so ACM India is giving out various awards for the research. Out of that, ACM India Outstanding Contribution in Computing by Women, this award is there, and after my session, there will be presentation by the awardee. Further, we have some of the activities for the UG students as well. So I'll not focus more on it, but I just want to highlight one exclusive session. Summer and winter school is there for the girls. And this is the statistic. Specifically, I'm putting it here on the regional basis. So these are the professional and W student chapters of the W. And if in your state or in your region, if there are no chapters, so I think you can come forward and take the initiative and make, maybe build the brigade for the starting chapters and some initiatives. I'll tell you, UG, PG, PhD students, everybody is getting benefit through this community. You can start with professional, you can be part of professional chapter in your city, and maybe you can get connected with some student chapters. So these are the flagship annual events of the ACMW India, that is Lady Ada Programming Contest, co-located with the celebration. Then for the Nari Yukti, which is the 24-hour hackathon, co-located celebration is there, grad cohort. Then ACMW India annual event, where we are inaugurating this time here. Then we are starting with mentor-mentee program, then chapter engagement activities. So these are some of the glimpses of our event. This is this time's Lady Ada Programming Contest, where the final round held at the UPS Dehradun. So there was 5 plus registrations. 2 rounds were taken online, and the final rounds, girls were invited at the UPS. These are some of the glimpses, and again, have a look at the statistic region-wise. So again, same, if your region is missing, help us to spread the word in your region. And I'll take this opportunity and use this platform to appeal. There is very less participation from IITs. Previously it was there, but I don't know, from 2-3 years, there is less participation from IITs. So those who are from the premier institutes, I request you to spread a word about the ACM and ACMW events in the IITs as well and encourage them to participate. This is co-located celebration. So one day there is competition and second day we use for the celebrations. Celebrations has the series of panels, keynotes and discussions. These are some of the glimpses of the previous events. At Chitkara University, previous was at my institute. And this is about Nari Yukti. Recently it held at the Infosys Hubli on the 23rd and 24th. These are some of the glimpses. And as this is the recent event, I will play a small video here.
We are here at Infosys Hubli DC campus where ACM Hackathon is going on. Let's talk to our participants and get to know how it has been going for them. It is not just a hackathon, it is a movement and it is Nari Yukti.
The name of the event is Nari Yukti. Infosys Hubli, and there were some very good sessions. They were very good host, and I know Infosys is our sponsor, and some of the volunteers who helped us for this hackathon, they are present here. So many thanks to them. There were some break sessions for change, yoga, dance. Again, I had to go for play. Okay, these are some previous glimpses. So this was the recent event, and these are some of the previous events. Previous year it was at SRM Chennai, then PSG Coimbatore. And further, I came down to now grad court workshop this year. This time it is at the IIT Madras, and I appeal all the girl students who are present here. You should take this advantage of applying for grad cohort as well. So it is a 2 days event for exclusively for the female PhD and the master's research scholars. You're getting platform to interact with the senior females from the research and the academia. Research and professionals from academia and industry. So generally we discuss about past, present and future of women in the science and technology. We help them to breaking the barriers with the inspiring stories, and that platform helps them to build the mentoring relationship and further develop the peer networking. Major focus is balancing professional and personal lives, which is one of the major reason what we observe for the midlife breaks and the crisis in the professional life. So there are very good discussions on it during the grad cohort. So it was at IIT Kanpur last time. These are some of the glimpses, and this time we are planning at the IIT Madras in June. So this is about the previous year's annual summit of the women. Further, as I told, we have ACMW, we are starting with ACMW mentoring program, so it will be skill-based mentoring program, and it will be for soft skills and professional wisdom as well. So this is our new initiative. Again, we are thinking of giving welcome kit to the new chapters, and we also want to add some training programs for the girls. So being research scholars, PhD research scholars, if you want to volunteer for this program, so kindly register you or talk with one of us. Like you can volunteer for the conducting events, or you can volunteer for the mentoring, or maybe for the training the students, maybe UG, PG, PhD. So as I told, like do participate and volunteer for the ACM India and ACMW events, some of the glimpses of some other events like ACM India Chapter Summit and the ROCS workshop. You might be aware that is the research opportunities in computer science. Institutes can organize this in their region, and they can take benefit of all the resources of ACM, and that will be one of the community work for you. So this was short about the ACMW. So being ARCS forum, and as I'm professor, so I'll take this opportunity to give some advice. So I know you're contributing to the ACM's vision, that is promoting ethical and responsible innovations through your research work. So as we're giving Turing Award, like ACM gives Turing Award every year, and we know Turing is also known as the father of AI, who coined like what should be called as AI. And he has used his innovation and inventions for shortening the World War II. So it was for social cause. So similarly, I appeal all of you to add this aspect as well for your research to solve the societal problems, and specifically for the Indian context. And I feel in the era of Gen AI, resilience is very much important, because everyone talks about what will be future of computing in Gen AI, co-pilots and all the ChatGPT, Gemini. So what will happen, what will be the role of the computer scientist and all that stuff, because it is now becoming more creative. So we don't know, we were very proud, like humans are very creative, and that is the difference between the computing or the machines and the humans, but they are also becoming very creative and doing very good poems and drawings and whatnot, all, music. So resilience is very much important in this era, and use all the platforms for the collaboration and networking with your seniors and juniors as well. Take the social responsibility of mentoring juniors as well, and prefer the in-person meets, because I know everybody is sitting in front of machine for days and days, and it may increase the problem. So with this, I'll say join as member and stay as professional for the ACM. So thank you. Now I have responsibility of introducing the next speaker as well. So let's move for that. So as I told you in my speech, it just went, no? What's that? So as I told, like outstanding contribution in computing by women, we're giving this award every year. And this year, Professor Krishna S. from IIT Bombay, she has received this award. So yeah, big round of. Krishna is a faculty member at the Department of Computer Science and Engineering at IIT Bombay. Her area of research is formal methods with an emphasis to the verification of concurrent and quantitative systems, as well as automata theory and logic. Her work has appeared in flagship venues such as POPL, PLDI, CAV, and LICS, to name a few. She is also OCCW winner for this year, for the year 2025. and awarded in 2026, where she has been recognized for making outstanding contributions towards the twin procs of science or technology and mentoring or outreach scientifically. She is known for her seminal contributions to the area of formal methods, especially the theory of transducers and in the verification of concurrent programs. In outreach, Krishna has shown unwavering dedication and undertaking significant efforts such as regularly running training programs for high school girls, serving on her institute gender cell, and leading the academic rehabilitation program and more. So please join me to welcome Krishna.
Thanks a lot, Gitanjali, for the wonderful introduction, and thank you, ACM India. So the title of my talk is Verifying Concurrent Programs and a Weak Consistency. So I work in 2-3 areas mainly. So for today's talk, I just thought I will talk about concurrent programs because it is slightly more applicative nature, and hopefully it interests other people also to work on weak consistency models. So what are these? We will see soon. So I'll begin the talk by saying that concurrency is there everywhere. It doesn't need a special motivation. So let's think about the leading manufacturers of architectures, the multi-core architectures. So if you think of any one of them, right, Intel, IBM, or ARM, they all give you multi-core architecture. So that is concurrency at the lowest level of system design, at the level of chips. So now we can go ahead and think of, let's say, higher levels of system design like distributed databases or what we call geo-replicated computing. So here think of applications such as Facebook. So sitting here, let me say I like the photo of a friend. It's immediately propagated to all my friends group, right? So this is basically concurrency working at the back end. Now all of this has also kind of inspired the development of programming languages, where now you see concurrency primitives as part of the languages, okay? So if you look at the latest versions of Java or C11 or C20, you have things like release write, acquire read, logs. These are all basically concurrency primitives which are ingrained in the programming languages. So the rest of the talk, what I'll do is the following. I will take you through some well-known weak concurrency models, okay, weak memory models, so that we are familiar with some of them. And then I'll talk about some verification problems. So this is, of course, a very small subset of the state of the art. I'm just going to talk about problems that I have been looking at over the past 4 or 5 years, so that you get a glimpse of this area a little bit. So before even we look at how a concurrent program looks like or any weak memory model, I think all of us understand how to interpret a concurrent program the moment you see a concurrent program, the model that comes to your mind is sequential consistency. So this is popularized by Leslie Lamport. All of us know about Leslie Lamport, Turing Award winner. So the idea here is that there are multiple threads. What I have written CPU, there are multiple threads. And they're all communicating with the main memory. So every time a write operation happens, it's immediately propagated to the main memory. And then when a thread wants to make a read operation, it has to read the latest value written. In other words, all the threads are in sync, right? They all have the same view about the main memory, right? This is how we interpret a concurrent program under sequential consistency. So just to get a bit of notations also in place, because I'll do 2-3 examples. First, we will see them under sequential consistency, and then we will look at how they behave under some of the weak memory models, okay? So what you see here on the slide is a very simple concurrent program. There are 2 threads, thread 1 and thread 2. I will also call them processes interchangeably. So X is a shared variable. I'm going to assume that initially all the variables are initialized to 0. Now, let's just get acquainted with the operations. So this is a write operation. I'm writing the value 2 to X. Of course, this is a very simple example. Read operations basically look like this. I'm reading from X into a local variable called B. The first thread has a local variable called A. So this is pretty much how a simple program looks like. Of course, you can use conditional loops, assignments, right? All of these are there, as you will expect them to be there. Now, what does an execution look like? An execution is nothing but a sequence of instructions that are executed from either thread. So it's an interleaving between the instructions. The only rule is that I respect the program order of each thread. And whenever I read from a write made, I always read from the last value written. Okay, so this is all I need to know about sequential consistency. So in some sense, it is like the easiest and most programmer-friendly model that we can think about, because it's very easy for me to understand what the program is trying to do, right? So now if we look at, if I want to understand the behavior of a program and to give correctness, normally there are 2 kinds of semantics that are used in the literature. So the first one is called the axiomatic semantics, so I'll start with that. So the axiomatic semantics is in some sense an abstraction of the behavior of all executions. Okay, so I will present the picture, then it becomes clear to you. So the idea is that now you see the execution above, it is just a run or a sequence of instructions. Now I don't have to look at all the possible runs. Instead, what I'll do is I will abstract several runs into an equivalence class, which is called an execution graph. So what you see here is an execution graph. So what do I have there? The nodes of the graph are basically the events coming from the program. So if you look at the left, the 2 nodes which are blue in color are basically the instructions coming from thread 1. And the other 2 nodes are instructions coming from thread 2. So those are the nodes of my graph. Now I have various kinds of edges or relations among the events, right? So the simplest relation is given to me already, the program order. That is what I call by PO. The program order is simply the order in which instructions appear in each thread. Okay, so that is known to me. Now other than that, we use some other extra relations. So the MO is the modification order. So the modification order basically tells me the order in which writes have happened to the same variable, okay? So the MO going from XS1 to XS2 is basically conveying the fact that if I look at the execution above, first the value 1 was written to X, followed by the value 2 to X. So X has been modified from 1 to 2 in that particular order, okay? That's the meaning of the modification order. Then we have the reads from, right? Every time I have a read operation, it has to read from some write that has already happened in the past. So the reads from is basically a function, because every read must read from a unique write. So in this example, if I am trying to model this execution as an execution graph, so notice that A has read the value 1, which comes from the write of X is 1. Likewise, B has read the value 2, which comes from the write X is equal to 2. So don't worry about the FR so much. FR is used because I need it to completely define when a program respects sequential consistency. So I'll mention it in English. So FR is nothing but, so just as reads from is a relation from a write to a read, okay, because this read reads from that write. Think of FR to be, it's called from reads, okay, the name is not very nice or intuitive, but what from reads does is very simple. So imagine I am a read operation. I have read from a certain write. Now after my write, this write has been overwritten by another write, a later write. So in this example, look at A. A has read from X is 1. Now the X is 2 is a later write which has modified the write X is 1. So basically that from reads goes from this read to that write, which is modified its source write, okay, that is all it is. And now with all the edges in place, to check whether an execution respects sequential consistency, I just have to check that this execution graph is acyclic, okay, but I need all these relations to check for acyclicity. I cannot just omit any one of these relations and check whether the behavior is good for me, okay, so it's basically as simple as that. Now later on in the talk, we will see that multiple executions can be bundled up into one execution graph. So rather than explore all the executions of a program, it is enough to explore all the distinct execution graphs, because every execution graph by means of these relations gives an equivalence class, and I'll just explore those equivalence classes, and that will be enough for me to check whether I found a bug or not, okay, so this is the big picture. So since I'm anyway talking about axiomatic semantics, so this is how it is for sequential consistency. It is quite easy, because checking acyclicity once I'm given all the relations is pretty simple, right? It's not difficult. So now I have some 4 candidate litmus tests, simple programs which are normally used to understand whether a program behaves as expected under a certain memory model. This also to kind of break the ice so that we are on the same page and we understand whether the program is behaving in this manner or not. Okay, so this simple program is called message passing. I have 2 shared variables x and y. Rx is a local variable. So the question is, does this program respect the specification of reading 0 into Rx? So what do you think? Can I read the value 0 into Rx? So I'm of course implementing this under sequential consistency. So what's happening in thread 1, I write x is 1, I write y is 2. But now in thread 2, I have a while loop which is waiting as long as y is 0. The loop is broken the moment y becomes non-zero, and then I'm reading from x. So given the program order of the first thread, the moment y becomes non-zero, x has already become non-zero. So obviously Rx cannot be 0. Okay, so this is not met under sequential consistency, and this program does not have a behavior which respects sequential consistency and respecting this specification. Okay, so this is the expected behavior under sequential consistency. Okay, yet another well-known litmus test called the store buffer example. 2 threads, 2 writes, 2 reads. Okay, I'm writing to x, reading from y, writing to y, reading from x. I'm asking, can I see Rx is 0 and Ry is 0, which means can I read 0 from both x and y? So what do you think? Once again, this is not possible under sequential consistency, right? Maybe I can read 0 from one of them, but not both of them, right? Because however I try to execute the program, at least x would be 1 or y would be 1 before I read into both of them. So I can't read 0 from both of them, but one of them is fine. Okay, this is what I would expect. So exactly, this is also not possible under sequential consistency. Okay, my third example, which is 2 threads and 2 writes. This is again a small example. So I'm having 2 writes, x is 1, y is 2. I want to read from y in the first thread. The second thread, I'm writing to y, writing to x, reading from x. And I want to ask whether I can read 1 from y and x. Did you have a question? Okay. So can I read 1 from both y and x? What do you think? So if I think of an execution, okay, I will write 1 to x. I can write 2 to y if you wish, and then I write 1 to y. So now my current value of x is 1 and y is 1 in this order of execution so far. So yes, I can read 1 from y, but to reach reading from x, I need to execute x is 2, and then the value x is 1 is gone. So I can't read 1 from both of them. I can read 1 from one of them is possible, but not both of them. All right, so my final example, 1 read, 1 write. So there are 4 threads. There are these n threads which are just writing to x and y respectively. The remaining 2 threads are only readers, okay? So A is reading from x, B is reading from y in the second thread. The third thread, C is reading from y, D is reading from x. And I want to ask, can I meet the specification A is 1, B is 0, C is 1, and D is 0? So once again, if I try to make A and B happy, I would execute x is 1. The initial value y0 remains. When I execute the blue thread, yes, I can read 1 from X and 0 from Y. Then I try to make C and D happy. To make C happy, I will execute Y is 1. The green thread I'll have to execute. So then C can read 1. But then D can no longer read 0. Okay, because I've already written X is 1, right? So this is, of course, one sample execution. But if you try to reason about all executions, you will realize that this can never, ever happen. Okay, so all these 4 examples are basically saying no for all these behaviors that I'm asking according to sequential consistency. But now, when we move to the other weak memory models, we are going to say that some of these behaviors which are no for sequential consistency can actually happen under those weaker models. And one of the reasons why the multi-core architectures like Intel, IBM's Power and ARM execute or implement these weaker models is for better performance reasons, okay? So here the idea is that there is a continuous traffic happening, from the threads to the main memory, because every time a write is made, it's like published across. And I'm constantly, doing this exercise, right, between the threads and the memory. And somehow under the relaxed models or the weaker models, I would say that it's not necessary to publish every write made, and it's not necessary to leave the last value written, okay? This is kind of the theme for the weaker models, which is why they're called weaker or relaxed models. So as you can expect, you will see all the behaviors that I can see under sequential consistency and more behaviors where I can now read what here would be obsolete writes, okay? This leads to extra behaviors, but somehow, it gives better performance at the level of the multi-core architectures. Okay, so now the first memory model, which is weaker than sequential consistency that I'm going to talk about today, is called total store order. So Intel's x86 machines implement total store order. So the references are basically the papers which talk about the operational semantics of TSO. So I'm going to give a very simplified picture of the operational semantics of TSO. So remember the picture we had after sequential consistency, okay? I have the threads, I have the main memory, the threads are talking directly to the main memory, right? This was the picture we had. But now the picture is slightly different. So I have the threads, I have the main memory, but between every thread and the main memory, I have a buffer, okay? A buffer or a first in, first out queue. So now what happens, whenever a thread makes a write, it does not go to the main memory immediately. It puts its write inside its local buffer. Okay, so it can just keep on storing its writes in its local buffer, which means that when a thread has made a write, it is sitting in the thread's buffer, and another thread which wants to read from that variable will not know unless this thread is willing to release this write from the buffer to the main memory. Okay, so this is the point. So now that is how threads work. Okay, so now if there are multiple writes and multiple variables sitting in the queue, now the thread can non-deterministically flush the buffer, which means the flushing is done in a first in, first out fashion. The earliest write is flushed first, the next write is flushed next, etc., etc. Okay, so these hit the main memory, and the size of the buffer can grow smaller and smaller after the flushes happen. So now what do I do when I have to read? Okay, now imagine I am the thread wanting to make a read from X. So what I'll do, I'll consult my own buffer to see if I have written to X in the past. If I have made a write to X in the past, I will read the last value I have written to X, which means in my buffer, I will look at the last X value I have written, and that's what I would read. Now suppose I look at my buffer and I realize I do not have any write made to X. Now this could be for 2 reasons. Maybe I never wrote to X, that's why I don't have a write in my buffer. Or I have written but I already flushed to the memory, so I don't have it anymore in my buffer. Okay, under both of these circumstances, the thread will look at the main memory and read the value sitting in the main memory. Okay, this is how reads happen. So that's pretty much it. So now the obvious thing to say here is that every sequentially consistent behavior is possible to be realized under TSO. How? Every time you put something in the buffer, flush it immediately to the main memory. Okay, which means your buffers will always stay empty. This is exactly how sequential consistency would work, right? Because your writes are always sitting in the main memory. So any better? I'll hold it like that. Okay, so what this says is that under TSO, I can get all my usual SE behaviors. SE means sequential consistency, plus extra behaviors coming because I've hidden some writes in my buffer, which I am flushing later on. Okay. So just to look at the axiomatic semantics of TSO, so this can be a bit more involved, so don't worry too much about all the letters written there. So since I need to get extra behaviors, remember the acyclic condition we had for SC, it was program order, reads from, modification order, and from reads. See here I am going to say that I don't care about all the program order, I only look at a subset of the program order using which I need acyclicity. So some of you, with a compiler's background might know that sometimes I can reorder the instructions in a thread, and those executions are actually going to be allowed. Okay, so in TSO that's actually possible. So in particular, if I have a write instruction followed by a read on different variables, it's okay to reorder them. And whatever happens after that, if I interpret it under sequential consistency, that's an allowed behavior under TSO. Okay, so this preserved program order of PPO is basically capturing some reorderings. So let's not worry too much about what that is, but let's go back to our example. So remember the stored buffer example, right? We said that I will not get this behavior under sequential consistency. But now, even if you understood this, putting the write in the buffer model, do you think I can get this specification approved under TSO? If I interpret this program under TSO, do you see that this will be satisfied? Yes? So let's see. So the thread 1 has a write of 1 to x. It will put it in its buffer. The thread 2 has a write of y to itself, so it will put y equal to 1 in its own buffer. Now thread 1 wants to read from y. Thread 1 never wrote to y. Now if the second thread has not flushed its buffer, what will thread 1 do? Look into the main memory. What is sitting in the main memory? The initial value of x, which is 0. So it can read that. Same story for thread 2. Thread 2 never wrote to x, it is written to y, but it wants to read from x. It looks into its own buffer, there is no write present on x. Assuming that thread 1 has not flushed its buffer, it looks to the main memory, it can read 0. Okay, so this specification actually can be visualized under TSO. So there's an extra behavior under TSO, so I'm just going to say that I don't get a cycle, which will violate this behavior under TSO, because this write x read y is in program order, it is not in preserved program order, so I don't get a cycle. Okay, so let's not worry about PPO, but I hope that you understood that indeed this visualization, this behavior is realizable under TSO. Okay, I will just do one more example for TSO because taking all 4 will take time. What do you think about this example? Will this be possible under TSO? The same one read, one write example. So I have drawn the corresponding execution graph, which is suggestive of a cycle. Okay, so here indeed, do you think you are convinced that this cannot happen in a TSO? So notice that the second and third threads are just readers. They are not writers. So they have to depend only on the other 2 threads flushing their writes to the main memory if they want to read the value 1. Right? So the blue thread, if it wants to read 1, the first thread must have flushed its buffer to the main memory, erasing x is 0. And then the blue thread also wants to read y is 0, which means I would expect the last green thread to hold on to its write in its buffer. Okay, then that is the way A and B can be happy. Now if I have successfully done that, then coming back to C is y. When I want to read 1 from y, I would expect the green thread to flush. Then it can read C is 1. But then I can't read D is 0, right? Because it's already flushed and it's sitting in the main memory. So even under TSO, even with that extra behaviors that are possible, again, what I said is just an example. You have to reason about all possibilities, but you can just believe me for now that even under TSO, this is not possible. Okay, so this is basically saying that TSO is weaker than sequential consistency because some examples where I cannot meet a specification under sequential consistency, now I can do. But TSO also does not allow all possible relaxations. I will talk about the last memory model I want to talk for today and tell you that there are many others, okay, which you can go and read up. So the release acquire model is basically a programming languages model, like I was saying in the beginning. Now there are programming languages which incorporate concurrency primitives. So release acquire is one such example. So under release acquire, I will just try to be abstract about, so if you notice, right, in all these, at least in both these situations, SC versus TSO, the difference comes from what a read can read from. Okay, in sequential consistency, there is no choice. I always read the last value written. In TSO, that's not the case because of hidden write sitting in the buffer. Same thing in release acquire. Okay, whenever I have to weaken a memory model, it's pretty much either by reordering the instructions, which I can simulate by saying that a read cannot read all possible values written. It can now choose what value it can read. Same happens here. So I just want to remind ourselves what causality means. Causality basically means the sequence in which events have happened. So if you look at this example, so I have a write in one thread, a read followed by a write in second thread, and there is a read in the third thread. RF is the reads from relation. Okay, so I can just think of the program order and reads from and the transitive closure of that, which I call happens before, and that's a causal order. Okay, so basically it's like things that have happened in the past. And one condition that release acquire wants is that causality must be acyclic. So for example, I cannot go back in time and try to read something that was written already. Okay, so if you look at these 3-thread example, if you look at the last write here, I cannot say there is a write going back to that read, forming an RF relation, because there is a happens before relation going from that read to this write. Okay, so that is all this says. So happens before has to be must be acyclic. Okay. The second thing in release acquire is that you can read only maximal writes. So what does that mean? If you want to read from a certain write, either it must be a write you are not aware of, or it must not be an obsolete write. Okay, if you are aware of multiple writes, read from the last value that you are aware of. Okay, so just if you look at this example, so I have this third thread. Notice the ARCS sitting at the bottom. Okay, it's a read from X. There are multiple write X's that I have in the other threads. So my question is, which among these writes can this read X read from? Okay, so now if you look at the middle thread, okay, there is a write X, there is a read, there is a write, and there is a happens before relation flowing from that write X all the way to the read X. But that write X is not hidden from read X because this W that you see below, I'm going to assume it's on another variable. Okay, so this read X can read from that write X, that's allowed. If you look at the first thread, okay, there are like 3 instances of write X there, happening there. Now the first and second write X are already, they have a happens before relation with respect to this read operation. Now the second write X from the top is a candidate this read X can read from because it's not hidden from its view. The first write X cannot be read from because it has been overwritten by another write X in the same thread. Okay, so this is what I mean by saying read the latest write that you are aware of. Okay, so you cannot read an obsolete write in that sense. Now the last write in that thread, okay, the first thread also the read X can read from. So basically, this basically opens up multiple possibilities of writes I can read from, even more than TSO can do. So in this example, the only write this read X cannot read from is the topmost write X. Okay, so the technicalities of RA can be a bit involved. So don't worry if you don't get all of it. Just remember that in release acquire, the only way I can have a synchronization between 2 threads is through a reads from relation. There is no other way a synchronization can happen between 2 threads. Okay, so this is just summarizing the axioms of release acquire. But what is interesting to now notice, if I revisit the store buffer example, we already saw that in store buffer, TSO can see the specification. Okay, so of course in release acquire also I can see the specification. I'll just tell you in English why it is so. So the first thread wants to read from Y. Okay, it has just seen write of X. It is not aware of a write to Y. So here aware means I should be explicitly notified by means of an RF relation for me to know such a write existed. There is no such edge happening, which is why I can read from the initial value of Y being 0. The same holds for the second thread also. Okay, so just this is the summary of saying why both threads can read value 0. But this was already possible in TSO, okay, so it's not a big deal. Now this 2 plus 2W example is a bit more non-intuitive because this is not possible under TSO, but it's allowed under release acquire. This says that release acquire is even weaker than TSO. Okay, so I will not get into the technicalities of why it is possible under release acquire. It's interesting, but it will take more time for us to kind of go back and revisit why it is possible. So this is just to summarize that, okay, now there is a hierarchy between memory models. The more weaker a memory model is, the more behaviors it allows you, and the more difficult it is going to be to reason about that particular memory model because you have so many extra behaviors, right? You have to see whether any of those behaviors are also contributing to the bug that you're trying to find out. I will just put one slide saying that, okay, I have tried to speak a bit about TSO, a bit about release acquire. There are many other models which I am not going to talk about simply because there is no time for that. Now there is Power and ARM, which are hardware models, okay, which are very well used. I also have other programming languages models, which are fragments of release acquire, stronger and weaker versions of release acquire. There's also a relaxed model. There is RC20. Okay, so all of this are out there in the literature. And the question that I would like to ask for many of them is what I will come to next. Not all the questions, but a subset of questions that I have been interested in, which is basically verifying a concurrent program under either sequential consistency or under any of these weak memory models. Okay, so what are the techniques out there? How does the state of the art look like? And what are the challenges involved? Okay, so I will just do this and we can finish. So the first question that in formal methods people are interested is reachability problem. So I'm given a system. I want to ask, can the system have a behavior where it sees a bug? Okay, a bug is basically a bad state. Can I reach a bad state? Okay, this is the standard question that people always ask. So first about, I'm going to assume that my data domain for the program is a bounded data domain, because the moment you allow me an infinite data domain, many of the things either become extremely high complexity or become undecidable, which is not what we want right now. So I'll assume that my data domain is bounded. So the known results, okay, which are like pretty old results, is under sequential consistency. If I ask the question of reachability, I think it is easy for us to visualize it can be in exponential time by just blowing up all the states with all the possible values for the variables. But there's a very clever idea of Cousin, which shows that you can do it in polynomial space. Okay, so this is the known result for sequential consistency. Now, of course, I'll be interested to ask what is the status of reachability for programs under x86 TSO. So there is this complexity class called Ackermann complete. So here, by the way, I am not going to dig into the details. Okay, this is just like without the detail, just telling you the state of the art kind of results. Okay, so for TSO, the complexity is Ackermann complete. I'll tell you what Ackermann complete means. So these are basically, so everybody knows undecidability, right? Undecidable problems are like the hardest kind of things. They're like hopeless problems. The one right below that, which is still decidable, okay, is what is called non-primitive recursive or Ackermann complete. So, these are basically extremely very fast growing functions, and it basically captures a very high complexity. Let's just put it at that, okay? It's extremely high in, you cannot imagine you can implement a system at this complexity level and, expect it to run well. So we can show that it is Ackermann complete. If somebody is interested in a bit more detail, how do you show something is Ackermann complete? Or for that matter, how do you show something is, let's say, X complete, for X being a complexity class? There are two ways to do that, right? One, we have to show the membership in that class, okay? And then second, you have to show it's at least as hard as that complexity class is. So here I'm talking about how do you show something is Ackermann hard. So there is these classes called lossy channel systems, which are known to be Ackermann complete. So I can show a reduction from lossy channel systems to a TSO program. That is how we show the reduction for the hardness, okay? There is a theory for how do you prove lossy channel systems are Ackermann complete, which is again interesting for formal methods because it's beautiful theory. So there is a theory of well-structured transition systems where you have to, a lot of complicated things, I will not get into that. So essentially, if you want to show that the class of TSO programs are Ackermann complete, you have to show it's a well-structured transition system by opening up its transition system. So this has been done in POPL 2010, assuming the programs are not parameterized, which means I have a bounded number of threads. Now, if you allow a parameterized program where the number of threads are a priori unknown or unboundedly many, also we can have the same complexity bound. Okay, that's a later paper which appeared in POPL 2021, the parameterized analysis of TSO programs. So the references below are basically, foundational papers on well-structured transition systems, which if you can look at, if you like theory of that kind. So this is just to give a glimpse of what is a lossy channel system and what the connection of lossy channel systems and TSO, okay? So to summarize it in a single line, in TSO we know that writes are put in the buffer and then the buffer is flushed to the main memory, okay? So now it's quite possible that a thread has made multiple writes. It was written in its buffer. When it flushes to the main memory, some of these writes become lossy. In the sense, some of these writes are never read from, right? Because if it flushes continuously, some of these writes become unavailable for the other threads to read from. Okay, so basically, TSO behaves like a lossy channel in the sense it keeps writing to a channel, which is a first in, first out queue, but then not all the writes it has written are actually used, which is also kind of the semantics behind a lossy channel system, which can give an intuition as to why there is a connection between TSO and lossy channel systems, and the reduction is basically mutual. Okay, I can reduce both sides. So without getting too much into lossy channel systems, this is how it looks like. So it's basically, think of it as a finite state automaton. And I have a finite number of channels now. So when I make a transition, I am reading a symbol. I am also appending to a channel. I can read from the head of the channel. And I can have a lossy transition where I can just lose messages from the channel, okay, arbitrarily. So that is how a lossy channel machine looks like. And the question that we are reducing from is reachability in a lossy channel machine, which is known to be Ackermann complete. Okay, so this is basically the background for the complexity of TSO. Now, if I ask about release acquire, okay, what's the story of the reachability problem for a program under release acquire? So there are two parts to the story. Now, I never mentioned about an operation called atomic read-write, which many of you may be aware of. So it's basically executing a read and a write atomically without allowing an interleaving from any other thread. So if I allow atomic read-writes, I can show it to be undecidable. If I do not allow atomic read-write, the problem is still open. Okay, with parameterized and without parameterized case, they are both open. So this is some of our recent work which appeared in PLDI and POTC some few years ago. So the status is still open if you do not have atomic read-writes. So again, it's basically it just says that theoretically it seems to be a hard thing to solve, even to implement because of the high complexity. So if things become undecidable or have a high complexity, what do I do about it? Okay, these are supposed to be practical things. Do I just give up, or do I have some useful techniques by which I can still make them good for me? I can still use them to find bugs in a meaningful manner? The answer is yes, I can still make use of them by working with under approximations or over approximations. So what is an under approximation? So if you think of the normal behavior of the system, I consider all possible executions. But now I may want to say that, let me not look at all possible executions. Let me look at a subset of executions which have some certain behavior associated to them. And of course, this subset I define must be meaningful, that is important. And if I can now demonstrate that from looking at all the possible benchmarks, if I can say that I could identify bugs in almost all of these existing benchmarks by considering only this subset of executions, then this under approximation becomes meaningful, okay? So some of the very well-known under approximations are bounded context switching, which has been very well studied for sequential consistency. There are state-of-the-art tools out there. So the idea behind bounded context switching is, imagine a process is running or a thread is running for some number of steps, call that a context. When a different thread starts executing, that is switching of the context, okay? So if I look at only those executions where the number of switches between threads is bounded by some k, then those executions are a subset of the overall number of executions, because I'm not looking at all possible executions, but only those where the number of context switches is bounded by k. Okay, now the good thing is, so this paper by Shaz Kadir and others showed that if I'm working with sequential consistency, if I look at bounded context switch executions, I can find almost all known bugs within some small bounded context switching, maybe 8 or 9, okay, which is not like very big. So one natural thing that has been done is, can I lift this bounded context switching under approximation to some weak memory model? So it has been shown that for TSO and power, it does work well in practice. So the idea would be to do a code-to-code translation from a program under TSO or power to a program which can be interpreted under sequential consistency, and then use the existing tools available for sequential consistency. That is how it works for TSO and power. But now the thing is, for release acquire, this under approximation also does not help, because the undecidability result I mentioned already works with a bounded number of context switches. So this basically gives rise to a new under approximation in release acquire called view bounding, and thereby a new tool and a new code-to-code translation from this new under approximation, which has also been pretty successful. So under view bounding also, we have been able to show that you can catch all the bugs possible within 4 or 5 bounds of the view, not the context switching, but the view bounding. What is view bounding? Just, you can read the paper if you're interested, but just, just another under approximation that is relevant for release acquire, since context bounded switching is not relevant for release acquire. Okay, so this is under approximations. Now I want to talk a bit about the state-of-the-art tools that are available. So for bounded context switching under the weak memory models, Datagnan is a state-of-the-art tool. So now when I talk about under approximations, there are various approaches, okay, to basically implement these tools. So Datagnan has an approach where it encodes the program with some bound on it as an SMT formulae. It's fed to some state-of-the-art SMT tool, and then the satisfiability of the formulae will tell me whether I'm seeing the bug or not, okay? So Datagnan, by the way, is also, if you're aware of, there are these competitions for, tools. So there is this conference called ETAPS. They have this competition for SAT solvers, concurrency tools. There are various categories. So DataGnan has consistently won the gold and silver several years. So DataGnan is one of those tools. And recently they also have a version of DataGnan which works for GPU models also, not just CPU, but GPU concurrent programs also, across all memory models. So this is one well-known tool with one approach of basically encoding it into SMT. Okay, this is one approach. Now there are other techniques also out there which can handle programs which, where I'm interested in under approximations or basically bounded techniques, let me call it bounded techniques. So they are called partial order reduction techniques. So the idea here is, if you think of the first slide I had, okay, the earlier slide I had, where you spoke about execution graphs, okay. So an execution graph is an abstraction of the set of several executions can be mapped to one execution graph, I said. We will see it pictorially in a couple of slides. So partial order reduction is basically an idea where I look at two interleavings or two executions. I'll call them equivalent. If somehow I can obtain one from the other by swapping some independent events. Okay? So in some sense, the order of these events do not matter because in effect, the executions are actually equivalent. Okay? This is the idea behind partial order reduction. So there is a big, beautiful theory of traces behind this, okay, where people have a lot of interesting foundational results, which I'm not going to talk about. But what is relevant for us from program verification perspective is that now under partial order reduction, I will explore at least one equivalence class which captures all my interleaving. Okay, that is all that is relevant for us right now. So notice also that if I simply were to build a tool, okay, which is going to look at all the possible executions of a program, they're going to be exponentially large, right? If you think of in the simple example, okay, imagine I have k threads having 2 instructions each, all right? So now the total number of instructions is basically 2k. Now I can say all possible combinations of that I can execute on one hand, but then that is not very meaningful because I'll be repeating equivalent executions. So even then, even if I kind of remove that extra factor from that, I still have an exponential number of executions out there, which means it is important to have some abstraction or some equivalence class which can remove the need for exploring, exponentially many executions, all right? So now if I talk about partial order reduction techniques, there's a dynamic partial order reduction, which makes it even more effective. There's a foundational paper by Flanagan and Godfroy, which appeared in POPL 25. And even a better approach from DPOR called source DPOR, where you can ensure that every execution out there is captured by some equivalence class, and they do not explore an equivalence class more than once. Okay, so this is basically source DPOR. Now, if you think of DPOR for weak memory, so the first and second are mainly for sequential consistency, not for weak memory. Now, the DPOR approach to weak memory has its own challenges simply because the reads have multiple sources to read from. So this makes it even harder. But there are a lot of advances now. We even have techniques where I know that I can bound the space taken by my algorithm to be polynomial space compared to the exponential ones approaches of the earlier times, okay? So these are again very recent works. The last one is in fact something that even works for GPU. This was a contribution made by students from our group also, the CAP 25 paper. So just to give you a glimpse of this execution graphs and how I can kind of think of multiple executions captured in an execution graph. So I've taken that simple example once again. And I want to ask whether I can reach A's 1 and B's 2. Okay, this is an example how a specification or a bug I'm trying to look for can look like. So my question is, does the program display an execution where it sees this violation? Okay, this is the question I want to ask. So what do? I'm going to now apply a DPOR algorithm to the program, and then I'm just going to, kind of look at all the execution graphs, not the actual executions. And the idea would be that every actual execution is covered by one trace or one execution graph. Okay, this is the idea. So just to give it pictorially. So now I have the execution graphs on the right. On the left, I have executions that correspond to this execution graph. So if you look at the top compartment, okay, there are 2 actual executions. Now, if I look at both the actual executions, that execution graph captures both of them. Why? Because the order in which I have read from X into A and B, it does not really matter, okay, to understand whether the property I'm interested in is satisfied or not. So basically, that execution graph captures both those executions. Similarly, the second 2 executions are captured by that execution graph, and so on and so forth. So this is, and we can prove that I'm doing it optimally in the sense I don't explore an execution graph more than once. But I can actually do better, because here in these graphs, the equivalence class requires all the three relations of PO, RF, and MO. But in some models, I can say that I don't need the modification order even, which actually means that I am looking at an equivalence class where I only need PO, RF equivalence. Now that makes it even better. I have fewer execution graphs to cover because I have fewer equivalence classes to cover. So this is super optimal DPOR. Now, these tools are proven to be state of the art, and they work very well across memory models such as release acquire, TSO, even variants of release acquire. This super optimal DPOR algorithm has shown that it can capture bugs which are known to be there. So this is the current state of the art. Now, I will finish soon by mentioning a couple of other interesting problems. So while you build this tool, okay, for the DPOR algorithm, you are actually exploring execution graphs. In the very beginning, when I spoke of the axiomatic semantics, I said an execution graph is consistent with respect to a memory model if it satisfies some axioms, okay, some acyclicity conditions. So now, while I'm building my execution graph as part of my DPOR algorithm, it's important for me to check whether the graph I'm building is consistent with respect to the memory model, or has it already violated the axioms of the memory model. Okay, this is an important question I have to answer. Because if the graph I'm building, if it is already inconsistent, then it does not make sense for me to continue building that execution graph, right? I might as well throw it away and look for another execution graph which is good for my memory model and which can also capture my bug. But now this also asks the question, what is the complexity of checking whether the graph you're building is respecting the axioms of your memory model or not? So the easy answer is, if you give me all the edges that are necessary for the graph, checking if it is acyclic is simple, it's polynomial time, okay? That is not a big deal. But now, when I actually build the execution graph, I don't have all the edges, okay? I have only the program order. The reads from, I am synthesizing on the fly dynamically. The modification order, I am synthesizing on the fly dynamically. So I don't have all the edges. The question is, given this partial execution graph, what is the complexity of synthesizing this RF and MO edges so that I can get a complete execution graph which is consistent for my memory model under choice. Okay, now this problem has been well studied again under all these variants of synthesizing only RF or only MO or both RF and MO, and many of them are known to be NP complete. Okay, some of them are even W complete. It's okay if you don't know what is W1 complete, it's fine. This basically says, there are complexity classes which are beyond polynomial time, which will also contribute to the difficulty of developing these algorithms. So I've listed the references where these papers appeared. These are quite recent papers where the only question of interest asked was this theoretical question. Tell me the complexity of synthesizing these relations so that the complete graph obtained is going to be consistent, okay? But this is an important component which goes inside the building of my tool. So that is why this is a question which we cannot ignore. The last thing I will stop with today, I hope I have not exceeded the time, or did I? 5 minutes? Okay, no, I'm done. Okay, so this is the last formal methods perspective to this whole area. So the axiomatic semantics is very well used. The operational semantics is used for reachability. The formal methods researcher would like to ask, is there another easier semantics I can propose, okay, which can be more amenable and maybe it can compete with the existing semantics. Okay, this is a rewriting semantics. So I will quickly tell you what the rewriting semantics is and what's the connection between the compiler perspective of that. So I said for TSO, it is well known that I can reorder instructions in a thread. I can reorder a write and a read if they're on different variables. And the resultant program now looks different, but I'll kind of interpret it in a sequential consistency, and if all is good, I'm good with the TSO. Okay, this is what I said. Now, while this is well known for TSO, this kind of a reordering is not proven what exactly it is for the other weak memory models. Okay, for RA, it's not very well known. Even for the RA cousins, like strong and weak versions of RA, it's not known. And for the power ARM models, okay, also it's not known. Okay, so the question here was, can we now develop a theory under which I will look at all possible interleavings and I will create some, rewriting rules. And the idea would be that take an existing interleaving which has some nice properties, apply repeatedly these rewriting rules, and then if I end up with an interleaving which looks in a certain fashion, then I can say that my starting interleaving was good. Okay, so this is the idea of the rewriting. So I have an example which I don't think I will take too much time to show, but essentially this is kind of using automata and transducer techniques, so that I am now creating a new kind of semantics called rewriting semantics, which can hopefully compete with the existing semantics. So this is like a different take on the same problem of checking consistency. So this is just an example to show on the same program we had. So that automaton that you see there is basically an automaton that shows you all possible interleavings of the program. What I want to do is, I want to extract from this automaton some special kinds of interleavings, which I call aligned, whatever it is. And then I will now, this for sequential consistency, it's very easy to see, okay? I have some rewriting rules. A rewriting rule is basically saying, can a read overtake a write? Or can a read now be matched with the write? Okay, the rewriting rules are basically either swapping rule or a matching rule. That is all I need. A matching rule is when a read matches with a write. A swapping rule is whether a read can overtake a write in my given interleaving. So I'll apply these rules continuously. So this basically I'm transforming the current interleaving into another interleaving at the end of applying all these rules. That is where the transducer theory comes from. At the end, I'll be left with some good interleaving, which I call a terminal interleaving. If I reach the terminal interleaving, I'll conclude that my starting interleaving was actually a good one, which was satisfying my memory model. Okay, so this is the story. So this is a very recent work, and so the advantage of doing this is it gives a unified kind of treatment across memory models, okay, because it's the same kind of swapping or matching rules, but using which you can basically check whether the program is consistent under a particular memory model or not. So I'll wrap up with some potential directions for further research. Okay, robustness between memory models is a very ongoing and hot area of research. It's basically like saying, right, you wrote a program, okay, you have some expectations of how the program is going to behave. Now you take it to office, you're going to run it on, let's say, a computer running under TSO. Now under TSO, you may get some extra behaviors, which you're not anticipating when you wrote the program under SC. So if the program is robust, you will say that, okay, when I interpret under a weak memory model, it basically demonstrates only the same behaviors it had under the stronger memory model. Okay, this is robustness. Now I can ask this for any pair of memory models M1 and M2, not just SC and TSO. Okay, this one direction. Then of course, I can also think of programs to verify. So there are these languages such as Rust, Kotlin, Erlang, okay, which also allow message passing along with just shared memory. Do there exist deeper algorithms which can handle such paradigms? It's not clear. Okay, this again very interesting ongoing work. Then as I said, GPU programs, because most of the work I spoke about is for normal CPU programs. Okay, what happens with parameterized GPU programs? How do I do some predictive monitoring to detect data races? This yet another, very interesting direction. But these are, again, coming from my formal methods background. I'm sure there are more other applicative, kind of research problems out there, coming from a more PL perspective, which I have not covered today. So pretty much that's all I had. If I have overshot the time, sorry about that. Thank you very much.
So thank you very much, Krishna. So should we take 1 or 2 questions, or audience should join during lunch? They can discuss. 2 questions? Top 2 questions? Okay. Any question? Yeah, please.
So about this rewriting semantics, so originally the motivation apparently to go to axiomatic semantics was that programmers were thinking more in terms of rewriting, what kind of rewritings are allowed versus not.
Yeah.
And then going back towards a similar model. So I was not able to see how it is different than that, or how things become less messier.
Sure. So the axiomatic semantics was proposed more in the sense of, checking whether the execution graph is consistent or not. That is what the axiomatic semantics does. Now, when I mentioned rewriting, so there is this, what I will call folklore about reordering instructions so that the resultant program is good for TSO, this is known mainly for TSO, okay, that reordering of writes and reads can be done. Now, this is a very interesting perspective, right, because you're telling me that I can order the instructions in a given thread. Some of the instructions, not all of them. And when I do the reordering, the program can be interpreted under sequential consistency. So can we formalize this? Okay, this was the thought, right? So this is known for TSO, but it's not known for many of the other memory models. There have been some attempt in the past where they could not really formalize it, because it may not be just thread level reordering. Okay, this is the complication. I may have to look at a complete interleaving where I have now instructions across threads, and I may have to just say allow reordering among the instructions which come from different threads. So this calls for a more generic rewriting kind of framework, like it's a grammar, where I'm saying that these 2 instructions can be swapped, or this read can be matched, until, let's say, I arrive at an interleaving where all the reads have been completely consumed, because they have been matched to the corresponding writes. So this was the motivation for us when we wanted to look at the rewriting semantics, whether we can have a unified treatment using rewriting framework across memory models and not just TSO. TSO could be the easiest you can show to be correct, but for the others, this was a bit more challenging. So we have been able to handle some of the memory models now, but not all of them yet, because for some of them, the proof of correctness is still not very evident. It's not clear whether it will work. Yeah, there's somebody behind, yeah.
Yeah, thanks for the talk. So from what I understand, basically we are trying to make an automaton kind of thing, which basically checks for are the rewrites correct or not. So I was wondering how does the number of states of this automaton kind of scale with the size of the...
That's a very good question. That's a very good question. So the automaton I showed you was basically the automaton that captures all possible interleavings. Okay. So now clearly that won't scale because first of all, I don't need all possible interleavings for this theory, right? Because we want to say consider a subclass of all possible interleavings, which I was referring to as aligned interleavings. And I wanted to say apply the rewriting framework to the aligned interleavings to get your result. So yes, we should not look at the entire product automaton, but actually something where I only look at the interesting set of interleavings. Even then, I agree with you, it's not very easy to scale because even that can be quite large in number. So there's a challenge about how we can optimize things there so that I can actually scale and compete with the existing state-of-the-art tools. Yeah.
Thanks.
So thank you very much, Krishna.
Thank you so much.
Join hands to say thanks and congratulations to Krishna.
Congratulations to Professor Krishna for winning OCCW award and being an inspiration for all of us. And thank you, Professor Geetanjali, for smooth session moderation. And thank you once again for joining us today. And with this, we conclude the session and invite everyone to join for lunch. Lunch will be served on the ground floor of guest house. And please do come back within 45 hours because we are short on time. So thank you. Panel discussion titled Career Crossroad Research Industry and Leadership in Technology. For that, I would like to invite Alpana Dubey as a session chair and moderator for the discussion. Please, Alpana, take over.
Hello everyone, good afternoon. So after lunch sessions are always challenging and I hope this session will make you awake, excited and energized as you walk away from this session. So today we have a very interesting session called Career Crossroads, Research, Industry and Leadership in Technology. So before I start, I just wanted to understand that how many of you are students here in your early career or students. So maybe first students raise your hand. Okay, quite a few then. And how many of you are in your early careers? Okay, good. So we have a good mix, I guess, and they are going to get a lot of insight from our leaders. The second question is that how much you want to understand the way the research ideas convert into a real product. Are you curious about that? If you are, then raise your hand. Yeah, so I think almost all are interested. And yeah, and other is that when we think about designing a system, do you think at the level of POC versus massive scale systems, and what inspires you? POC, proof of concept, a massive scale high performance system. How many of you? Okay, good. I think we have a couple of audience who really want to understand the massive scale computing and how to build a system. So we are going to have this session from two very accomplished leaders who have been working in this area, large-scale computing and cloud. And it is my pleasure to actually invite Charu Srinivasan from Microsoft. Yeah, please come. So I have made this small caricature based on what Charu has done so far and what symbolizes her. I'm not sure if Charu would agree or not, but this is a kind of depiction. And one of the things about her is that her professional career has grown along with cloud. So as you can see that she's holding cloud in her hand. So she is the...
Charu in the picture has more jewelry than I own, so.
Yeah, I also noticed. So it was a creativity of ChatGPT. So yeah, so right now Charu leads the Azure core compute system where she helps in shaping very foundation of cloud infrastructure, and a lot of us actually use it. Her work focuses on building systems and platforms which are secure by design, resilient at scale, AI optimized, self-evolving, and continuously modernized. So you can see some of the other symbols in the in that visual, right? In terms of the security, in terms of all those aspects in this picture. She's a distinguished engineer, and she's also an INAE fellow. And yeah, I mean, her journey started 3 decades ago in the Microsoft. So she comes up real wealth of experience working on large-scale system. And it is our honor to have her as a part of the panel.
Thank you.
In summary, I would say that her story is one of the building system that scale, and that is what we will hear. Welcome, Charu.
Thanks, Salva.
Okay, so we have the other speaker, which is Professor Yogesh Shimhan from IIC Bangalore. So I hope Professor Simon would agree with the caricature again. It was something which I just tried without showing to them. But if you see, his journey actually reflects from how deep system research can shape the way world computes. So his journey includes a PhD in computer science from Indiana University, followed by research roles in US, Microsoft Research, and University of Southern California. And after that, he headed back to India to bring all those and start his own research lab in IIC Bangalore. He works mainly in the area of scalable platform and intelligent systems. He has authored over 100 of research papers and publications, has been recognized with several prestigious honors, including national and international awards for excellence in scalable computing. So he just, with his work, continues to push the boundaries of distributed systems. And what makes Professor Simon's journey especially inspiring is his foundational research, real-world deployment, and mentorship. So please welcome Professor Simon for the conversation. And I will take the middle seat. It is not a fireside chat. Probably it is more close to Coffee with Karan, if you have ever seen it. But we will have conversation around different areas. Am I audible? Yeah, so initially I will just ask about your personal journeys. So my first question is that, to you, Charu, is that what first draw you to computing?
Yeah, I was reflecting on that question, and perhaps the one thing that drew me to computing and continues to, right? I was sitting there, like I'm at an age where I could perhaps retire, but I'm no chance in hell of that happening, because I think computing is really about solving puzzles, right? Like solving hard problems and doing it. You got to do it really well because it has to work at scale and stand the test of time, and that's usually super hard, right? Like, do you build tech that moves the dial? I've just been super fortunate. Like this is my fourth big kind of inflection, right? I joined the industry in the early 90s where we were doing client server. And then I had, of course, the mobile internet wave and then the cloud edge and now ambient intelligence with AI. And each one of these inflections, I think, has given me the opportunity to work on new problems, which I think always fascinate me. So for me, it's what can you do with your curiosity, with your ideas, with your resilience? Because often building tech is about resilience. You've got to, have that staying power to take your ideas, but shape them in a way that kind of stay up. You're talking about like uptime. I work on Azure Compute. We build the core compute infrastructure for the planet. So we operate at planet scale. So how do you do that in a way that the virtual machine doesn't come down? How do you make sure that you can maintain your fleet? I mean, these are fascinating, hard problems that I just sit there thinking I could come into work for the rest of my life and probably have fun problems to solve. And for me, that's all it takes. Thank you.
So was there any pivotal moment in your life which actually you can recall and tell that this is what made you really feel that this is where I should go?
It was kind of, I think it was in 11th grade or 12th grade, like I joined some local kind of computing classes, and somebody just showed us how Visual Basic works, or Basic, maybe it was Basic, I can't remember. And they ran it on an Altair, and my jaw just dropped, like, wow, like I'd never seen something like that. And it was very clear, of course, my parents asked me, my sister was a doctor, like, do you want to go do your MD, because then I can take the hand-me-down stethoscope. I said, no, I want to do engineering. So here I am. So.
Great. So Professor Yogesh, I would want to ask the same questions, that what drew you to the computing for the first time, and what was the pivotal moment in your life which made you feel like that this is the area where I want to go ahead?
So not like Charles' last statement, right? So I was probably in my 6th or 7th grade, and I saw a computer for the first time in my life, right? So we had a sort of computers arrive at our school. It was a big moment, right? So, and am I audible? Is this any better? Okay. So yeah, probably in the 6th or 7th grade. So we had computers come to our school for the first time. Till then, computers were stuff that you saw maybe on TV, right? We didn't even have much TV, right? 1 or 2 channels back then. And as I mentioned, we are into GW Basic. Back then, that was the thing, right? And now this is something you can actually do, right? So till then, sort of, most of your classes was about learning things and writing exams and so on. But here you could actually build stuff, right? Create, and so you can make it. You can give it instructions that it will follow, right? It's not going to talk back to you, right? Like your younger brother, right? So, and I was just hooked, right? So, and of course we had sort of, I forget the name, so we had a small turtle that you could have go around, draw things and so on. But the power of creating things, right? And sort of giving instructions and have it do it. Now I can think of it deterministically, but sort of do stuff, right? Was really sort of, I was just really hooked, and at that point I knew that I wanted to keep doing this for the rest of my life. It didn't seem very childish, but that's what it was. And going from there, getting into learning new languages and all those things, that just strengthen your sort of ability to express things, right? Just like languages, like human language is one way of expressing things. There's another way of expressing things and making things happen, right?
I can relate it actually, and I think the people who are now, at least the kids who are interacting with ChatGPT, I don't know, they might be equally excited about the same way that, okay, I mean, I'm asking something and it is doing the way actually, and the language is now natural language.
Yep.
Yeah. So the next question, I just wanted to hear more about your journey from graduate student to becoming a leader in the academic community, research community. Actually, how is that journey? How did it shape, or if your journey can help actually to the audience?
Sure. So I knew going out of school that I wanted to stay in computer science. That part was clear. But beyond that, you don't have much visibility, right? So you always take it one step at a time, right? At most stages of your career, right? So then I went on to sort of go, I wanted to get into computer science. Doesn't matter which college I went to, right? So and finally I landed up at SRM, right? So that's right now a big university. Back then it was just an up and coming sort of private college, right? So when I did my computer science over there. And even there, right, like, it was really nice. And I should sort of recognize, even in my schooling, right, my computer science teacher in my 11th and 12th, she was amazing, right? She sort of helped nurture that idea into something more sort of fundamental, right? Not just sort of having a sort of whim, because computers were still of a bit of a novelty back then, right? So saying that, hey, you can actually go into this area, that itself is the confidence I got from her. And of course, getting into sort of college like SRM, so I used to participate in the equivalent of hackathon. Back then, it used to be these tech quizzes that you would have and all kinds of these events that you would have in different colleges, so I was very active in those, right? It's always nice to be good at something, right? So I think I say that to even my students, right? Just be good at one thing, right? You don't need to be good at everything, but that should give you pride, right? And you should have others come and talk to you, saying, hey, you are the expert on this particular thing in your lab, right? So, and to me, that ended up being computer science, right? So, and then post that, I eventually wanted to stay in that space, but and one natural way was to do grad school in the US, right? But there are some personal challenges. I wanted to eventually become a scientist, right? So it was back in my undergraduate itself. So I had to sort of do personal challenges. I wanted to first do a master's first. And then once I went to grad school, it was like I realized sort of there is a dual awakening. So one is, of course, being in grad school in the US, going from a private college in India, it's a bit of a cultural shift, right? So things are sort of great, streamlined, all those things. But to me, it was also a bit underwhelming, interestingly, right? To me, the courses, at least in Indiana University I went to, were not as challenging as I would have wanted it to be, right? So it felt like another fifth year of my, maybe in a good school, maybe fifth year of my undergraduate. Right? But I took the OS course, and there we actually started building microkernels, right? And that said, okay, and I really got hooked to the system side of things at that point in time, right? Saying that, hey, this is even more. It's not just about programming. It's about building complex systems, right? And the fact that you find all these seg faults, right, makes it challenging, right? So you think you're a good programmer till you hit a dozen seg faults, right? And then you know, okay, there's a lot more to be understood about the internals of the system, right? Not just at the sort of language level, right? So, and then I got a chance to actually get a sort of RA position as part of doing well in this OS course. Interestingly, I had a choice back then, right? So Microsoft had come for campus placements, right? I was still a master's student. And I got selected for an internship, right? So with a bunch of other students, right? So I go to my sort of supervisor, right? I was still a master's student as an RA. I said, hey, I have this summer internship at Microsoft. Can I go, right? And he gave me a choice. And the same kind of choice I give to my students nowadays as well, right? You go for the internship, you don't have an RA-ship, right? You skip the internship, you have an RA-ship, right? I could still be a TA, right? I could go to Microsoft, come back, be a TA, and still be good. But I knew that I wanted to be in research, right? So while all my other students went to Microsoft for an internship, I stayed back and said, okay. And at the end of summer, I switched to a PhD, right? I knew at that point, this is where I need to be headed, right? So.
So very nice inflection points in your life. Your passion for understanding systems and then the role of mentor has actually shaped your career, as I understand.
Absolutely, yeah.
So I think this is a similar question, Charu, I would want to ask that how has been your journey? You have started from the beginning in Microsoft, right? So initially, most of the people start with individual technical contributors. So how has been your journey shaped to being a technical contributor to CVP? What were the journey and what were the inflection points?
Great question. And by the way, I loved that same Unix source code. Like I was hooked when I saw the source code for fork and join, and like, okay, this is why I want to be in distributed systems. I think there's something very unique about people who love distributed systems. You've got to kind of love the complexity of those building the systems. And I've just been super, I'd say, lucky to have been in computing for, at the times that I've seen like this incredible transformation. As I'm sure many of you, but definitely I would think you've seen those big inflections. So for me, the early years were kind of spent just trying to be a good engineer, right? Like when I say good, you need to become the person that's people reach out to, hey, Charu, can you go take a look at that bug? Can you run your, I used to have this really tough regression test suite. And the database engine folks would make some changes and come back and tell me, Charu, can you run your test suite? Because you always catch the most interesting bugs, right? So kind of becoming like a go-to person. I think that was like the early years. And then over the years, I realized that the path was not about, hey, did you have this big idea? It was really about getting people to take a bet on you, right? I remember the very first time I see Karthik Raman in the audience. Karthik works in SQL Server. So in the mid-90s, we started working on our own database engine. Until then, we had access to Sybase's SQL Server code. So in 1995, we actually started working on our own database engine, and I joined the team at that point, worked on this product called Merge Replication, which many of you may have never heard of, but it was a very interesting piece of tech because it built eventual consistency in databases, which is somewhat like, whoa, eventual consistency in databases sounds like a bad word. But it was a very cool product because you could have these disconnected replicas making updates autonomously, and eventually they would kind of converge to the same version of the data. And at that point, 1998, I think, we had designed SQL Server Compact Edition. And this was a handheld database. So for many of you out there who think mobile phones were there all the time, the answer was in late 90s, it was not a thing. Like, it became more of a thing in 2000 and later. And in the late 90s, we started seeing some of our customers take their large-scale database that was running in the enterprise and mobilize their workforce. So Nabisco, the biscuit company, wanted to send its truck drivers out with a ruggedized handheld device. And guess what database engine was running on that? Karthik's SQL Server again, right? SQL Server Compact Edition. And so I just put up my hand in a team meeting, said, hey, I think it'll be fun if we can sync SQL Server Compact Edition with the SQL Server database engine. And a bunch of us looked at me and said, like, you gotta be kidding me, right? Like, oh, why do you want to do that? Like, that doesn't even sound interesting. And why don't you just have people carry laptops everywhere? And I said, no, this is real, right? Like, you're gonna carry these handheld devices. So some of it's like a leap of faith. In fact, I took that, and more interestingly, people around me, some of them at least believed me, because by then I had produced a prototype. I said, I know how to go crack this. I'm going to go build this and show you a demonstration. And of course, over time, so I built that. I built it really badly because it didn't scale, and then I learned multiple versions to get it to scale really, really well. It took a long time to get the scaling right, because you don't design for like tens, right? You design in order of millions of devices out there. So long story short, that was one big inflection. And then the other kind of big one was when cloud happened, when virtualization happened and cloud happened. I, in fact, wrote a very interesting proposal saying, hey, I think it might be fun to virtualize machines and, in fact, replicate virtual machines. Virtual machines were by then beginning to, virtualization was taking in the cloud. The cloud was not yet born, by the way. The cloud was still nascent, and we didn't really have Azure or what have you, AWS or GCP at that point. And so my proposal said, let's replicate virtual machines. And because by then I had noticed that customers who wanted disaster recovery were spending tons of money on specialized storage stacks, specialized hardware, and it was hard to kind of access that. And if you're at Microsoft, you always solve platform problems. What that means is you constantly democratize technology. So something that was running or costing customers hundreds of thousands of dollars, suddenly we were producing this stuff that costs thousands of dollars. So order of N like cost reductions, which I thought was it's hard to do those, but when you do it, it's massively inflectional, right? And when the cloud happened, we said, what if we now replicate databases to the cloud? Not databases, virtual machines. By the way, I know how to do database replication as well, Karthik, just in case you want. That's something, no, I'm kidding. But long story short, when we started, we said, what if customers don't have a second data center, right? Like, because the cloud is happening, then we would replicate to storage and stand up the virtual machine in the cloud. And so suddenly now we had opened up this brand new, almost I'd say like domain for Microsoft and the industry, which was called DRaaS, Disaster Recovery as a Service. And for me, the thing that was fascinating was a paper, an idea that was maybe 10 pages long, just broadly described this. And then a decade later, you've got Gartner, the analyst, talking to you about why is this a visionary product in the industry, or it's market leading. In fact, Azure was the first hyperscaler to in fact have a cloud backup and a cloud DR solution, and my career was in fact built over that. And over the last, I would say, decade, I've kind of spent time on Azure Migrate, like making sure we can lift and shift data centers into the cloud. We build an interesting piece of tech called Live Migration, where we kind of move virtual machines in the cloud so we can shape the cloud, kind of make sure that we can get the right capacity, bin pack the cloud. So lots of very fun, interesting problems. And in the last few years, I've worked more on confidential computing and worked on this product called Clean Rooms that really do privacy-preserving compute. So if you look at my journey, right, I think the one thing that stands out is you always need to anticipate where the puck may land, or where I don't know, where you need to kind of place yourself so you can catch the ball, right? And I think computing industry lets you do this, especially with the kind of inflection we are at now. I was just talking to both Karthik and Professor Yogesh, right? The horizons of research have shrunk dramatically. What felt like a 24, 36-month problem is now a 6-month problem. So Horizon 3 is Horizon 0.75. So researchers should better kind of, you have to look over your shoulder because engineering is catching up real soon. And we are solving some incredibly hard problems, giving you some competition, Professor Yogesh, right? So the pace has shifted dramatically, the pace of diffusion of this tech, but the pace of innovation. And so that keeps me excited, and I hope I kind of continue to bring ideas to life.
Yeah, so I think the kind of work you mentioned, one of the work is...
I remember being in meetings where I would be tongue-tied because I would be nervous to talk, right? So a lot of times, for me, it was about silencing my inner critic, okay? How many in the audience can relate to that? Show of hands. Yeah, like where you feel your idea may get judged, right? And perhaps you're not the smartest person in the room. I definitely kind of had that experience multiple times. So you've got to lean into your inner strength and just develop that conviction. Believe me, I have had some terrible ideas too, which I'm not going to talk about. So.
So along the similar line, Yogesh, I just wanted to ask about your work, which has actually led you to win IEEE TCSS Scale Challenge. And this was an interesting problem which you have solved, and definitely being from Bangalore, I can also relate a lot. So can you just explain about the whole journey? Just for the audience, this work was related to the traffic. I mean, in a very simple way, but Yogesh will tell more about the whole journey and what was the problem and the impact.
Sure. So just a bit of backstory. So I was in University of Southern California as a research faculty in about 2010 to 2013. And back then we were working on a smart grid project, right, at USC as part of the whole ERA grants that US government was giving away to revive the whole economy after the crash of 2008. So we were working at a large-scale smart city project with LADWP. So they have the largest power consumers in the US, right, a gigawatt, right? And as part of that, we actually put together a stream processing system for doing smart grid management, microgrid management in the US, in LA. And that actually went on to win the IEEE TCSC Scale Challenge Award, which is held as part of CC Grid. This was back in 2012, right? So couple of years later, I relocated to IAC to India, and we started working on projects related to smart grid in India, and these are very two different smart grids in the US and in India. And in India, it is more about, can I do online billing, right? That makes utility smart, right? Instead of paper billing, right? But we started working with water utilities and also sort of as part of intelligent transportation and so on. And we sort of encountered sort of similar kind of challenges, but at a much different scale, right? And we were looking at Bangalore traffic as one of our use cases. Can you sort of observe and sort of try to analyze? And that was our first sort of twist with edge computing, right? So can I sort of have streams of data coming in about traffic, and can I start looking for anomalies? Can I start doing prediction of traffic flows and so on, right? This was back in about 2015 or so, right? And as part of that, we realized that you cannot just do everything centralized on the cloud, right? So because in the US, in the USC, everything was centralized on the cloud, right? But then we realized that that's not necessarily going to be sort of tractable in India, given all these sort of network variabilities and sort of the emergence of just national data centers, not regional data centers, and so on. Things are still emerging, right? So we actually had a sort of demonstration of POC that was able to scale to hundreds of these sort of traffic streams on the edge and essentially respond in real time through various kinds of batching and sort of windowing techniques and even dropping techniques. And we were able to show the POC that we picked up, right? So the demonstration was, can I give a sort of a signal-free lane for an ambulance, right? That's because the scale challenge is also about practical impact, right? And we were able to demonstrate sort of partly through simulation, partly through real data, that you could essentially boil it down to a graph problem, a streaming graph problem, that in real time would sort of track the traffic flows and sort of starts doing signaling of various based on the shortest path from the current location of the ambulance to the nearest hospital, try to start doing staggered signaling, right? So of course, we didn't deploy it on the field back then, right? But that went on to sort of win us the scale challenge from India for the first time. So that was really something that we wanted to do, right? Having done it on the US side, right? But fast forward like 5 years, right? That was just a POC. It got us a couple of news report, and the news report incorrectly stated that we actually are deploying it, right? It was just a lab POC. Of course, it was at scale, but several years later, in the last couple of years actually, right? So that actually got us into the Bangalore traffic police. We had a very sort of proactive joint commissioner of traffic, Anuchet. So he got excited. He saw this report from a few years back. And he said, hey, can you guys start doing something about that? And we had some good partners at our Center for Sustainable Transportation with whom we teamed up. And today, many years after that academic award, right, we are actually seeing that in reality, right? Nowadays, of course, back then we were using Raspberry Pis. Now we were using Jetson accelerators on the edge. And in fact, we even have a demo currently going on where we are using traffic camera feeds, right? Because back then you assume that you'll get some kind of a sensor feed from the field, right? But in India, deploying sensors in the field is extremely costly, and no one wants to get into that business, right? Maintaining it is even more challenging. So what we have been doing for the last couple of years is look at all the not the traffic cameras, these are safety cameras, right? And there's a subtle difference. Safety cameras do a wide-angle view, right? So that if someone is caught in the act of sort of theft or whatever it is, later on you can go back and catch them, right? Traffic cameras are pointing at specific lanes, right? Which means traffic cameras are easier to do video analytics on top of because things are properly oriented, right? But safety cameras, I could be looking at the whole sort of street, and I've got 3 streets going on in 3 different directions. So how do you keep track of which traffic is flowing in which direction and so on? That becomes much more complicated from a computer vision challenge. So we worked with some of our ML researchers, and now we are able to sort of, sorry, that's my reminder to pick up my kid. So we essentially have a lot of models, vision models running on edge accelerators, chewing into sort of dozens of video streams at a time, and Bangalore has about 5,000 plus traffic cameras, right? And they essentially do video analytics, that the video gets converted into vehicle counts and classifications in real time, and then you bring in the stream processing, you do sort of prediction models, and right now we even use graph GNNs, right? Back then it was classical temporal graphs, now it's GNNs. So the whole ML flavor comes into play, the edge is much more stronger nowadays. So we are seeing something that's getting closer to practical reality, right? Thanks to sort of the work that started a decade back, right? Starting from USC, then to the scale challenge, and eventually something that's seeing the light of day through a practical prototype. Yeah.
So cool.
Yeah.
This is really cool, actually, very interesting to hear, and I think there is a very important message in this that we should not be I mean, we should be patient, and maybe, the idea has its own time, and it needs its own time to get really used and see the applicability in the world, right? I mean, and this is a real great
Absolutely.
inspiring example here.
And it's also about grabbing opportunities, right? So and that's one thing that I realized, right? So I'm actually the other extreme from Charu, right? So I don't have a vision, right? But I always remember to open the door if something knocks, right? So to me, it's just a succession of serendipitous accidents, right? That take me in different directions. But as long as you're sort of doing good stuff, right? And you keep doing good stuff, right? Be it whichever research area or topic that you pick into, right? And also look out for opportunities, right? If something comes in, right? So one thing is to sort of seek it out, right? The other thing is just, if something comes by, recognizing that it's coming by, right? Not overlooking it, right?
Yeah. And I relate to that. In fact, I don't think the vision stuff works because finally it's you opening the right doors at the right time, right? Like being able to course correct. Those things will eventually matter, right? So I think the vision counts, but really that's not what gets you further along. It's the smaller like openings of door, right?
So don't forget your work, keep in your basket and keep it ready as and when the opportunity comes. And
no, I think it's being curious. I don't know how many of you are feeling curious in today's day and age. I'm like, first of all, curious. I'm scared as well, like about what's going to happen to the world, right? As this technology like takes over. But I'm very curious about how the world is shaping up, and I think we all have a role to play. So perhaps just that engagement to understand tech, I think, is about solving human problems. Better be about solving human problems. Unfortunately, there's a lot of tech that hasn't necessarily kept humans at the center of the innovation, but if you keep that, I mean, that's really what has allowed me to keep my sense of purpose intact. Yeah.
So on a separate note, I just wanted to understand how does the leadership journey looks like in industry? I mean, people in a technical role, how does that journey looks like?
Yeah, and I probably, to explain this, I'll probably share, I mean, a leadership is a broad word. Yeah. So do you want more of a technical leadership journey?
Technical leadership,
okay, that's a good question. And I think often, especially when you get into the industry, people like try and kind of go in for like larger roles with a lot of people reporting to them. What I've tried to do is over all these years, try to remain a technical leader, because ultimately the strength of the ideas you bring to the table are what
matters the most.
What matters the most, right? Yeah. Of course, I think I really love running my teams. I'm a good org leader. But I think if I go back and talk about my happy place, it is being a technical leader. And for me, I think it's been this journey which I described earlier, right? Like finding interesting, unique ways to solve something, and perhaps solve something in a way that new things are now possible, right? When we built disaster recovery in 2012 for Windows Server customers did not have a way to replicate virtual machines to a different data center. So when Hurricane Sandy happened in New Jersey, we actually had a law office that we received an email from them because we had literally saved their business. Their virtual machines were running in one data center in New York, and because there was some upfront notice about Hurricane Sandy, they failed over and ran the virtual machines in data center 2 in New Jersey, and their law office was intact. They didn't run out of business. For a bunch of small business, if you go down during these, like COVID, like we know what COVID did to a bunch of small business, they just vanished. So really kind of building that resilience was important. And then the next, so that's like one inflection, right? Like where you build successful product. But then over the years, my growth as a technical leader kind of came when you can almost spot the industry trends. When the cloud started happening, we pivoted our product away from building for on-prem data centers to building for the cloud. So suddenly you're disrupting your dev team. Our dev team did not know what it meant to build a cloud service, and suddenly everything that you're doing on-prem, you now have to like move it to a new paradigm, like the AI paradigm shift now. Yeah. And to do that, you have to let go of your old, like almost like your old way of thinking. You have to like rethink a lot of how you think about things. And I think AI, more than anything, makes you rethink your old workflows, right? And so when we ask the question, hey, what if you don't have another data center, but you have the cloud? Then we build virtual machine replication into the cloud. That was again a breakthrough idea because that core idea was never done before. There was no other cloud that was booting on-prem virtual machines. And so that became a hard engineering problem. And so I think technical leadership is often a composition of these hard problems that you can put together. But ultimately, in a company like Microsoft, it's also about business success, right? Like being the first mover, like when customers were moving to the cloud, they were not going to, there was no enterprise customer that was going to move to the cloud if they could have a disaster and that it would take down their business. You have to have a backup, you have to have a DR copy. Otherwise, there's no way you will feel safe to move your production database to the cloud. And so because we had built BCDR, business continuity and DR solutions for the cloud, Azure suddenly was able to bring in more enterprise customers. So suddenly, the business impact of the work that you did years ago lit up and made sense. So to me, a technical leadership journey, I mean, getting, for me, like I'm currently a distinguished engineer at Microsoft, which is a pretty high level of technical leadership. It's always been about demonstrating that your ideas work, but not just at an academic level or at a theoretical level, but it works at planet scale. But it also works and creates significant business impact. And for a company like Microsoft, it is about our mission statement, right? Like what can we do to make our customers succeed on our platform? So it was not a single idea that gets you the accolades towards the later part of your career. It is this composition of those little ideas that kind of compose. So slowly, little by little, year after year, we had democratized resilience. What used to cost customers hundreds of thousands of dollars, SAN, specialized kind of storage devices, SAN architectures, and extremely expensive IT investments, we had now made this like a self-service, and self-service, like people could get to it in order of thousands of dollars, like I said, right? The fact that you democratize that, I think that is a breakthrough. So the impact is never breakthrough on day zero, right? Yeah. It becomes breakthrough over time. I hope that makes sense.
Very interesting perspective. I wanted to hear the, answer to the same question from a person from academia. What is your perspective about the leadership in academic world or the research world?
Right. So in academia, you always have, let me start about talk about IISc, right? Because IISc is a very unique, in India at least, a very unique academic institution, right? So at least till you're in the US, right? So you are publishing is a big deal, right? And in fact, from a technical leadership perspective, I always feel that you always need challenges, right? And the moment you feel that I've done a lot or everything, right? You're set for retirement, right? You just go off and like fade away, right? Yes. And the question is, what challenges? What are the benchmark that either you set for yourself or what the system sets for you, right? Till you're in your grad school, effectively your advisor is setting the benchmark of, hey, do X, Y, Z, you get to graduate, right? That becomes your benchmark, and that sort of motivates you to sort of do well, right? In fact, for most PhD students, it's going to be an exponential growth in your research output, right? The closer you get to graduation, the more you're publishing and so on, right? And in a place like IISc, right? So the first thing that my chair of my department said when I joined IISc is, great, you've got a good publication record in the US and in Microsoft Research, USC, and so on, right? But at IISc, we don't care about the denominator, we care about the numerator, right? Which is not how many publications that you have, but the numerator of how many good quality publications you have, right? And that's a sort of mental shift, right? So you said that, hey, it's not just good publishing, but quality is paramount, right? So if the ratio is bad, I don't care if the numerator is 1,000. If the denominator is 1,000, if the numerator is bad, you're not doing good, right? And IISc has a tenure system, right? Which means that you don't get a permanent contract. You get tenure only after 6 years, and they do an evaluation of the first 6 years of your work that you do, right? So, and that's actually good. IISc is probably the only university in India, right? In the US, it's standard, right? That has a tenure system, right? Which means that you're constantly challenged, right? Saying that, hey, can I do better, right? And no one's going to come in and tell you, right? this is the ratio, this is the number, right? There's no magic number, right? It's always like, do the best you can, right? And the moment you set an unbounded benchmark, right? It essentially means that you keep trying your best every day. You wake up and say, okay, how can I do better, right? And that's, in a sense, despite all the constraints, I can't come in and say, hey, I didn't get a PhD student for the first 4 years of my tenure. No one cares, right? So you're at IISc, this might be the case for the rest of your life, right? Can you survive and do good research, right? So I think that's one important, the system in which you're operating becomes very important, right? It could be sort of business, it could be technology, it could be academic, it could be research, but make sure you're always in a place that challenges you, right? If not, you should move on, right? That's not the right place for you. If you think it's too easy, low hours, good pay, but not intellectually challenging, that's not a good space to be in, right? And of course, you do have the sort of the research community as a whole, right? You come to a conference, or you could come to a place like this, right? You meet top researchers, right? And you always feel that, hey, what should I do to get there, right? So, so that's the other sort of motivation that you get, right? So you cannot sit back and say, oh, I'm doing good research by Indian standards, right? That doesn't work that way, right? You go to a top conference and say, hey, there are 100 ideas that I didn't think of, right? Right? What should I go back and start doing, right? So I think from an academic career, so it's more about constantly looking for new things, not necessarily because from a business or from a technology perspective, but if you're not working on the sort of the next big thing, right? And as Charo was mentioning, if engineering is sort of lapping research, right? So we have our job cut out. We need to work even harder, right? So to see where we should be, right, as researchers 3 or 5 years from now. And that's a hard problem in this day and age, right? In fact, a side note, I was at MSR for about 3 years as a postdoc, right? After my PhD. And the pay was great, right? So I was earning more than my advisor when I joined MSR. But it was not as, back then, intellectually challenging, right? So I felt I had to sort of do beyond that. I moved to USC, and there it was sort of much more demanding, right? And right now at IISc, it's even more demanding, right? But now I see that industry is leaps and bounds ahead of academia, right? So I think academia is way behind when it comes to some of the AI and even systems challenges, right? I'd say in the last 5 years, right? So no questions about that, right? So I was happy to spend the summer at Microsoft a couple of years back, because you need to sort of upskill as an academic. I need to upskill, and some of the challenges that scalable AI is facing, there are probably only 15 institutions in the whole world that are working on them, right? And I don't think any Indian institutions is part of that, right? So even there, look for sort of opportunities to sort of fork out. You're not sort of pigeonholed. If you're in academia, it's not like you're always in academia. You should look for these opportunities to collaborate so that you're always technically sharp, right? If not, you're going to be in trouble. Yeah.
Very, very nice. So I will just ask one question to both of you, and then we will go to the audience Q&A. And this is a very important question, actually, which everyone would want to hear, given your background in the distributed system and cloud computing. That given the diversity of problems in the distributed system, what would be the next big thing that you would like to take forward?
It's a great question, and I think I kind of hinted at the answer during my career journey question, right? I personally feel that it's our responsibility, and I definitely mirror Microsoft's opinion on this, that we better keep humans at the center of this innovation, right? Like an AI, more than anything else, challenges that, because not all players are necessarily playing the fair game. We know that, right? Like, is AI inclusive? Do we, when a hospital chain deploys a disease model for cardiovascular disease, is that disease model, does it have data sets from tribal people or people in remote parts of the country? It's a very interesting question. It's an important question. I think inclusion deeply matters. So the other thing that I also deeply care about is, unfortunately, in today's day and age, we have become the product, right? Like, people are looking for us to click on those reels, and they're watching every digital byte that's being emitted by us so that they can monetize it. That's the reality of the worlds we live in, and the algorithms are running constantly. We can't even shut them down. So I think in this day and age where privacy has become quite a challenge, I think making sure that the work preserves human privacy, right? If it's patient records, let's just say the same disease model, we want to kind of combine somebody's model with somebody else's data. Is there going to be privacy risk? Will we be able to exfiltrate data from the other hospital, or will the model's IP, in this case the model weights, get leaked? These are all very interesting questions, and I think we need to deliberate these and build systems. I loved the way you stated it. I think today's systems were built for yesterday's problems, right? How do you build the systems for tomorrow's problems? And the systems that we've built, I built in my 3+ decade career, I've built many, many systems. But when I look ahead at even 2028, just 5 years from now, 3 years from now, I think the systems we build are going to run out of steam. So how do you kind of create that new system subtraction that will help you solve the next decade of problems? So I'm kind of fascinated about that as well. So frankly, I don't have a definitive answer because I want to keep my options open. But in my current work, I am focused a lot on privacy preserving compute. I feel like it's a really cool and very important space to kind of make progress on.
So essentially, responsible and human-centered system.
Innovation, absolutely.
Yeah, okay. And what do you think, Yogesh, about the same problem, same question?
So looking beyond a couple of years is very difficult in this day and age. That's reality, right? So I have no clue how things are going to be in 5 years' time, honestly speaking, right? So it's not just about the technology part, but all the consequences of technology, right, are going to have a sort of multiplicative impact, right? So we saw the Sasocalypse, that with all the Claude came out with a better sort of software engineering model, and that's it. The whole world got shivers, right? So how technology is going to sort of progress, it's not purely a technology problem anymore, given that there's so much investment going into probably compressing a decade's worth of research and innovation into like H1 or H.5 kind of 0.75 kind of thing, right? So, and that's going to sort of throw up things that we can't even imagine, right? So that's my sense right now, right? But a couple of things that, at least for the near term, right, from a systems research group, it's about how scaling AI is one thing that we are interested in, both on the edge and to some extent in the cloud, as well as how AI can play a role in solving systems research problems, right? So one fun thing that we are looking at, to me, anything, so we work on distributed systems, and this goes all the way till even drones, which are like flying computers for me, right? So we are looking at how can you actually use agentic systems to program drones, right? So you just give a single one-line prompt, and it goes off and does a farm survey and comes back and lands back, right? So that's stuff that sort of looking at AI for systems, right? But another thing that I'm also starting to look at in the last 6 months or so is what role AI plays in higher education, right? So imparting higher education, right? And we've had some conversations with Gitanjali and others as well yesterday. I feel that the university system is going to get obsolete, right? So in the next, maybe not 5 years, maybe 10 years, the way in which universities are run are going to be very different, right? And I think they have to be different. If it's not different, we are doing something wrong, right? So, and this is just my personal opinion. I'm not talking about IISc. I feel, or for any university for that matter, not just IISc, right? IISc might have its niche. But I feel that we had a trial last semester where I had an entire semester of cloud computing course taught by AI agents. Okay. I was just sitting in the room, right? And students were chatting. We had a bunch of prompts and so on configured, and students were just chatting for the entire semester with an AI agent on Teams Copilot. And my job was more as a facilitator, right? Giving the prompts, giving the structure to the course, the curriculum, and so on, right? We had some good TAs doing some hands-on stuff. Those are all good, right? But we were able to demonstrate that you could have a full-fledged PG course at IISc run purely using agents, right? So which means I just signed my death warrant in a sense as an instructor, right? But to me, stuff like that is the way to scale in a country like India, right? Where for every faculty like me, or for every student at IISc, there are probably 10,000 students who are not at IISc or an IIT, right? But who still want to not just in computer science, but in many other fields, who sort of need higher education, right? And that's something that we are, as a country, severely lacking, right? And the way I see it going, AI will be running a lot of the show in education, and universities will be a social construct, right? They'll give you structure, they'll give you timings to come to the classroom, they'll give you sort of friends, they'll give you hostels, dormitory, all those things are important as part of your educational journey, right?
And don't forget the Insta Reels.
Yeah, Insta Reels as well, right? So you need people to sort of take Reels with and all that, your cultural programs and stuff like that, right? But I think that's something that I'm experimenting, or some of us at IIC are experimenting, to see what's the role of AI in higher education. And that, to me, is a fun journey, right, for the next few years at least.
Very interesting to hear, actually. I mean, I think everywhere in all the industries, people are trying to reimagine how the workforces will evolve, be it a workforce of educational institute versus any company, factory, or healthcare, or that's what I'm just seeing, yeah. So, yeah. So thank you very much. Now I will just open the floor for questions from the audience. So, any questions? So there is a question. PK.
Yeah, thanks. So I have a question for both of you. What would Charu want an academic leader to do for PhD students? Because all of us are PhD students here. What do you think an academic leadership or leader should do that your job will be better? What, Yogesh, you want industry to do that will make PhD students' life better?
Sure, I can go, right? Yeah. Because faculty always have their cheat sheet ready when it comes to collaboration, right? So, anyway, again, I would love to see industry in India at least, right, engage closely with academia, but without very high expectations of outcomes, right? So literally, because one thing that I see is that in the few collaborations I've had with industry, things that are successful are where it's a joint engagement, right? So not just a sort of consultancy, I give you a problem, you go solve it, come back in every quarter and give a report, right? So, but I think having more closer engagement between industry and academia on sort of problems that are maybe slightly further out, right? And I know that's extremely difficult in this day and age, right? So maybe a couple of years back it would have been possible, right? But that, because I'd like students to get a sort of crack at some realistic problems, scalable problems, technically challenging problems, but not have to contend with sort of someone breathing down their neck, right? Sort of give me what's up next quarter, or next deliverable, and so on, right? And that's of course, students can, we do have industry collaborations, and that sort of helps. But doing it at scale, right, across many such institutions, not just at IAC, would be sort of helpful, right? And again, I can see there is a bit of a sort of, sometimes this might happen with some universities who are, or with some faculty who are doing a bit more applied research, right? But having some kind of a closer sort of engagement model that's still not deliverable driven, but joint engagement driven would be nice.
Super.
Great answer. Let me try the flip of this, right? I'd love academic leaders to coach PhD students or whatever, students coming out of universities to have more of a kind of long haul view, right? I think sometimes we, the thing is, right, like this, tech is this continuum. You constantly, you come in and then so much has happened before you and so much is going to happen ahead of you. And often the biggest value an education, especially like I noticed when in fact I was a PhD candidate at UC Santa Barbara before I dropped out. I came back, I'm a PhD dropout officially, right? I was supposed to go back for my PhD thesis, and then I decided I enjoyed being an intern in the company, so I came back for a full-time job. But then the skill that I learned in my master's program, which I thought held me in kind of good stead throughout my career, was that skill of abstraction. I think system abstractions continue to remain the most complex intellectually, right? And to create thought patterns and PhD students or master students who can spot abstractions and build them. Because the thing we're going to need over the next decade or whenever, right? I'll definitely have retired by then, is our current systems are missing tons of abstractions. And so it'd be good to have academic leaders almost like train PhDs to think in that abstraction model and bring that expertise, not the specifics. See, finally, people will throw all kinds of acronyms at you. They are almost uninteresting because when you learn an abstraction, then now you have machines that can translate it from abstraction to an implementation. And I mean, just think about this, right? The absolute cost of producing a line of code is asymptotically trending to zero. That just blows my mind. The fact that for the last, whatever, 30, 50 years, producing a line of code has been expensive, but because of this inflection, that is asymptotically going to trend to zero. So I think that means a lot of things are going to shift. So PK, I would say, I hope we gave you an honest answer. Thank you. Great question.
I have a question. You talked about a lot of things that are changing, and and Yogesh, you said you can't even predict what's going to happen in 2 years. That's fine. What do you think will stay constant, or at least not change for the next few years? Is there anything that you have that in mind that you would like to share?
I think distributed systems will stay intact. I'm kidding, but I think systems will stay intact. Like the nature of the problem will change, but the fundamental need for building something with the right foundational goodness will stay, right? Systems will stay because ultimately the only way you can scale technology inflections is by building systemically. So probably the only thing I think will stay constant is the ability to build systems. So if you're a systems builder, you're intact because you're going to know how to build the next system.
So I'd maybe add something to that, what Charles said, right? I think building systems collaboratively is going to be critical, right? So because I think gone are the days where you can sort of literally spend 3 months coming with a design, where there's a team of architects, and then sort of spending 6 months developing it, 3 months launching it, testing it, and launching it. That's all gone, right? So things have to happen 10x faster, right? And I think over there, I think the essential skill for any student today, right, is to sort of embrace some of these new technologies and see. I tell students, unless you're doing 10x better, right, you could be the best coder on earth, right? But I know one who's better than you, right? And that's probably a bot sitting next to you, right? So unless you're able to do 10x better than the student next to you who's not using such as AI-based techniques, you're going to be obsolete, right? So, which means that you constantly need to sort of keep up to date, right, with what's going on and apply it, right? So not just learn about it, apply it, build stuff, right? So just the other day, right? So my son, he's 8 years old. He likes cars, right? So, but he likes just the superficial stuff about cars, right? So I was trying to teach him, he's just 8, but things like torque and RPM, right? He sees all the dials in the sort of speedometer and tachometer and so on, right? I was trying to teach him that, right? But of course, there's only so much you can teach about basic physics, right? So I built an app for him, right? Not I didn't build it, Copilot built it for me, right? And within an hour, right, he could literally configure 3 or 4 different cars, right? And he can race them around, right? And he could set them up for different gear ratios and different sort of RPMs and engine sizes and so on. And that was a light bulb moment for him, right? He said, okay, now I can see it happening, right? I know that a 2000 cc car, right, can sort of go faster longer than, let's say, a 1000 cc car, right? If I have a sort of faster gear ratio, right, it accelerates more quickly, right? And I'm sure I could have built it in a week's time, right, in the earlier age. But I wouldn't have had a week's time, right? Nowhere I'm going to find a week to build stuff, right? So, but in an hour, this is up and running, right? So, and that's something that every student ought to be doing, right? You don't need to have an 8-year-old to do this, but you need to have problems, right? You just imagine problems, right? Or there are enough real problems, you don't have to imagine them. But go and solve it, right? Don't talk about it, right? Don't come up with an idea. Implement it, show me a portfolio of 100 things you've done the last 1 year, right? That are non-trivial in nature, right? That will take you places.
Great advice.
There is one question. This is a general question for Charu. So how do we prepare ourselves for like the post-quantum, for the quantum era, right? Especially in areas of cryptography like PQCU.
It's a great question, and I probably don't have a academically sound answer, but I'm going to attempt it. I'm rather uncertain about it. I'm sorry. I had to crack that. Hopefully somebody got that joke. But anyway, I think the thing about quantum and security, right, is you're going to have to come up with approaches where our current approaches are completely going to get thrown out of the window. So at some level, we need to falsify the things that we know. So in my opinion, I think it's going to be a bunch of research that you're constantly scaling that next hard problem. I don't know that there's like one big, oh, we've got the most secure kind of quantum-friendly, quantum-aware protocol. I think it's going to have to be built again on something that looks hard today, but then you crack it and then you kind of consistently crack it. And I think AI will give us almost the training to solve for quantum, because AI is disrupting at such a rapid pace that it almost teaches, it will show us the muscle we will need to kind of solve for quantum. But that having been said, caveat, I really do not consider myself, I was hoping that by the time that thing gets real, I would have actually retired, so I'm kidding.
No, yeah. So I think quantum, so at least on the computing side, it's happening. It's happening not as fast as AI, but faster than we expected.
We thought,
right? So than we thought, right? So the next decade, you should maybe not. We already have quantum computers, probably dozens of them all over, right? In fact, India will be getting 2 quantum machines at least, right? So one in Bangalore, one in Amaravati, right? That are coming over here. So there's a national quantum machine is very strong in India. Lots of research supporters getting into it. But again, at the end of the day, of course, for crypto security, there's an impact in terms of all the existing cryptographic methods being replaced by new ones, which are already out there, several of those, right? But it's also about recognizing quantum as an accelerator, right? It's like days of GPUs before you knew that GPU was actually could be used as a general purpose accelerator, right? So we are in that era, right? But I think there's a lot of work to be done on the algorithm side of quantum, right? Designing new quantum algorithms. They're open territory right now, right? It's a completely different beast. So I think from the computing side, there's a lot more challenges. At least on the crypto security side, there are some solutions that are quantum safe, right? Just to pass you through the next decade or so. Beyond that, we'll have to see.
Yeah, but I think in general, I definitely entered the industry where the Moore's law was holding, but now we are in an era where that law is no longer holding, and I think it does make you think like how much we're going to have to keep up, because I also worry about the dark web, I worry about the state actors, I worry about the threat actors that really have made this a very unsafe world, right? So I think humanity is going to have to think about this in very deep ways. We're already in so much trouble, I think, with all the nefarious stuff. So, but hopefully there's some bright researchers in the room who are going to crack some of these for us.
Okay. So yeah, thank you very much.
Yeah, it's one question. Do you want to stay there?
Yeah.
Maybe the last question.
Yeah, last question. Okay.
Hi, so I'm a master's student, so I have a lot many questions, but I'll ask only 2. One is, since you have said that kind of engineers are now catching on to researchers on solving important problems. So the first question is whether to PhD or not to PhD, if to PhD in India or overseas. The second question is, you say that we have to be on the cutting edge of learning things, building things, but most of the cutting edge things, they are cost prohibitive to students, at least in India. At the stipend that MTech student gets, working with the new agents or working with the new, let's say, hardware, H100s or A100s, whatever, they are at least $6 or $7 per hour and stuff. You get somewhat credits for some use cases, but it is very difficult to, test and build continuously. So how do we work with that? Only 2 questions. Thanks.
Sure, I can take a stab at them. So I think this is probably the best time to do a PhD, because you will put away the problem for another 5 years, right? And in 5 years, the world is going to be a very crazy place. So it's the best time to do a PhD, right? The most number of students I've seen join the PhD in the US was after the 2008 crash. Because people don't know what's going to happen to the economy, right? The best students I got in India was during COVID, the best PhD students, right? Because these are times of disruption, and the best thing to do in the times of disrupting, go do a PhD, right? You put away the problem. Whether in India or the US, right? So again, mixed bag, right? So in India, you do have some good schools. Some for a PhD, the advisors probably more important or equally important as the institute itself, right? And there are enough good sort of faculty in India who are doing world-class research, right? Sometimes stuff at IISc from a research perspective are better than the top 50 universities in, on par with at least the top 20 universities in the US, right? So just from a research perspective, right? But again, getting into a top university in India is probably way more competitive than getting into a top 20 university in the US, right? So those are some of the trade-offs to look into. Also the whole geopolitics and so on, right? Those things are always there, right? So, but I feel that doing a PhD outside India is good, if not for the technical education, right? More from the world experience that you get, right? I really sort of, my mind broadened because I did a PhD in the US, right? Even if the education could have been on par or better in IISc than in the US.
I'll take a slightly contrarian perspective. I think the world has flattened, right? Like, I feel, I mean, I may have not said this 30 years ago, but I think especially now, given where the country is at and the kind of opportunities I see emerging in the country, I have 2 young kids and I wish they would consider coming back to India at this point. My kids are in their, one of them is in their late 20s, my son is in 23. And I really wish we would, India is going to scale technology like no other country in the planet. I think we've already seen it, right? Like the UPI, the Aadhaar card, the India Stack, digital public goods. Where in the world have we seen such massive societal transformation, right? And the interesting thing is India is also kind of leading the global south. We have a tremendous leadership role in how we're going to do this, not just for us, but also for like Africa and the kind of countries in the global south. The thing that I feel we should not rule out is our technological prowess, our supremacy as technologists, right? That is definitely a good outcome I hope at some point we may be able to achieve as a country. So I think the world is flatter. India's in a very incredible opportunity to lead place. It depends on how we play our cards. And then the question on PhD versus master's, staying with the master's, I think it's very much a personal preference. Like what will make you feel great? Like, because you can't go wrong anyway. You get into a job, you're going to learn. On the job, you're going to have some deep learning, depending on, hopefully you don't land up in a dead-end job with a bad manager. That's like the worst experience. So please get the hell out of there if you get into a bad place, right? But I think you're not going wrong. I mean, for heaven's sakes, you've already got a master's under your belt. If you want to go grab that PhD because it makes you feel good, go for it. So make the decision intuitively, make it with your gut, and don't ask anybody else for advice. Just turn to yourself. You'll know the answer.
And maybe a brief stab at the second part of your question, right? So just to close it out. I don't agree with anyone who comes and complains to me I don't have enough resources, right? So I don't have access to H200, right? And I'm happy to do systems research, right, at IISc, right? Pick the problems, right? Pick the problem that you can solve, right? You can't sit in and say that, hey, I want to train a foundation model with 20 trillion parameters, give me 200 H200s, right? That's not the way to look at it. With what you have, what's the best you can do, right? That's the attitude to have, right?
Thank you very much.
If nothing else fails, Jugaad.
Yeah, that is what India is known for. Another. Okay, thank you so much, Charu and Yogesh, for this lovely insight on all different topics.
And I just want to thank Professor Yogesh. It was so fun being on this panel with you, and Alpana Dubey for your very insightful questions.
Okay.
Thank you.
Fully second that.
Thanks.
Thank you.
Hello. We sincerely thank our esteemed panelists, Charu and Professor Yogesh, and Alpana Dubey for the insightful and inspiring discussion. We truly appreciate for your time and guidance. Now, next in the list is the workshop. the Confidence Researcher Blueprint. For that, I want to invite Shriparna Saha for moderating this session. Please begin the session. Thank you.
Kind of a special kind of a workshop that we have planned. We named it the Confident Researchers Blueprint, and there are two, panelists, or I must say the experts, who will, give you some tips or suggestions to build 3 pillars. So basically, we named 3 pillars: confidence, influence, and personal brand. So how during your research you can build confidence, influence, and personal brand. So that is the motivation of conducting this workshop. So now I would like to welcome 2 panelists of this workshop, Ms. Radhika from Silicon Labs, and also Professor Lipika De from Ashoka University. So let me give a brief, introduction of themselves. So, Ms. Radhika is now the CIO of Silicon Labs. So she graduated from BITS Pilani. She is the customer and pupil-focused leader with 25 years of global experience in value creation using IT and technology. So she joined Western Digital as Vice President of IT to lead engineering services. She worked with Micron as Head of IT for India over 3 years. She contributed to various senior leadership roles across IT in GE Appliances and demonstrated technical expertise in relationship management and finance, skills to implement projects and run operations for functions across the business. So you can see that she is into leadership roles for many years, so around 30 years. And also let me welcome Professor Lipika De. So she is now the Professor of Computer Science in Ashoka University. So earlier she was a Chief Scientist at TCS Research, where she was heading research on the theme of economics and financial intelligence. So her research interests are in the areas of AI, NLP, and data analytics. Prior to joining TCS Research, Lipika was also a faculty of Department of Mathematics, IIT Delhi. And she was also elected as INE Fellow in the year 2021 and also received Distinguished Scientist Award by TCS in 2012. And Lipika has done her MTech and PhD from IIT KGP, and she is a very active member of ACM, and she is actively involved in various mentorship programs for PhD scholars and promote women in STEM. So with this note, so I really urge all the PhD students to come forward, because we are also having some exercises for you. So if you can listen to our discussions, that will help us, filling these 3 pillars. Like, if you can listen to our panelists, what they will be saying. After that, there are some exercises that we have planned for you. So if you can simply come forward, like we would like to make some groups with the PhD students. So that is the plan of this workshop. Yeah.
Thank you. Okay. Yeah. So can we start with a brief introduction, like if you would like to introduce something regarding this workshop, like how can students build confidence, personal brand, or influence?
Okay, very difficult question, that's what I would say. To begin with, certain things I would say is confidence is something that's what you have to inculcate, but as a confident researcher, I think what's very important is also to understand the vastness of the area of research, to actually accept that I may be good in what I am doing, but that's definitely not the end of the world. I have much, much more to learn. I think that's something very important to understand, or to me, that is confidence. So confidence is, I understand the area, I will understand what's going on, but I also have to understand that I am only a very small part of it. Should I go ahead with all of it?
No,
or
I have questions, yeah. So just maybe a kind of introduction.
Sure, definitely. First of all, we have big shoes to fill. Mr. Yogesh, Professor Yogesh and Chitra, they took all of you and at least me into a different world. It was very immersive, the deep conversation. So I'll try my best to give my point of view, which is useful for all of you. When it comes to confidence, I think I'm going to share my personal stories all through the process. So in the process, if it relates to some of you, fantastic. If it doesn't, just ignore it, right? When I look back, when I look at my job as a CIO now or in different leadership roles in IT, often I would doubt in making the decisions, right? Do I have enough data? Do I have enough to make the decision, right? The confidence comes from the data, right? I mean, all of you as researchers, for you, data is what is important for making the decisions, right? However, when it comes to leadership and industry, often what differentiates from the researchers to industry, and that's maybe the shift that I think during the session that I would want to drive is, how can you make decisions with what you have, with whatever the sufficient enough amount of data that you have, right? The leadership get differentiated in being able to make the decisions with what you have and not waiting for the perfect entire data set, right? And in the process, I keep telling, I think Chitra also reiterated to one of the question about listening to the gut, right? As much as data is very important, as researchers or even as leaders, often I tell people that intuition and gut are still in fashion, right? Because you as an individual, when you look at the problem, your data keeps telling you something, and then how do you add your own intuition and the gut, and then be confident about the decision, move forward and make a decision. And we can always come back and correct it, right? There's always more to improve.
Yeah. So let me talk about your early research phase, like when you were an early researcher. So when did you not feel confident as a researcher?
Not feel confident as a researcher. I mean, that's a very difficult. I wish you started with a more positive thing because that's what the starting point would be. So I think the key point for me was, if I just look at my journey, I joined maths to study maths. Halfway through, I joined because I didn't know much about computer science when I joined the 5-year program in maths. Halfway through, as I became interested in more computer electives were there, and I moved to it. I did an M.Tech. Then what started, attracting me was that abstraction. I think that's what we were talking about earlier, that there were problems in AI that were being solved. Many of my colleagues were solving vision problems where they were trying to recognize objects which had definite shapes, but they were occluded, or part of the information was available, etc. Now what started bothering me was still they knew what object they were recognizing, and it was not a generic representation of the object. And because I was always interested in language and semantics, so subconsciously I started moving towards capturing the semantics. How do you go about it? Now, in that process, I landed up at many places. I landed up at psychology, I landed up at cognitive science, and then I had to literally draw myself back and come back to AI and say I have to finish my PhD, and I really cannot, go around. So I remember I had a paper. That time we used to write to researchers to share papers, and then the papers would come after a month, and it would be a big thing to open the papers. All the research scholars would sort of come, oh, what paper has come? And I had called for a paper which was called How Red is Red. And of course, it became a joke in the department, but it's a psychology paper of 1958 trying to quantify how different people's perception of red. So that whole exercise of what we are thinking, how to quantify, how to still keep the generic aspects of it there, and at the same time go and solve something that could be done. So, it's continuously a process of confidence, self-doubting, trying to solve or get over the self-doubt, and then again come back to one more question.
Yeah, so that is the thing. Which is more difficult, like generating ideas or legitimacy or communication? Like,
all are equally important, but yes, I think for a researcher to survive, getting the ideas about what is the next problem that remains, to me at least, it has been a very important thing. And even for survival, somehow I feel you need to have a problem to solve, but as soon as you solve it, it's done. I don't feel so excited about it anymore. And then there has to be a next problem, without which at least I couldn't survive. So yeah, I have always felt that the journey has been more important than really reaching the end or the solution.
yeah. So Radhika, so same question for you. So when do you feel not confident regarding your some work or some research?
Right. First of all, this whole, maybe some of you would go through it. There are several moments when whether it's a crisis or at least personally, during the crisis or during the boardrooms, there are several moments where I go through this imposter syndrome, right? That's real, right? Am I good enough? Am I truly, is it real? Am I here? So there are those moments where the imposter syndrome is real and I go through it, right? However, again, I tell myself that, and one of the situation where I was truly low at confidence and I was not sure if I was going to be able to do it, and that might help students to relate to, is during the major crisis. I was with Western Digital 3.5 years ago. I just joined into the company and then took over an additional role of leading their global infrastructure. So their global infrastructure for a company of a $30 billion company had 90 sites globally with 13 data centers and 60,000 employees working. And 28th March, and it was my youngest daughter's birthday, and I was at a birthday party cutting the cake, and I get a call from my team saying, we are attacked. There was a cyber attack, right? And I was literally 2 weeks into that role of infrastructure leader, right? Leading this whole thing, sitting out of India with manufacturing in Asia and US and across. And CIO hiring was going on. So I didn't even have my boss in the job, and I was 2 weeks into the role. Right? I was so shocked. I was not sure. I was so low at a confidence, if I can think back, as to, I don't know if I can survive, right? I don't know if, see, I'm not sure if you can relate to, maybe some of you, when a company which is stock listed, if it goes through a cyber attack, it is a major setback. It's a question of company surviving and not surviving. Now it is about you being in the seat where it's a question of company and the 60,000 employees and their families and the stakeholder and the lot at the stake, right? And you don't have a boss to guide you. So CIO was not there in the seat to guide you. And then here you are sitting with US authorities. They don't go easy on you, right? It was the moment where 45 days, maybe first 15, 20 days, literally I could think of sleeping for half an hour to 45 minutes in between the calls. It was crazy time. All that I was thinking is, okay, it is straightforward. I had to tell myself I'm qualified enough. I can go through this whole thing, right? And then come back to basics, right? Problems in, I think one thing, I love this author, Eliyahu M. Goldratt. If any of you haven't read his books, please pick it up. He says everything in life is simple, right? Actually, it is simple if you simplify it. In that scenario, all that I had to tell myself every day is, what do I have to solve? Right? Only one thing I have to solve: get out of this whole ransomware attack. If that is the only objective, then that's all I will focus, right? I'll not worry about what happens to stakeholders, what happens to employees, families. The moment I clutter my head, right, I am complicating everything in my head, right? My only objective is to get out of that whole ransomware attack and do everything that is needed to do it. Even when I'm doing everything, I'm only doing one task at a time, right? So as long as I'm doing that task perfectly, then I'm walking towards that end objective, right? If you can relate to in your research and if you can simplify any problem to that level of ease of crystallizing it, right? Say, what is the end objective? Now I'm doing one thing at a time, walking towards that, right? So when I told that to myself, I think I started to see the problem a little more clear. My confidence, I continued gaining my confidence. And by the way, ultimately after that 45 days, we didn't pay any ransomware, and then we restored all the systems and company was back to operations.
Good, yeah. So, so the same question. So what do you think, like which one is more important, the ideas, communication, or the legitimacy, like when doing a research?
Maybe I'll take slightly a next version of ma'am's one. So I think as a researcher, ma'am definitely nailed her point of view about ideas being very important. Sure, I agree. And as in the industry, I have seen some of the fantastic ideas which are taken, and then they go through this phase, and then those researchers who are excited about that, they take it to a pilot or a POC, and then it dies, right? Because it doesn't excite. There's no more coolness after you solve the problem, right? However, when the same researchers turn to industry, usually we tell them about taking it to the closure, making it mainstream. Right? Your idea, as long as it's a pilot, it's a cool stuff, you will be looked as somebody who's sitting in your cocoon, and then you're solving your problems. How do you make it mainstream and then put it into the business, right? When you're working for a corporate, you have to show the real value. Right? I have one of these researchers in our company. His name is Raman, and he is fantastic. He takes a problem, he can explain it to an 8-year-old kid as much as he can actually talk to a professor, and then he can actually walk the problem through a board and then make it work, right? And industry looks to those kind of researchers, right? So if you want it to be only in the idea generation, probably then you need to identify those roles where you are in the idea generation kind of workforce, which are very few and limited, unless you are able to take it and then materialize it and make the value out of it, right? Any company in the business for some primary drivers, right? Revenue, increase the revenue, reduce the cost, and be compliant and stay in the business, right? Some of these business drivers are straightforward: manufacture more and take the product to market faster. If any of your ideas that are helping these drivers to or build better products, right? If it is contributing to any of it, you need to take it to the closure. Otherwise, it's a matter of you being seen as an expensive asset. Right? That's how corporates see it.
So can I just add, because
please.
you also added communication, how important
Yes.
it is.
Communication.
And I think I also didn't take it, and so, that's very important. So while we do agree, I completely agree with her that being an academic researcher is like on your own. You can experiment with ideas, you can do a lot, but being in the industry, it's a different ballgame altogether. Yes. And I think she has explained it very well. Let me just give an example, a real life scenario, not an example, where what happened when finally these two did not meet. So I was new to the industry. I was in the research division, so that time enterprise search was just coming in, and from the R&D, me and a junior person, we were sent to do a POC for a big Australian customer. And we did the POC, I listened to them, I prepared a kind of documentation, requirement specification, etc. It was really liked by the customer. They wrote back that, yeah, this is all very good. And then the junior person, he executed small things, and it was all fantastic for 6 months. Now, this had to be taken over by an account team to execute, and the company was not in a position to execute it to the level that we researchers had painted the picture. Okay? And it soon turned out to be a disaster. So they called me again. I went, I did some little massaging, came back, but then, it became a usual thing. Will research take up the project? Of course not. Research cannot take up the project, cannot do the whole building, etc. It became a very big issue. And at that point of time, I did a mistake. Not I alone. I mean, I was prompted by seniors also that you write, you do some, kind of communication, and it backfired across the whole company. Okay, so the point I learned over there was communication was very important. We should have had a thorough understanding among ourselves, taught the account teams properly about what to deliver. We should have understood our limitations as a company, research, everything together. However, one thing I just want to add, it's not just about the communication that we had. One thing I learned over there is industry is about a team. The way my seniors backed me, I mean, I could have been thrown out saying that, oh, you wrote that email, because everything else happened in closed rooms, right? But no, I was given complete support. My contribution to it was recognized. The project didn't go through. TCS didn't get the project. However, the whole thing that we learned as a team was how important communication was among us with the others, and how important it was to carry on everybody together and not just be about your own research.
Yeah. Very good point. And Shripana, one comment I want to add on that is, when I see researchers coming to industry, one aspect that are any ideators in the company, which is like my technical people, true technologists, right? They get, when they get frustrated, for the time it takes for your idea to go through. One big skill that you need to, if I'm sure you may be having it, you need to double down when you're coming to industry, is the patience. The number of iterations the idea has to go through, it'll drain your energy. Whether it's proposing a tool or a process, it'll drain ideas and patience out of you. So multiply your patience when you're here, when you're coming to industry. You need it a lot.
Yeah. So, madam, you were talking about your early days struggle, like searching for a problem statement that, during the IIT Kharagpur period, when searching for a problem was so difficult. So what do you consider as a turning point in your life? Like any kind of recognition or failure or rejection. So what do you consider as a turning point?
Turning point, of course, I think for me, because, there were multiple things that happened. So I was doing my research, then I had to shift to Delhi. So I was almost on my own during my entire research thing. So it was not something great. Okay, that's what I always felt. Okay, so the turning point was after I joined IIT Delhi as a faculty, and I started working with students, and the first PhD guidance happened, the first very good students who started working with me, and those were the times really when I started feeling very happy about the whole thing. And yeah, I mean, I would really say the turning point was, of course, getting into a system and not being on my own as I was throughout my research always after I left IIT Kharagpur. So that was not a very happy period for me. What I felt while I was at Kharagpur and later when I became a part of an ecosystem is, for a researcher, it's always very academic researcher, of course, it's or even in industry, it's very important to be in a group where everyone is equally excited about maybe their own work. Okay, so the turning points are always when you are in a great group where everyone can challenge everyone. It's not about saying yes to whatever you say. It's not like in the social media. It's really about challenging, it's about discussing and gradually growing your group. I can't pinpoint a particular point, incident, but that whole thing, when gradually you grow your own group, you become a mentor for many more people. I think that's really a turning point where it starts giving you the confidence that now you can also shape someone else's career. In fact, one of my teachers at IIT Kharagpur always used to say, your PhD is not what we guide you on, we judge you on. We judge you on your first student's PhD.
Yeah, that's one of the interview question, by the way. If you're attending the interview for the leadership roles, they'll ask you how many leaders that you groomed, right? Not just how good you are as a leader. So that's relevant there as well.
Similarly, Radhika, the same question. So what is the turning point of your career? Like maybe initial days there must be some struggles.
Sure, yes.
Yeah.
Maybe I'll do two turning points. One is, I come from agriculture, farming background in Telangana, and then first of all deciding to not marry and then work. Right, that was hard. My first time when my parents fixed my marriage, I was 17, and they said, "You're getting married. Here is a guy, and these are the dates." Right, I had to really fight hard. My father gave me a big slap, fell down, and then got up and then came to Hyderabad. So that was a big inflation point for me. Right, it was the moment, and after that there was no look back. So later I got married when I was 24, so I survived that. But the recent time when it came to leadership, my biggest inflection point is. And then after that, my thought process changed. My confidence got multifolded. When I went for this Kilimanjaro hike, I did the Kilimanjaro hike a few years ago, and I get goosebumps even today. Think about it. Have you ever seen any cancer survivors, right? If anybody in the room, hats off. If you are not, if you have seen somebody, the kind of confidence that they gain, right? Because they have seen it to the end, right? They went to the end, and then they came back. What else can happen? Right? Maximum you will die. They have seen it. And when I went through this Kilimanjaro, that's the exact feeling that I got it. I have seen it. 7 days, 7 nights, sleeping in those little tents at the high altitudes where you're not sure if you'll get up tomorrow morning and you'll be alive. After that, when I look back, I'm like, why did I do it? I didn't know. I thought it's fun. And then we went and did. And then by day 3, you can't come back also. Now you are midway. You have to go up only. Right? And when I did that, now when I could climb, 7 days I'm alive, I can do anything. After that, going into the board meeting, come on, that is easier than Kilimanjaro, right? So now for me, anything I relate to the Kilimanjaro, if I could do that, I can do anything else. And going back to my early confidence question also, again, there also one simple situation, right? What do I have to do? Climb Kilimanjaro. Yes or no, that's all I have to do. What do I have to do? One step at a time. That's all those Sherpas taught me there. Pole, pole, one step at a time. That's all I can do, right? Slowly, pole, pole is slowly in African, right? Pole, pole, one step at a time. That's all I have to do even in my work life, right? Pole, pole, one task at a time. And for you also same thing. In life we see that simple, after that, everything else is easy. That's my inflection point.
Nice. One step at a time, yeah. So now let us discuss about the influence without authority. Like sure. Maybe, initial researchers, like early career researchers, they must be struggling with, like no one is listening. Sure. Like, when you are just started your career, like what is the suggestions? Like how did you make people take your work seriously early on?
Sure. Maybe I will reflect on my experiences. If it relates to, that's even better. There are jobs, I have done some jobs where there is authority comes, right? When people are reporting to you, you are there doing their performance appraisal, you are giving their compensation and pay hike, and those roles in relatively easier, right? Because there is authority directly. However, I have done one mergers and acquisition role at some point in time where I had a large team, and from there I became an individual contributor suddenly, like a researcher, right? I didn't have any power or authority. I have to get work done with 200 people with no authority, absolutely no authority, right? And those are very time bound. I mean, in case if you can relate to, usually M&As, mergers and acquisitions, when a company buys another large company, now you have to combine 2 companies, and there are a lot of regulatory requirements that are involved. A single day miss costs a couple of millions of dollars. So you cannot afford to miss any timelines there. And here I was all alone. I have to get this done with 200 people with no authority. Right? Now, what came to my savior, and that's something that I keep telling everybody to consciously do now, is the interpersonal relations that I built. If any of you who are looking at the industry and thinking, oh, if industry can do hybrid work, I can sit in my dorm room and then I can finish my research, please do not fall for that. This whole hybrid sitting at home is a drama, song and dance, it doesn't work. Go out, talk to your co-researchers, talk to your friends, and build those interpersonal relations. Those go such a long way. right? During this whole situation of mergers and acquisition where I didn't have a direct authority to get work done, all that came to my survival was the relations that I built earlier with those people. They said, oh, that is Radhika, I know her. She talks to me at water cooler or she talks to me in the washrooms, right? There are times when you meet in person. So those relations goes a long way. Please consciously build your network and relations. Those will help you. And when you come to research and you come to industry, yes, go to office every day, show up, in hallways, shake hands, hug people, those who can appropriately, right? And then build those relations. Building relations go a long way for you for influencing without authority.
Thank you.
Collaborators. I mean, that's kind of written. Not colleagues. Colleagues, there's no authority situation. That's interpersonal relationship, right? In industry, it is interpersonal relationship. You need to solve a problem. You need some data for something. It's with somebody you met at the coffee shop, you came to know, or water cooler, all those discussions, and there's no authority whatsoever. They are not bound to help you in any way. If you can still get the work done over there just because of your personal relations, I mean, they may not be very cultured relations as such, you may be working only then, but it's how you communicate, how you convey the value for it to both them as well as you. That's how things get done. And when it comes to a team in the organization, of course, you do hold something like, they will need a year-end appraisal from you, but you have to remember, you will also be appraised at the top by somebody else, and unless your team works for you on their own, taking the ownership, you cannot get things done. And if you cannot get things done, then you are a bad leader. So in order to get things done, you will have to give that ownership. And again, it's your personal relations that you build with them, and how you communicate with them, how you make it look like a team, and where you are also a part of the team. And again, something I also learned from my bosses, as I'm saying, that when there's some success, it's credit for all. When there's a failure, you are the one who are responsible. That is something that all of us, I have learned from my bosses, and I think that's some thing that we have to learn to follow.
So, ma'am, which one is more important, lab meetings, having regular lab meetings, or collaborations, or going for a conference? Like, which worked for you the best?
It's everything together. I mean, regular meetings are very important to understand. Also, that whole thing that, yes, we are all there together. Some ideas spark through the discussions. Conferences have their own kind of thing. First of all, you listen to some people who are much greater, right? You go to a conference, you listen to a Turing awardee, or you listen to some ACM fellows and all of that. So that definitely broadens your horizon. You are listening to so many other areas. Plus, you are seeing a new place, and in that scenario where you are bonding with your team members, in that kind of scenario, you come to know different personalities of your team members also. Team members also come to know about you, different sides of you. Okay, so I mean, all these are important. Travel is a very important part of personal life, right? You have to embrace the new things. You cannot just hope that everything will follow as you expect them. So yeah, I think each aspect is important. They teach you different things.
Yeah. So, Adhika, so coming to the personal brand now, which is very implicit, So today, what do people associate your name with, and how did you build this personal brand?
Sure. Yeah, when Sriparna said the topic would have a personal branding, in fact, I went and asked some of the known members, hey, what do you associate me with, right? Because often we assume certain things, right? Because personal brand, often we think is what we know, right? That is something that often you get surprised, right? I feel, oh, I'm high energy, and then I'm fantastic leader that people want to look up to, versus when you ask your colleague, they're saying, she drains energy out of me, right? That's actually your brand. Right? We feel what we wanted to see it, but that's not real. So I asked my friends and some of my previous bosses as to, what do you associate me with? So what they told me about me, and then I suggest a little exercise for you to try out on the similar lines, is what they told me is, I come across as a calm and trusted person, especially during crisis. That's because many of the people around me have seen me handle several crisis moments, right? Be it one of the Western Digital one, or setting up a large organizations where there's a lot of crisis all the time, be it talent and dollars and budget and so on and so forth. So somebody who is able to handle crisis with a calm is how they see me as a personal brand, right? So during this process of me asking them, what do they think? Then I started to click down a little more, and I thought a little exercise that may be helpful for you to identify what your brand is, right? One question is, I started to ask in the last few days when this panel discussion came, is one is, what kind of problems people come to me, right? To me, people come to me when there is a crisis. Often, trust me, I've spent 16 years with GE. That's the longest tenure that I spent. And I never had same boss do my performance appraisal second year. Never. 16 years, no boss did my second performance appraisal, because I'm always moved on to the next crisis, right? I think that's how I built my personality. So now people look to me for somebody who's good at crisis. So what kind of problems people are coming to you is first question. So go check with your colleagues, or go check with your friends or professors as to what kind of problems that you put me on to. Right? You'll get one answer. Next one is, what kind of responses that I give when I don't know something. This is something my team members told me when I asked them, hey, how do you see me? Right? They said, Radhika, we love you for the fact that when you don't know something, you don't fake. You say, I don't know. My team members like that. Because as a leader, if I give an impression that I know it all, people don't appreciate it, right? Rather, they appreciate me for the fact that I say, hey, I don't know, tell me more. I'm extremely curious. Going back to Chitra's comment about being curious, right? I'm so shamelessly happy to admit that I don't know something. And my team members appreciate it, right? Because they are more intelligent than me. You guys are more younger and smarter. Your access to information is very different. And I don't act that I'm the smartest. So go and ask as to, when you don't know something, how are you responding? That will get you get more people towards you, right? So this is the second question that you need to ask. And third one is, depending on how do you want to pursue, how do you want them to pursue you? You decide and ask, if I wanted to be seen as this, what do you think I should be doing? So ask these three questions. It will give you a good reflection of your current brand and what brand you wanted yourself to be. Yeah.
Good. Thank you. Yeah, ma'am, the same question. So today, what do people associate your name with?
Unconstrained.
Okay.
You want an unconstrained answer?
Unconstrained answer, yes.
Handloom sarees. I'm sure if I ask anybody, to the extent that when my TCS team members gave me a farewell, they gave me a book on Indian sarees. Okay, other than Alexa and all of that. So that's one. I think more over time, I mean, I never really bothered about it. What am I being branded as? But because you asked that question, then I reflected. I didn't have too many people to ask because I'm in a new situation now where I don't know too many people. So I think it's being a mentor, and in a very generic way, not in a very specific way. So, I mean, my earlier in TCS, the younger people would always, sort of ask that, how do you handle all these things when your husband is in a high position? So sometimes I really have to go there and, smile and accept flowers and things like that. And the next moment I'm in some other meeting, etc. So how do you handle it calmly? And also, I mean, the pressures that usual that women have take up for home, for running an extended household which is open for students, guests, relatives, everybody. I think that overall thing would be about mentorship balancing different things together.
Multitasker.
Sorry?
Multitasker.
Multitasker, yeah. I guess nowadays, most people are multitasker. Now, earlier it was, women. But today, very happily, like she mentioned, she went to Kilimanjaro. I know so many people who are doing so many things. That's one good thing. Everyone has come out of their boxed images. Of scientist means scientist and they cannot be doing anything else. Anyway, that's gone now. So, yeah, I guess it would be about I mean, I had forgotten the name of this, and when someone was asking me, what are you going for? I said, resilient researcher. I forgot it was confident. Okay, so I think it's that aspect which actually possibly people associate me and they want to hear from me.
So, we have very limited time. We will start with some exercises for the students. So now finally some advices to students, like one habit the students they should start to build this confidence, influence and the personal brand. Like, if you can give some advice to students. Like one habit they can inculcate?
Of course, it's listening to various things. Like one of the things I find, when we have plenty of talks organized in the department, and then no one comes to attend them. I think it's the most important thing for students and researchers to listen to a variety of things, whether it's important, not important, aligned, not aligned, because that's how ideas will emerge. That's very important, one thing I would say. Others are pretty generic. I mean, you have to keep faith in whatever you are doing. You should be confident, as I again mentioned, in what you are doing, whatever you are thinking, but don't hesitate to thrash it out, and the moment you find that it's not going somewhere, you should learn to backtrack without any hesitation and pick up something that is new, that is aligned and so on. So a researcher's life, one thing is it's a endless same circle of inventing, reinventing, doing the same thing, coming back and still liking to do it, do some more of it.
So the same. So one advice for the students.
Sure. I would say nurture mind and body. Right? I thought I should give two advices, and then I started to think, how do I combine? So combination is nurture your mind and body. The way I do it personally is, and I wish I could have started a little early, is reading books. So combination of reading and listening. I try to do about 40 books a year. That's that, and then I combine the varied books. Right? I don't do one genre, one category. And how it helps me is broaden my context. Right? You take any of these ML models or AI, GPTs, etc. The response starts to get better when the models has got more context and the more data. Right? That is same as our brain modeling as well, correct? The more broader you nurture your mind, the way to do it is either listen to the talks or listen to podcasts or read your books. For me, it has been reading my books. Reading the books has been a very big one. And then nurture the body. Physically, please do not ignore your health. In the process of combination of this whole research work itself can be very exhausting, and that is true for even the industry. Many people sit hours together in front of computers. However, if you have to go longer in your career and then higher, you have to stay alive longer. Health is important. I don't end my day without completing all my circles. That's a mandatory thing for me, and I coach this to all my mentees as well.
Okay, so I hope this is, summarizing whatever we have discussed. So these are the three pillars: confidence, influence, and personal brand. So whatever panelists have discussed, so I hope this is summarizing these three pillars. So for confidence, you have to be clear about what problem you are solving, own uncertainty instead of hiding it, and track progress, not the perfection. And for influence, you have to frame ideas simply, ask good questions, And for personal brand, you have to keep asking what topic do you repeatedly show up for, and how do people recognize your thinking. So I hope this is clear from the panel discussion. We have only 10 minutes and we have a couple of exercises for you, but before doing that, can you make some groups of students? Yeah, can you help me in making some
Sriparna,
groups
depending
of
on how many groups you want, you may just make 3 groups, 3 sections.
Okay. So I initially thought of making 5 groups, but okay, we can have 3 groups. So these are the exercises for some students. So if you can just make some groups, then we can do these exercises with you. And we have 2 experts. They can give you some expert opinions. Is it okay? Can we start? We need to discuss among yourselves.
Personal relations with people around you. Just makes few small groups. You don't have to, not everybody needs to be in a group, but makes smaller group. Okay. So then you can stick to your seats. That's what ma'am is saying, that in considering the time, the first one of groups per se probably is stopped, and rather I think they want to go with the second one. This is elevator pitch, right? When you meet, let's say you are now in industry, and then you meet with Sriparna ma'am in the hallway. Right, and then the first question is, hey, I'm so and so, I'm Radhika, and I do this so and so for my living. Similarly, if you have to talk about if you get 30 seconds with somebody who is influential, who can get a funding for your research, what would you tell about you? Right? If you have pen and paper, or if you're a mobile person, you could open a mobile and then write about your maybe current research. Take your current research. If your research requires funding, and if you have 30 seconds to explain about your research, what would you tell about your research? Right? So, ma'am, so you're saying they'll take maybe a minute, and then after that, randomly, anybody want to raise their hand?
And then we will invite one of you from the group, and please come on the stage and give us an elevator speech.
Or you can pass a mic as well.
If you are ready also, you can, now also you can come, yeah.
About your research, if you have to get a funding, what would be a 30-second explanation about your research?
Yeah.
Depending on how good the pitch is.
You need more funding?
Okay. So are you ready?
Any bold one?
So group 1 wants to come on the stage.
Or pass the mic, if that is easy.
Yeah, so.
So basically, I am working on making sustainable autonomous pipelines. So we have autonomous pipelines which use LLMs, and these are called thousands of times. So what I'm trying to do is like reduce the cost as well as the emissions of it, like that are made as a consequence of these LLM calls, by kind of designing systems where we can choose between like cheaper versus expensive and large models, and like hopefully like it has a good impact, because such autonomous pipelines and agentic pipelines are being used everywhere, like for scientific discovery, also in many platforms like AlphaEvolve, etc.
Okay, first of all, thank you for being the first one. It's always hard. We'll do that. If you do that now, I think others may be hesitant in coming up.
So,
Anybody want to explain your research in 30 seconds? It's okay if you take.
Yeah, so 30 seconds, I guess. Huh?
You can take a little long.
Okay. So, hi sir, my name is Soumitra Ghosh. I am a very young researcher, not by age, but by experience. So what I want to do is, we have a competitor called Oxford Nanopore Technologies. So right now in the market, this personalized medicine is very famous. It will be the futuristic technology. So what we want to do, we are just doing a baby step now. We are doing the sequence alignment, and here we are trying to build some kind of software on a hardware Now, we are struggling a lot with the hardware. If we get some kind of funding from the hardware perspective, then it will be great. And the future run, maybe we'll reach that goal. But first of all, we have to take a baby step. So that's what my pitch is. Thank
Cool.
you.
Purpose is very clear. All the best.
Anyone from the first group? From this side? Yeah, please come.
Hello all, I am Dr. Chanchal. So I am also a young researcher. So currently I am trying to study the effects of mobile screen time for the children of people suffering from ADHD and autism. So currently it's in study found that people who are suffering from ADHD or some neural disorders, their children are also getting affected, not directly, but with this mobile screen time and how many times they are opening the related applications. Like let's say if somebody is suffering from ADHD, maybe I am sitting in this conference or in this workshop, but still I am just opening my WhatsApp regularly. There is nothing, no notification, nothing, I am just opening it. So I am trying to do a study on this, so how this is actually affecting others. So I am trying to do this. Thank you.
That's a cool problem, right? I mean, I call it diaper check, right? You open the mobile, keep checking if you got a message, right? Diaper check. It's funny, but a very, very meaningful one. Good luck for you.
Okay, so maybe you two can
I will
take
let
some
ma'am do
suggestions.
Oh, okay. First of all, thank you for three of you to raise your hand and do that. I think one of the mantra that one of my mentor told me was, if you cannot explain your problem in one sentence, your project or research is already in question, right? So I think they have been able to, they have tried well, and I think for the first one, it is too deep, it is too technical. I think you lose the audience. Again, depending on the audience, you may have to tweak it, right? If the audience is too generic, including someone like me who is not as technical as you are, then you may want to explain the purpose a little more, right? The moment you explain the purpose, it sticks very well, right? A personalized medication, then it sticks, right? Or the mobile utilization, then it sticks, right? If you take a purpose, then I think it sticks around much faster, right? And then another view that we suggest anybody to add when it comes to this elevator pitch is what is in it to the other person, right? One is what is in it to you, why are you doing it, and other one is what is in it to the other person. If you're talking to a CEO or a company president who has to who has some influence on your research, then knowing that person a little more and having some common ground would actually establish a lot more stickiness, right? For example, it could be as simple as, let's say, the person is more interested in maybe it is easy to take for a CEO. If the person is interested in golf, right? Then if you have something stickiness that you could add to the elevator pitch, the stickiness is higher. Or if the person is a book reader, then add about that book reading, right? Okay, instead of using so much of mobile time, I think kids need to spend more on book reading. Then there's a stickiness, right? Usually as a human tendency, when there is a common ground, stickiness is higher, right? So find something common ground. Or maybe you know that person is from maybe Uttar Pradesh, right? And then you might want to say that, oh, by the way, you know what, in Uttar Pradesh, the stats say that the mobile utilization percentage is XYZ. Then there's a stickiness, right? So that's one advice. When you're building elevator pitch, one is a purpose, and second one is find some common ground and what is in it for the other person. That's my advice.
Yeah, so, I mean, perfect. So you have got the feedback. One point I would like to add is also, why are you doing it? Yes. I do understand that, you know, the ADHD is increasing, I will be counting, but then what is my counting going to give to the society? The problem doesn't end in counting or knowing how to track it, but how to overcome that particular problem, and then what it would mean for society when you are solving it. I remember the last one, so I said I liked your problem also because it is a burning problem. So saying that I'm working on something which will help address it in this particular way is very useful. The same for the first one. I think the second person was closest to it to say that, what's the purpose of a particular problem being added. And that's what I would just like to add to what Radhika said.
Yeah, so sorry, we are running out of time. There are so many exercises we planned, but I think we will not be able to cover none of these exercises. PK is looking at me. Close it, close it. Continue. Okay, so some closing remarks. So please try to write privately. So one practice, I hope this will be useful for you after this workshop, that you want to start building, in order to build your confidence, personal brand, that one practice that you would like to start from this month, and also one fear that you would like to stop hiding behind, okay? So in some personal cheat or privately you can write down. So with this note, we really would like to stop here, and many thanks for attending this workshop, and many thanks panelists, Lipika ma'am and also Radhika for giving beautiful advices for all our students. So many thanks. Yeah.
Thank you so much. I hope it's useful. Good luck for your research.
Thanks, Shriparna, for moderating the session so well, and also Professor Lipika and Ms. Radhika for giving us insightful and their life-inspiring stories. Now we'll take a quick break for 15 minutes. 5 minutes? Okay. It's a literally quick break, so it's just a 4 minutes. Just go back, grab your cup of coffee and come back to the auditorium so that we can start next session. Thank you. So for this highly interactive fishbowl session on how generative AI and agentic systems are transforming research and industry, for this session, I invite the moderator, Professor Manik Gupta from BITS Hyderabad, to lead us. Ma'am, over to you.
Thanks, Sakshi, for the introduction, and a very good evening to all of you. As Sakshi already mentioned, my name is Manik, and I'm going to be moderating this session. So what we are attempting to do today is we have tried to put together a panel session. We usually do this static panel session. So we thought of doing this turn on a usual panel session, and we call it the fishbowl session. And what we are going to do as a part of this fishbowl session is we are going to have more engagement from the audience. So we will have some of the panelists sitting here on the chairs, as you see on the stage. I'll be now inviting our panelists for this session. So first and foremost, I would like to invite upon stage Professor Meenakshi D'Souza, who is a professor and HOD at IIIT Bangalore and is also the president of ACM India. Welcome, Meenakshi. Next, I would like to invite upon the stage Dr. Gitanjali, who's an associate professor in the Department of Computer Engineering at Pune Institute of Computer Technology and also the chair of ACM India W. Next, I would like to invite upon stage Dr. Alpna Dubey, who's a Innovation Research Principal Director at Accenture and also serves as a board of director at iHub Divya Sampark at IIT Roorkee. And she's also the vice chair of ACMW India Council. And last but not the least, I invite upon Dr. Radhika Mamidi. She's an associate professor at IIIT Hyderabad, where she also serves as the program coordinator for computational linguistics and the dean of the student affairs as well. So welcome to all of you. Thanks a lot for your time. As I would like to now explain the structure of this session. So basically, if you can see on the stage. We have got 6 chairs. Alpna and Radhika, I would request you to move to the center of the stage. So I'll be seated on one of the chairs, and we have one chair empty there. So what we are going to do is, after the initial, introductions, what we are going to do is we are going to have some themed discussions and some dedicated questions, where each of the panelists will put down their thoughts, but we would also invite students to talk and share their opinions or voice their thoughts here. So, and once you have done that, we would like students to, rotate on a regular basis. So that's the whole idea. So we will proceed with the session now. And I would just request each of the panelists now to give a brief introduction about themselves, and also tell us what has been a key transformation that they have observed in terms of using agentic and generative systems in the past 1 to 2 years. Over to you, Meenakshi. Yeah.
Yeah, good evening. My pleasure to be here. I'm Meenakshi. I work at IIIT Bangalore as a faculty. Before that, I worked for Honeywell Labs in Minnesota. Generally been in the industry and academia for about 23, 24 years. And I've also been volunteering for ACM India, currently serving as the president of the council. So when Manik asked me about this fishbowl session, there were two things that were new to me, because I had to understand what a fishbowl session was. One is used to panel discussion, fireside chat, so I Googled, and obviously Gemini tries to tell you what it is. Then the next thing is, the topic was Gen AI and agenting systems transform research and industry. I'm several steps backward. Till date, I haven't used ChatGPT. I don't think it's caused a dent in the quality of my life, academic life, personal life, and otherwise. So I said, oh my God, this is going to be interesting. So I said, okay, maybe, somebody needs to give a contradicting view, and I could play that role in the fishbowl session as a non-user of Gen AI and agentic systems. So, I mean, you try to be a non-user, but then it's there around you, I mean, in the smart board that I use in the classroom where I teach a course on algorithms, if I open it, there is a little panel. You move your mouse around, an assistant pops up saying, do you want help? And it takes a while to shut down. And when you search, normally you're used to seeing Google results, which we are all used to several years now, whether we like it or not. And instead of Google results, now you stop at what the Gemini gives you right in the front. Maybe sometimes you're tempted to click on it and see what it gives you. And then the ads of Google come. So they are there to take over, but honestly, I would like to wait and watch.
Is that your take? Okay. But has it been impacting your research in any way, or your teaching?
No, I don't use it. So
at all.
yeah.
Okay.
So
but do you see your students using it? Is that?
I think they use it a lot. My students use it. My children use it, and I've held up. Let's see.
Okay. Over to you, Gitanjali. So how's it been transforming your life?
Yeah, definitely. There is great contribution nowadays of the Gen AI and agentic AI in our lives. And we can see around, people are very much curious what will happen next, and whether these jobs will stay in the market or not. Even research, we had very good panel discussion at our institute last month, and most of the questions were around, we have spent 6 months to surveying our research topic and all 4 years back, and what conclusions we are drawing. Nowadays, all the tools, summarizing tools, are giving better results and very fancy language and tables, better than what we did in 6 months. So I feel this is the impact of the Gen AI on the research. And transforming life, yes, definitely. So I'll take small example on which we are working. We are working on voice-to-voice agents for the voice-to-voice. And here the latency is the main problem, like whenever somebody is talking from other side, so AI agent, it is searching in the corpus, what is the sentiment of the speaker and what answer should be given, what are the probable things and all that, we are working. So I feel then I am little bit, I feel good because human brain, we are not thinking what to talk now next, what is the sentiment, but at least agent has to think. So I feel good. At least there we can defeat. Yeah, that is my
So you
takeaway.
do trust the agents to do the job for you? Do you?
Yeah, I feel we can't avoid it. That is the era, right?
All right. So over to you, Alpna. So coming from the industry, what is your perspective? How has Gen AI or agentic changed your life?
So if I talk about personal life, professional life, I think both the ways agentic AI and Gen AI is helping a lot. Of course, there are fears, but I have used it to generate exercises for my daughter, like just giving that what should be
She's not generating on my own because my daughter just generates. She had an Olympiad exam. She just created exams on her own and did her tests on her own. I mean, she didn't even
No,
ask me.
she is too young. I mean, I'm talking about my younger daughter.
She's 11. So I mean, that's
yeah.
amazing. Right?
So yeah, so that's where I am using it so that I mean definitely it is saving a lot of my time because time is very crucial at at this stage of my life because there are so many personal as well as professional responsibilities, and if you have to deliver everything, I mean, Gen AI based tools are helping. But at the same time, what I'm seeing is that, as you asked the question about trust, I don't use it just like that. So when I am using it for research purpose, for example, to understand about a field, what is going on, I do a lot of deep research using Gen AI tools. So I ask further questions, go on, try to see the references. I have seen that ChatGPT, Perplexity, all of them does a lot of hallucination. They even give a wrong citation, which doesn't exist. So all those issues are there. But it definitely helps you to do things quick when you are time crunched. It also helps you to increase your creativity beyond what you could have done. So maybe it would have taken some more sleeping on the idea for you to come up with something interesting. If you have a little bit of idea, you start interacting with Gen AI tool, you get more idea, you can further expand on top of it. So definitely as a human plus AI as a concept is very powerful. Maybe not just, I don't believe in just pure AI play.
But is it also changed your life, your professional life, in how you seeing your
Yeah,
career?
I'm able to do, I think, more deeper research faster, as well as in the professional life earlier, to build any concept, to make it to a life, I had to rely on junior resources. But now I do it on my own, so I use different kinds of tools. For example, use Lovable, you use GitHub Copilot, and you use Claude, and then you have some idea that how this type of concept would look like. So instead of creating slides, you actually can build a very small concept very quickly. So earlier, to present a concept, I used to just prepare slides, but I also now try to build something if it is possible in a short time. So use it as a vibe coding tool also, just for my own research purpose. So it is definitely changed the way I used to work earlier.
Okay, so it looks like definitely helping Alpna at both work and home. So how about you, Radhika?
So last 2 years, you're saying?
Yeah, so
Okay, for one, I will say for the audience sake, I believe in magic, and for me, Gen AI is nothing short of being a magic. So I'm one of those who started with I'm a linguist, then I became computational linguist by my first job at CDAC Mumbai, working in machine translation, rule-based method, So one sentence, for example, from at least 3 decades we took to build machine translation for English and major languages like Hindi, Telugu, all that. Right, and my new project, we are focusing on indigenous languages like Santali, Mundari, Bhili, Gondi, So within a 1 year span, we were able to build machine translation models for these languages. So how was that possible? This was using the multilingual models we were able to build for low as in lowest resource language. We were able to do that. I think is a transformation at the language base. Personally, I would say like my time is being saved. Okay, if I have to read a paper, I don't have to read from abstract to the conclusion, right? I can just ask for the gist of it, and if it's really interesting, that's when I'll go and read the full paper. I can also ask certain questions to understand what the paper is about even before reading it. Earlier, what would happen, I would read, and then, there would be some disturbance. I could not finish the reading. Then next time I go to read the paper, I have to read again from the beginning. Now, it is making notes for me, it's doing. And rightly said, I actually use a lot to understand. Again, my other research area is language understanding. So I really want to know how it is doing it, right? So I see that references, citations is where LLMs have not caught up yet. They hallucinate, they create references for you, okay? So one advice to all the students here, okay, don't depend on LLM for, just ask 10 best papers in this field. Don't do such, I mean, you can still do, but go and cross-check whether those papers really exist or not. Other important area where I will see we are benefiting is creation of data sets. Again, most of our students, I mean, we believe in human in the loop, we evaluate it, but again, generating data sets using LLM, that has really saving our time.
Okay, so just to summarize, I mean, what I understand is definitely increasing the pace of your research, right? But though there is a deeper question associated with it, how about the academic rigor? So I think I'll ask you that question. Meenakshi, are you ever going to pick up generative AI?
No, there are 2 parts to the phrase in the title, right? One is generative AI and the other is agentic systems. So I think all of us in this audience know the difference, right? And in fact, surprisingly, you ask these Gen AI machines about what an agentic AI is, they will say, hey, they're not yet there. They're not reliable,
so
right?
I think all of us are using generative AI in some way or the other.
Yeah,
but
the
not
agentic. Yeah.
The agentic systems are still not, I mean, of course, systems which will be able to reason and, act on your behalf. So I think we're not there, we're not using them in our personal lives as of now.
Right, right. Yeah, definitely not using agentic AI in our personal lives. Generative AI, I mean, as far as my personal life or this thing is concerned, is that I now maybe don't go down the Google search, maybe stop at what...
the question is, are you going to pick up for your research purposes?
I don't see it. I mean, my research involves working with these systems in the sense that I do have a lot of sponsored projects where we work on testing and verifying ML algorithms, and obviously testing and verifying. So I work with ADA, for example, which wants to use ML for fighter aircrafts to do target acquisition or path planning. They want to use RL for path planning. So we do work to some extent on testing and verifying ML algorithms. Testing and verifying Gen AI is a different ball game. Testing and verifying agentic AI is a different ball game. So as far as research is concerned, maybe I will keep up this thread, because I do like to test and verify various applications. And if these are trending, maybe whatever it takes to test and verify, we would do that. But I won't use Gen AI, like Radhika rightly said, I mean, if I have to do a literature survey, if I get down to using it, even if I use it, I would spend enough time cross-checking what it's saying. So I might as well, get to doing it myself to some extent. But for my research, I would continue to work on an active class of problems that test and verify these kinds of applications.
But then how about your students? How do you assure whether your students are doing the job in a proper way?
No,
I
they
mean,
are
how do you-
not. Obviously, all of them, every single student will use all these things. So, like for example, in the courses that I teach, just to give you an example from a typical academician's life, I've stopped giving take-home assignments. There's absolutely no take-home assignments because I teach courses on discrete maths, computability, design and analysis of algorithms. I also teach one course on software testing. So every single quiz is written by hand on pen and paper and corrected so that they learn the concept. Nothing is online. And so, I mean, the other thing that I struggle as far as this is concerned, not necessarily related to Gen AI and agentic systems, is that, the attention span of your students is reduced a lot. And that is something that is worrisome. For now, there is a lot of hype in terms of these students using it to ease, so-called ease their life, but I don't know whether it's good for them in the long run, whether it results in, thinking about deeper questions that matter, or it just makes their life even more fast-paced and maybe they don't worry too much.
Right. So how about you, Gitanjali? Are you also facing
Yeah.
similar issues in your university, and how are you dealing with them?
Yeah. Generative AI, I feel agentic systems, even though first I'll handle that. And she said we are not using it yet, but even though they are not mature enough, but we can't escape from them. We don't know the websites which we are using or the systems which we are using, what they are doing with our data next and what is happening. So we don't have any escape for agentic systems as well. That's what I feel. And my students, like, I think all the students, they are very much habituated to use generative AI. It is killing their creativity. And even though they don't want to, now I'll wear my hat of the training placement officer at my institute. Currently, I'm holding that, and I'm facing problem. The platforms of the companies are not mature enough to avoid the co-pilots and all. And even though we tell hundreds of times to the students, don't use Copilot, it is restricted. We're getting all the footprints, what you're doing and all, copy paste. Still there are cases like students can't resist their temptation to use it because they are very much, you get prompt, right? So it is with your browser, you get prompt for the next. So there is no escape for this. So we have to be more, professors have to be more smarter than the students. And we should create such a problem, such a scenario that, for which the Gen AI models are not trained, and that can be one googly for the students. And I agree with Meenakshi. All the work which you are taking from generative AI should be verified once by you. That is
Okay. So now that we've heard from the professors here, I would like some student to just come over here and put down their perspective. What is their thought on usage of generative AI for the research? Why don't you just come here? So in the meantime, you can talk about. Yeah, I think I'll wait for him to come. So in the meantime, Alpna, what do you think? What's happening in the industry? Do you then trust your co-workers, or how do you verify their work?
We are asked to use co-pilots and be more efficient. So we have to be efficient, and we are asked to use Gen AI tools. So I think there is a difference between the student life and the professional life. Student life is the time in which your neuron gets wired and you develop the critical thinking and the way you have to solve a problem or approach a problem. And that training is definitely required without Gen AI. I absolutely agree, because if at that time we stop using our brain and just be relying on the everything for the generative AI, it is not going to grow our mind. But during professional life, as you know, this is driven by business. If everyone is using Gen AI, every firm is using Gen AI to be more efficient and more profitable, then single firm cannot just stand on a value of not using it. So this is something which will happen, and almost all the firms are actually adopting these tools. Yep.
Yeah, sure. Hi, I'm Poojan Shah from IIT Delhi, and yeah, I'd like to share.
So you should tell us that how is generative AI changing the research workflows for students?
Yeah.
And then how is it making the pace of research faster for you? But do you also trust it?
Sure.
As a student, yeah.
Yeah. So okay, like looking at the current capabilities of models which are like used for coding, like agentic models. For example, many of the people would have used Claude Code. I don't know. So these, like, if you give precise instructions to them, these systems are capable of executing very fast. So for example, the thing about research is, let's kind of put aside theory research. Wherever you need to do some empirical kind of work, right? The faster that you can iterate, the more ideas you can try. So for example, currently the models are at such a capability that I can just tell them, I can provide PDFs of, let's say, 10 papers, links to 10 data sets, tell them to benchmark all of these algorithms, implement from pseudocode to like very high performance C++ code, and they'll do it in like 5 minutes.
Do you learn in that process?
The thing is that it's like learning and research are a bit different. So for example, let's say I want to benchmark my algorithm against 10 other algorithms. Sure, the more time that I spend doing that, but then there's this trade-off, right? So like one would say that tool, like really you need to understand what your computer is doing. You need to take care of every electron का क्या transition हो रहा है, transistor कैसे काम कर रहा है, how the binary code is compiled. Sure, that will give you a very deep understanding, but are we willing to like what's the trade-off here, like time versus that kind
So
of
do you
thing?
think that's not important? I mean, what do you think? I mean, you're also speaking on behalf of the other students. What is the general perception?
Yeah, so like understanding things is important. For example, like as a computer science student, you should know how compilers work, how things are, how C code is converted to assembly code. But you can still just write in C code and not care about.
But I'm
assembly
talking about
code.
writing your algorithms from scratch. I mean, is that not important at all?
Oh yeah, that is important.
Do you verify your codes, the ones that are generated?
Yes, so you can, like, for example, write your own tests for testing the code. So that kind of works out.
So I'm not sure if every PhD student does that, but thanks, Poojan. I think we'll go ahead with the second theme, and then I'll ask one of your friends to.
Yeah, sure.
Thank you so
Yeah,
much.
thanks.
So yeah, okay. I think with that, Radhika, I have a question for you. Given that you do a lot of community-driven work, and particularly with the local communities, right? So what do you? I mean, you already mentioned that it is a very powerful technology. It's going to make a lot of difference to the lives of the underprivileged, right? But do you still see some barriers where these technologies can fail and are yet not up to the mark? I mean, do you want to share thoughts on that?
I will say that, most of us here, I will say all of us who are in this room are privileged people, right? This I was just mentioning in the other meeting we had recently. So technology is here and it is dividing us, right? People who don't have access to technology, people who don't have access to education, people who don't have access to, say, English language or any language where we are using technology in, LLMs, how good are they in Indian languages, we don't know. Even if they are very good in Hindi or Telugu or Tamil or Bengali, do these people know how to read and write in those languages, right? So are these technologies, widening the gap among the people? Is it coming as a barrier? Or only for the privileged people, it's, providing solutions? So those questions we have to take into consideration when we are talking of building these tools, to make our lives better. So in that sense, we are saying whose life, are they only people who have access to technology? We are considering their life to be better. And while there are people, like in my, again, this project, for the indigenous languages. There are people who don't even have access to many things. Internet, chodo, electricity also they don't have, right? And we are talking about reaching out and making lives better. So, you know, so we all live in one glass house, and there are others who don't even know what is coming. So it's very difficult to even stand in their shoes and think about how technology will change lives. So it will change life, but only for a small section of people, I feel. So technology should bring all of us together. It should not be something that is dividing us amongst us.
Yeah, so I think thanks Radhika for pointing that out. I think though we might all feel that we are experiencing the spring of AI as of now, but it is still limited to only a few privileged ones, and I think there's still a lot more challenges that need to be tackled, right? So Gitanjali, you wanted to say something?
No, just I feel suddenly due to pandemic how all this GPay came out. So similar some applications will come, maybe voice understanding in the Indic languages, and maybe technology will become accessible to all the sectors of India. That's what I feel. I'm very hopeful about it. I don't know.
So, for example, we have, say, when we reach out to any funding agency like ministries, government of India or anybody, or go to any industry like Google, Microsoft, anybody, right? Why will they be interested to fund in languages that is not going to bring them any profit, right? So market is a big thing. So there are, say 300 languages. Okay, 800 language. We don't even know how many languages we have. Okay, let us even put down the number to 50 active languages, right? So we don't have tools to build in so many languages. We don't have resources. We don't have money to invest in those languages. So what we do, we tell them, okay, you learn English, you learn Hindi, you learn the major languages, we'll fund in those languages. And then, when we talk of NEP and we say, early education should be in your mother tongue, and we don't even have a medium of instruction in those schools. So, so we are living a, dual life where we speak something and we implement something else.
I think I do agree with you. So I would like some student to join us here and share their thoughts if they're working in this area. And what do you think? Do you think we are living in this fool's paradise and discussing all this while it does not make sense for a whole lot of population in this country?
Yeah, while the student is coming, I would just like to add, I mean, I can't agree more with Radhika, but it's also, I mean, it's one about a large fraction of a population in India, being like this, but it's also equally like, for example, somebody you take like my father, 80 plus, and he just doesn't understand technology. He's happy watching a YouTube video, can't use GPay, forget about Gen AI and AI research, right? And aging population, lots and lots of them are there. So it's of absolutely no use to that community at all.
Yeah, sure. So what are your thoughts on this?
I would I'm Anagha. I'm from IIIT Hyderabad. I'm doing my PhD under Professor Radhika Mamidi. So I believe that things will change eventually. People did not know how to use Google as well, but today I am sure. So
she belongs to the younger generation. She's more hopeful, I think. So how soon do you see average Indian, like maybe a below average Indian using generative AI? What's your prediction?
Hopefully in the next 2-3 years,
Next
I see.
2-3 years, okay.
Because, like I said, I mean, I just wanted to complete my statement. People did not know how to use Google before, but now when I go to my village, a small village in Karnataka, I see a lot of people actually using Google to search for some agricultural information and so on in Kannada.
Do they use voice search or do they type?
No, they do voice search as well. They do typing as well, but mostly in Kannada. And additionally, now I wanted to take the example of how Charu ma'am was telling Instagram reels. Everybody watches these things. So slowly.
Just addition, WhatsApp AI.
Yeah,
Automatically
yeah.
you're getting, and those who are using WhatsApp,
Yeah.
everybody is using WhatsApp,
Yeah.
and you get AI assistance.
Yeah, I mean, there's no doubt that today we do have that division. Not many people are accessible. It's not accessible to many people. They do not know how to use it. But I think down the line, it will be something that many of them will use.
But I have a question here. So I mean, I feel that the youth, the rural youth, possibly use YouTube or Instagram for watching reels. But do you think they also use it for increasing their productivity? Or skill building, for example?
Okay, yeah, that might not be the case.
But it is not a problem of AI, it is problem of their attitude.
Yeah.
They can use AI for good
Yeah, so
purpose.
there's a bigger question, right? So the question is about AI adoption then, right? So do you think, is everyone going to adopt AI?
Adopt AI to what is the question? Yes. Yeah, so now
Maybe
if
that will be the role of teachers afterwards to tell them what to search.
Yeah.
No.
So any other student, thanks Sanaga, thanks for your thoughts. Yeah, there's another student who wants to share the thought. Yeah, thank you. Yeah, so you should quickly.
I am a research scholar as well as an assistant professor, so I can share both coins, from the both angles. So what I feel is that technology is evolving, and we all need to embrace it positively, right? Though there are negative parts also. We all agree that it is definitely increasing our productivity, whether in creating our lectures or starting with our research. So, but after all these Gen AI are our assistants only. That's what I believe. So we can start on with them. Okay, they give us a good head start, but ultimately we have to look into what they are, the results they are giving us. So I'll share my personal experience here. So I'm working in the field of ML and AI, right? And when I started my research, I also gave the question, of writing the code. And it gave me the results, and I was so happy that in one night I got everything, Wow, it's so easy to write a paper. So when I then checked out, okay, every line of the code, I just found out there were so many things that were missing. There's a complete data processing pipeline that we need to follow in it. And it did not go through the whole pipeline. Its main thing was that, okay, it gave me good accuracy, but steps were missing there. So we have to go and check each and everything, right? So basics we have to have in place, okay, and to check, whatever information we are gathering from it, whether it is code, okay, or any other, in personal also I feel now, and nowadays people are taking even help for their mental well-being, from ChatGPT. I have seen so many students who are going to ChatGPT to look for such suggestions also. So there are negative points also, but yeah, we have to embrace it, and we have to learn how to use it in an effective, ethical manner. That's what I wanted to just put across. Thank you.
Thank you. Rupali, right?
Yeah.
Thank
I'm
you,
Rupali. Thank you.
Please take a chair.
Yeah, hi, I'm Deepti from Triple IT Hyderabad. So, talking about how AI is used for the productivity, do I get the question?
No,
right?
so we were discussing the societal and the community impact. I think that
Right.
was what we were
Right.
currently discussing. But I mean, if you want to talk about how has it changed your research workflows, I mean, you can do
Yeah,
that.
so I have basically some perspective on the first point as well, when we said that maybe it's making students less creative. So I think it's a big portion of it is about awareness. Using any tool, you should be aware what you are using and how. So if I give a very simple example, how I use let's say ChatGPT, because it's a very well-known tool. So there's a study mode in ChatGPT, if a lot of students might have seen. So when I want to understand a research paper, sometimes when it's very tough, I obviously give it a first read, but then I upload this to the ChatGPT study mode, and I basically ask it, hey, I want to understand it. Can you ask me some insightful questions, which will help me build my creativity? So it actually can help us as a very good assistant. I mean, these technologies are very good at retrieval. So if you give them specific documents and the right kind of prompt, they tend to, I would say, in some sense, probe your creativity. You can. So whenever I'm asked a question, I'm like, oh yeah, I could have thought of it like this. So I think it's about awareness. That was the first point. Secondly, this one where we mentioned how accessible these technologies are to, let's say, the people of rural area. So one thing that we all know is so when it comes to accessibility, it's about how we design the application. So and also how badly we need it. So I see a lot of places where even the rickshaw walas or auto walas, bhaiyas, all of them know how to use Google Pay because it's a need of the hour. It's needed for them to use these digital payment platforms, and they know how to use Uber. So the other day I was traveling in Uber and I could see that it was written, like everything is written in their native language. So those kind of supports are also coming. And then we have then there has to be initiative via the system, like the policy makers. So then there are startups like Bharat Gen from IIIT itself. They're trying to raise funding from the government to build large language models for Indic languages. So these are very small efforts we can put into place so that it's accessible to everyone.
Thanks.
Yeah, thank you. Deepti from IIIT Hyderabad.
Thanks,
Thank you.
Deepti, for your thoughts. I think that's very pertinent points there, right? I think, of course, but the question was that people who use AI and people who don't use AI, so there's going to be an increasing, gap between those people, right? Of course, I think the students here or the professors here, they all belong to the category who are well conversant with AI and are using AI to the best of their abilities. Okay, so but with that, I'll move on to the next question, and the question is for you, Alpna, because now that we're talking of agentic, workflows. So one, how are they reshaping the industry? That is one. Are they really bringing about a change in the industry? Because, so I'm sorry, because you are the only person who are representing the industry here. And in order to prioritize, in order to do that, what skills should students prioritize? So should they focus on just systems thinking, or should they focus on, algorithmic, conceptual, or theory? What should they really focus upon? That's a question for you.
So agentic as an area is actually evolving. It is still not, we don't have the final shape and form in which it will come, but lots of concepts are coming, and there are, I would say, some benefit of agentic models. So when I'm saying agentic system, I really mean multi-agent system, and this type of system have been there since many years. The only difference which has happened is that now the agents have their own, they are powered by LLM, they have their own memory. Otherwise, agents who used to take autonomous decision used to be there earlier also, but they were rule-based. So now, because of LLM being part of agents and them having a sort of additional memory, which is again, this concept has been there, but obviously it is a new avatar of agent, and people don't know how exactly they are going to benefit. There are certain scenarios in which they are definitely very useful. For example, predictive maintenance, or anywhere where you want to iterate over different types of concepts or ideas, they are definitely going to be helpful. But they are not suitable for the situations in which situations which are mission critical. So I think right now there is a kind of agent washing also happening, meaning that you try to solve every problem with agents, but that is not correct. You have to really understand what is the real problem and what is the nature of the problem, what we want to solve, and then based on that, we have to figure it out whether an LLM-based multi-agent system would be needed or not. So in terms of the, I would say the learning which students should take on to understand this field better, as you said, systems thinking they should understand. They should understand the concept of software architecture better, because there is a lot of architectural theory in computer science which can be really applied here in terms of the distributed system, multi-agent system, all those kinds of things. If you understand that area better, you can really start looking at the multi-agent system properly. So architecture knowledge is very important apart from other things also.
Yeah, so Meenakshi, do you have any thoughts? What type of skills should students build?
Yeah,
for times to come?
Yeah, from the industry. I mean, I left the industry 16 years ago now.
Yeah. No, not from an industry perspective, but in general,
Yeah.
for the learning and research skills, what type of things should they focus upon?
Right. No, I mean, maybe I would quickly add on to what Alpana said. Like, there are two angles to take a firm like Microsoft. There are two angles. On one side, this massive promotion, use Copilot. The other companies are being told because it's going to increase your productivity. And Microsoft comes for campus placements. And the student is asked to sit opposing the interviewer and given a blank sheet of paper and a pen and asked to write code there by hand. If you're able to do it, you go to the next round. Otherwise, you can't. Right? So there's something that they want from them. And the minute you get employed, maybe you're asked to use Copilot. But to get employed, you have to be able to write code by hand. Right?
That's an interesting observation. So do you think the industries and the academia then should apply in different fashion? I mean, we should teach some skills in the university, which would then, that industry then would need to retrain essentially, right? All the students say.
Yeah, I mean, it's not clear to me what they want. Like, for example, if your goal is to promote after you become an employee to start using Copilot, might as well, test them on prompt engineering. But no, you test them on their ability to write quick sort correctly. Right?
Yes. I do agree. Yeah. But the thing is, do you think universities should also evolve? Maybe we should also introduce a course on prompt engineering, just teach generative AI, how to use these tools. Do you think, should that be done?
No, I still don't believe prompt engineering could become a full-fledged course.
Yeah.
I don't think so. But the kind of experiments that Yogesh was talking about, I think that's a stunning experiment. Why not try out something like that? University could evolve doing something like that, but not get down to teaching an elective on prompt engineering. I don't think so.
So I think
I'll just add analogy. It's like we have to teach children multiplication tables before we ask them to use calculator.
Okay.
I have one point, actually not a solution for something. It is again question, which I feel now we are in our 40s, 30s, whatever the generation, previous generation. So we did our UG, PG very good without Gen AI and Copilots.
Without internet.
Without internet. And we studied concept very well, so we can write code on paper and we can even use the Copilots. But I'm very much worried about this new generation. It's like chocolate for everyone. Copilots and everything, all pop-ups are coming to their browsers, and they have to register themselves, and even Microsoft is asking to write the code. So I'm with them, like they have question what to do. And what does this society expect from them?
Sure. So we would also like to hear from students what are their thoughts. So what should be taught in universities versus what should be done by the industry. So yeah, we have a volunteer here. Yeah, please come in. Anyone else wants to speak? Please, you can come next.
But there is no choice for basics, that I
Just
agree.
get up and come here. Whoever wants to speak, yeah, please. Yeah, please. Very quickly, yeah.
So like the point which I wanted to highlight is that students should be asking themselves that what value do they provide. So for example, I'll just give a simple example. So coding agents are.
But even I'll say your UG is completed before Gen AI.
Yes.
So you are not the right person to answer my question.
Okay, like I just wanted to give an example. Like all of the machine learning systems are in some sense a reflection of what their training data is. So for example, if you ask them to write Python scripts, they'll write a very beautiful Python script because lots of Python scripts are available on the internet. But if you ask them to write multi-threaded C++ code, they will fail.
But we can train it, right?
We will need someone to write correct
over the
code.
time we will train and it will become more smart.
Then so the bar moves higher. So for example, let's say 5 years ago, like a bachelor's project would be to implement some algorithm maybe. If you can do that in one day, maybe you should be asking students to actually come up with good research ideas. So I think that is a good thing, right? That
could you just reiterate your point? So the question was, how would you like universities to evolve? So you're saying that we should not ask students to code algorithms and we should ask them to produce research ideas? Is that what you're saying?
No, like they should be comfortable with these things. So for example,
Comfortable with what?
comfortable with the basics. So for example, I know how to multiply integers.
But how do we assess that and evaluate that?
I think pen, paper, I think even like oral kind of examinations where, you sit.
Do you think we should all switch to complete oral examination? Because I think oral examination is the way to go ahead, because even paper pen is not sustainable, right? I mean, how much could you do that? I mean,
Definitely more sustainable than training another LLM in terms of the environment.
I always have an idea, you have these voice-based testing systems, and that itself can be assessed by
Vivas
AI.
and oral thing is really good.
You can build an AI system to just test that if the student is, giving a proper answer or not.
So in Triple IT, for example, for every core course, there is a strong Viva component now.
Oh, so are you moving back
But
to...
her suggestion is you can develop AI agent to take the oral.
I'm saying you use a AI to do oral exams.
Then you're still scratching the surface. You can't ask. I mean, maybe an agentic AI would do, but a Gen AI may not ask.
So maybe build proper AI to do that. Okay. So you have some thoughts, please. Thank you so much.
Yeah, thanks.
So hi, I'm Chetan Sharma. I'm a PhD scholar from IIT Tirupati. So now I'd like to start from the analogy with what happened when, like, Gen AI is nothing but just one kind of disruptive technology which we have seen previously also coming to the human history. So I would like to take analogy from electricity. So when electricity came, it was kind of like it was seen as a devil. It can cook you as well as it can cook your food. But before giving it that much access to everybody, we made that much emphasis that it is being taught at the elementary school level, how the electricity works. So I think same thing we should be doing with this Gen AI technology, because when you want the people to use it properly, safely, they should also know how it actually works. So only that much I would like to comment from it. Like we should make changes in our education system to make sure like people know how it works and what they can expect and what can go wrong, the way we teach with electricity or in the technology. And similarly, around surrounding thoughts. So for the teaching part, when you're talking like how the institute should change. So I think like it's because previously, like till now, mostly whatever education system we have been following is most of the memory based. We are given a fixed set of questions for everybody, and whoever writes best gets the marks. But now I think the education system can use this technology to make the questions, the evaluation, very much specific to the student in question, about how much it has performed sincerely. So then, accordingly, it should be able to come up with the questions to test the student at the different levels.
Yeah, so personalized learning, basically. Yes. All right. So yeah, thank you so much. So, Chetan, right?
Yeah.
Thanks, Chetan, for your thoughts. All right, so I think it's almost time, so I'm just going to summarize thanks everyone for your excellent insights, and I do make this observation, while it is a very powerful, or both are very powerful technologies, but there's still a long way to go, and while we all are, using it to the best of our advantages, but then still there's a lot larger segment of people for whom we need to design and build usable and accessible systems. And I think with that, I would like to...
but along with that, just one line, sorry for that, interfering. But this Gen AI has stolen the poet's creativity and our notes of all the professors, because if you give a prompt, you will get all the PPTs ready, which we spend a lot of time on creating on. And further, who is poet, who is doing poetry, that girl or boy, they used to be very famous in the college, right? In the gathering specifically, they used to get some time. Nowadays, ChatGPT can write a poem on me, or anybody. And even if you want to convert that into a song, with music, it will sing a song. So
Yeah.
that is the effect.
So we had another theme. We wanted to talk about the ethical risks of these technologies, right? So that is, of course, what you are trying to highlight, right? So how do we hold these systems accountable? So Radhika, I think you have some thoughts as well.
So I talked about synthetic data generation that has come handy today. But again, I will say that most of our data contains many biased things. We should first de-bias them and then give it to training. Otherwise, even in future, for example, there is lots of gender bias in the data set because the data is coming from people and there is bias among people. They still project women in the stereotypical roles, right? And that gets affected when you're using generative AI for, say, filtering resumes for certain jobs. We have seen examples of those, right?
And now we are not just generating content, we are also making decisions
Yes,
using
yes.
that content, right? So therefore, the ethics question still remains, right?
Yes. Similarly, one comment on the other for the student where I would like to add is, it is good to use generative AI for the learning purpose. The moment they use it for, in their assignments or projects or exams, that amounts to cheating only. It's a plagiarism that I think everybody should be aware of. For learning, use as much as is possible, but when you're giving a test or anything, one should be very sincere in doing that. So, because today all these technologies have become so much a part of us, we don't even realize we have, the distinction of right and wrong is blurred. That we have to be clear about as teachers and as
I
learners.
recently heard someone, the ability to discern. I think that's incredibly important, right? What is right, what is wrong, and I think that's a question for everyone to answer on their own. So I think Meenakshi, you wanted to say something?
No, nothing much. When it comes to ethics, I just had one point, I mean, for a change, I think there is a positive use of generative AI. Like, for example, if as a teacher, you think that, teaching computer science, teaching information technology, teaching engineering to physically impaired or visually impaired students is very tough to make a mechanical engineer out of them or a civil engineer out of them. But you always think information technology, they could be programmers. So, I think there is one positive use of this generative AI. If you try to teach a visually impaired student, it's a lot of work. And, maybe you could use this translation to teach a visually impaired students some cool things like science and maths and programming, instead of saying, class 8 onwards you don't do science, so you can never become a programmer, you can never become a mathematician. If generative AI can mature into being useful for the not so privileged out of the classroom students who constitute a fairly large portion of our population into the next generation, it would be a wonderful thing that can happen with that.
So
No. I mean, I've always thought that if there's a nice use case, why not this? I mean, this
so
excites
Meenakshi,
me.
you're after all going to pick up generative AI then?
No,
yeah?
then I have to pick up a lot of what Radhika knows, which I don't know, the language theory and, stuff like that. But if something like this comes and if I get to use it to teach a visually impaired student, I'd be the first in the queue to pick up that tool.
But that's your personal choice, right?
Right.
That's how you would like to adopt this technology.
Right.
Okay, but I think with that, we would like to, put a close to this session. And as I said, that both are very powerful technologies, but and then though there are a number of challenges and risks, and also a lot of interesting problems for the researchers out here to look into those problems, try build better systems, and hopefully looking for a better and a brighter future ahead. Thanks everyone. Have a good evening. Yeah, and thanks to each one of you. Yep. I think we have some tokens as well.
Except for you.
It's there.
Thank you. Thank you.
You just thank you, Professor Manik It's really very interesting session for all of us, and thanks to all the students who participated and put their point forward. Now we will begin the ACM India Outstanding Applied Innovation in Computing Award talks. To chair this session, I invite Dr. R. Venkateswaran, ACM India Council, to please take the stage and guide us through the presentation. Over to you, sir.
Good evening, all. So, this outstanding Applied Innovation in Computing Award, we started it this year, and this is the first set of awards that we have rolled out, and of course, we expect that it will continue for years to come. The idea was that so far, ACM India has not been recognizing, there was no forum to recognize practitioners who have contributed significantly to the field of technology. A lot of the awards were focused more on the research community. And this year we, as part of the External Engagement Committee of ACM India, we thought it would be a good idea to create a forum or a platform for recognizing practitioners. And that was the thought behind initiating this Outstanding Applied Innovation in Computing Award. Of course, as the name says, it is applied innovation. And of course, computing comes in. Today, everything has a technology flavor to it, and that's why the applied innovation in computing is all about. I won't take much time, we're running short on time, so let me just start with introducing the winner of this year's OAIC award. The winning team is Watson X Code Assistant for Platform Z, which is accelerating the legacy code modernization. This team, the jury, of course, spent a lot of time. We will talk about the process. I'm not going to spend time talking about the process, but the jury felt that this is a significant problem that the team has solved in helping the reason they selected this was because of the high innovation quotient, of course, and in their ability to successfully transition a large number of COBOL code, the legacy COBOL code running on the mainframe platform to more modernized platform. And this has created real world impact, and that's one of the reasons why the jury felt that this deserves the award, the winning entry for the OAIC award. So I would not spend time talking about the project. Let me invite Dr. Yogesh Sabarwal, who is the distinguished engineer at IBM Research India, and spearheading this AI for Code team. And he was pivotal, his leadership was pivotal in driving this core innovation behind this, this translation of IBM, the COBOL code from mainframes to more modernized platform. He has made significant contributions in this field of AI, high performance computing and networking. Yogesh holds a PhD from IIT Delhi, and he has obviously spent more than 25 years in the industry, but he's also an adjunct professor at IIT Delhi and Delhi University. Over to you, Yogesh. You have his presentation? Yeah.
All right. Good evening, everyone. So I'm here to talk about IBM Watson X Code Assistant for Z. That's a code assistant that has been applied for application modernization on IBM's mainframe computers. And so just to say a little bit about the application modernization problem, right, particularly on mainframes. So legacy systems are still very widely used, right? A lot of them run on COBOL. So lots of business applications, particularly in the BFSI industry, are still running on COBOL mainframe. So typically if you do some financial transaction using a credit card, debit card, or anything else, right, there's a very high probability that it's going over some mainframe which is executing some COBOL code. Now, it is estimated that there's still, about 800 billion lines of COBOL code that exists globally. And this poses a challenge for enterprise applications. So one of the issues is that COBOL is monolithic. It's very complex and it's difficult to manage. And there's a high scarcity of COBOL developers, right? And that makes it very difficult to maintain the code. So the average age of a COBOL developer today is about 65 years. So there is a significant need for modernization. So we want to transform these applications from COBOL to modern day languages like Java or Python, and extend the lifespan of these systems because like for instance, there are new mainframes that keep coming regularly, and again, this software has to be updated in order to take advantage of that architecture, right? Now, there have been many solutions that have existed for a long period of time. Most of them have been based on program analysis, right? And so they basically try to mimic the COBOL behavior in Java. So it's more like simulation rather than, moving from COBOL to Java. So as an end result, what happens is you have an application that's running in Java, but it looks like COBOL. And now you need a developer who understands both COBOL and Java to maintain it, right? On the other hand, LLMs have been applied, right? That's more recent. They do a good job on small programs, reasonable sized programs, but they do not work on enterprise scale applications which run into thousands of programs with, each program being thousands of lines of code. So the need is to combine the program analysis with the LLM technology. Right, that's where watsonx Code Assistant for Z comes in. The modernization experience basically consists of 4 key steps. The first is understand, which basically allows the developer or the architect to understand the application by automatically discovering the knowledge in the application, right? So the architect can chat with the system. He can ask the model to explain what the application is doing, what the program is doing. You can discover business rules, and so on, right? And then if you want to transform, let's say you want to take some COBOL application and transform it to Java, it's never done in one shot, right? So you always do it incrementally. So you identify a service, and then you want to pull that service out from the entire application, one at a time, and run that in parallel to the full mainframe application, right? So the refactor component helps to modularize. It basically helps to analyze the application, and it's user-driven, and it helps the user to navigate and to basically extract that full service from the application. The third step is transform, which is essentially transforming from COBOL to Java, or PL1 to Java. PL1 is another language on mainframes, very much used on mainframes. And again, you want I think the crux is you want Java optimized design, right? You can get some Java, but you want Java optimized design, you want a good object-oriented design, right? And that's a challenge. And the last step is that, okay, we know that, models try to transform and they always make mistakes. So we need to support this with some kind of a validation module, right? Which generates tests and tries to ensure that the Java that has been generated is correct. Okay, so I'm going to just talk a bit about some of the challenges which come up, right? So for instance, in understand, one of the main challenges is the limited context window, right? So if you want to understand an application, you cannot provide all the programs and all the include files and everything to the LLM in one shot, right? It has a limited context window size, and this context can get really huge. Then the next problem is that typically the code assistants, right, they cannot reason over multiple programs together. So if you ask a query, typically if it's in a single program, they do a very good job. If it's spread across multiple programs and they have to chain the logic together, they generally do not do a good job. There are exceptions, but they generally do not. So the cross-program context was lost. And of course, there is lack of program analysis awareness. So control flow understanding is very limited. If one method or one function is calling another, right, then they are not able to, again, piece the logic together across the control flow. So one of the most obvious solutions is to use RAGs, right? So you can build structured indexes over the applications, over the files. You can generate code summaries. You can generate outlines of the code, right? That where are the methods, what are the key control points. You can generate documentation of the code, right? Maybe try to capture the inputs, outputs, and so on, and what it's doing. And you can also combine, so again, in the RAG, now you have code the code context and you have a lot of documentation that's available. The documentation could also be coming from the user. Now the challenge is to basically combine all of these in order to build a context, a relevant context to be provided to the model, right? Okay, the other interesting thing is something we call the code dictionary. So if you look at COBOL programs, or this applies to other programming languages also, but in COBOL in particular, right, the variable names or method names are very, very cryptic. And the reason is that COBOL has a limit on the size of the variable that you can define or the method name that you can define, right? So they turn out to be cryptic. And now if you're trying to understand the application, right, you can't do justice unless you really know what these cryptic names are, right? So you need to derive the semantic meaning of these variables and methods, right? So how do you do that? That's again a very interesting problem. Again, you can try to derive it from the code, from business logic, user documentation, and so on, but a very interesting problem to solve. Okay, moving on to transform. The first challenge is, coming up with an object-oriented design. So again, I won't talk about the limited context window again, but I think the fundamental issue here is that design is a global application level problem, right? You can't look at a single program and come up with a design, right? You might be using data structures and you might design them in a particular way. And then when you try to move to another program and, work on that, it's using the same data structures, but then, it has a different view of what that data structure may look like, right, in Java, what that class might look like. So you have to decide classes. You have to decide where the processing goes, where the methods go. COBOL doesn't have any structure of classes and methods, right? So you have to decide where the processing goes into which class. And again, there are other challenges which I won't get very deep into. In terms of solutions, right, one of the things we did was, so we did a program analysis supported class design, right? So that's done upfront right in the beginning. You look at all the data structures and come up with the class design. And a lot of it is assisted by rule-based patterns, which are determined by experienced COBOL developers. And once that design is fixed, right, then you go into translation and you work on one method at a time, one paragraph. You call it a paragraph in COBOL. You work with one paragraph at a time and you translate that into Java, right? And now it needs all the data structures, so you go and look at what are the relevant data structures for that particular code. You pull them together and provide them to the model as well, right? And in addition to that, again, models are heavily dependent on the kind of training that is done. Now, there's a lot of Java code out there, there's a lot of Python code out there, but there isn't a whole lot of COBOL code out there, right? So the patterns that these models have been trained with are very, very limited. So again, we had our experts generate these pairs, which were then are used in RAG and also in training the model. Okay, in the interest of time, I'll skip this. Then in validate, the fundamental problem is whether the generated Java code is equivalent to the original COBOL code or not, right? So there we rely on symbolic execution. And again, there are many challenges with symbolic execution. Like for instance, you have to model a large variety of COBOL data types. You have to model a large variety of COBOL statements. There are more than 7,000 different variations of COBOL statements. And you have to ensure coverage. So for instance, if you look on the right-hand side, right, that's a simple program with 2 if-else conditions. And so what you do here is you basically do a symbolic execution, and you see that there are 4 paths. For each of the paths, you basically find out the constraints on those symbols, and then you pass it to a constraint solver, right, which tells you that what are the possible values that the input might take for which this path will be traversed, right? And then you generate your test inputs based on those patterns, right? So again, you have to ensure coverage, good coverage of both of the control as well as data. And then there are these intricacies of mainframes, right? There are these frameworks like KICS, SQL, IMS, which are outside the scope of the the core code, and it's difficult to run in an actual mainframe environment. So again, we end up mocking this, right? So we mock some of the external resources in order to make this happen. So again, the crux is that we, from the COBOL, we generate the Java, then we generate the COBOL test cases, we run them using a debugger-based execution, we generate the Java unit test cases, and then we check whether they match or not. Again, if there are faults, if there are problems, right, in a particular path, we can identify that path and give that feedback back to the user so that the user can go and refine the whatever the transformed code is, right, and make it correct. Okay, with that, I'll close the talk. Questions?
Meenakshi has a question. Can you?
Use symbolic execution. So you wrote your own symbolic execution tool for COBOL?
Yeah, I mean, because, there are many.
Java there are.
Yeah, Java, other languages there are. The problem with COBOL is that you have to model the COBOL data types and the COBOL statements, right? So yeah, we had to extend a lot of this functionality in order to enable that.
And then you used it to match state spaces of the COBOL program and the Java program.
Yeah.
Is that the...
Right.
Okay.
Context problem, like for example, I have interprocedural kind of context across functions. So at least for me, from the slides, what I understand is you use RAG to solve that problem, right?
Yeah.
So how do you solve that using RAG? Because
yeah,
you still
so again,
have to
the idea with RAG is you create some kind of an outline of each program. Like one is you could generate a summary. The other is you can generate information like what are the variables being used, what is the call chain, right? Now, then when a query is asked, you don't just look at, so RAG helps you identify some of the code pieces where the solution may be lying, right? So looking at even all modern day code assistants do that, right? So they look at whatever the code exists and scan it and generate some kind of an outline of that and store it. Some of them store in files, some of them store in a RAG, but that's a standard practice.
Yeah, sure, thanks.
So that's done dynamically. Yeah.
I will take one last question from here. Yeah. Third row.
Hi, sir. So I had a very generic question. So as you mentioned, currently there is some 800 billion lines of code for COBOL which is still out there. So can you comment on any other such legacy language which is still there, which we need to convert in the future?
I think COBOL is the largest, without doubt, right? Next to it, again, I am aware of PL1, right, which is again on mainframes. A lot of legacy code exists out there. Yeah, these are two that I am aware of. There could be others. There's Rex and JCL, and yeah, there are. Again, I'm more familiar with the mainframe technologies, so I'm maybe pointing out more over there. But yeah, as a closing thought, right? Look, these code assistants, the role of code developers, right, is slowly shifting. Instead of being developers, they are going to become code owners, right? They will be called code owners in future. They'll be responsible for a code, for developing certain code. Now, whether they use AI, generative AI, or whatever they do, right, they will generate that code, but they are responsible for ensuring that it is correct, irrespective of how it is generated, and that, that it functions properly, integrates properly with other systems. And the job gets more difficult because, developers, when you're taught in colleges, you're taught to start writing from scratch, right? Here, you're not writing from scratch. You are given a piece of code which has been generated by somebody else. So if you're familiar with maintenance, yeah, not something that's been looked upon. People don't look upon it very positively, but it's very, very important. And you have to deal with somebody else's code. And here you have to deal with the LLM's code, right? So the role of developers is slowly going to shift to be more of code owners and ensuring that, the code is correct, whatever has been generated. Okay? Thank you.
Thank you, Yogesh. Congratulations once again. A great start to the new award, and you've set the bar high for the years for the next year. Whenever we look at the next set of submissions, the bar is very high. Congratulations again to you and your team. Thank you. A small token of appreciation. Thank you. Picture. Oh. Yeah. Thank you. Thank you. Thanks. We got more than 20 submissions for this award, and the jury had a tough time. Of course, while the winner was obviously, we already interacted with Yogesh. The jury felt that there were two other innovations that deserved an honorable mention. The first one is from IIIT Hyderabad. They worked on the problem of road safety, and I'm sure that's a problem that we all understand. And they took the audacious goal of reducing road accidents by 50%. And it was a true interdisciplinary project combining the technology from AI to civil engineering to policymakers. All of them got together and have worked on this project. And it, obviously the impact has been significant. And to explain about their work, I'd like to invite Professor Jawahar from IIIT Hyderabad. Sir, it's a pleasure to have you here. Professor Jawahar, he is a founder Center for Visual Information and Technology at IIIT Hyderabad, and his research focuses on computer vision and AI systems at large scale with real-world impact. So primarily his focus is AI for societal impact. So I'll not take much of his time. So let me first invite him here, and sir, please take the stage and see your presentation.
No, it's okay. This arrow will work. Yeah. Thank you for the recognition. Thank you for this opportunity. So this is a problem that we all understand, and that requires solutions which we still don't know what is to be done. So I got into this space. Of course, this is with a large team, and we had to limit the team numbers based on the requirements of the award, and with multiple institutions. And this is based on 2 long field experiments carried out in Nagpur, a city, road network, and Telangana, a state highways where it was carried out for nearly 3 years of field study. So this project started, or this activity started in 2017, where we were talking about, from a university standpoint of view, what does it take to have autonomous driving in India. The leftmost picture that you see is a brainstorming meeting with academia, industry participants, talking about what is the challenges of autonomous driving in India. And we were hoping that autonomous cars are going to be in Hyderabad street 2 years from then. So we were proved wrong, as we all know, and we had to actually, of course, we thought that, okay, look, the team was very small, and this team is incapable of solving this problem, so we want to make sure that the great professors from the Stanford and MIT should solve this problem or get into this problem. We thought we should set up challenges in the top computer vision forums or AI forums, where people will participate and know the gap, what are the challenges. So it was a long journey of various challenges and solving problems in standard machine learning formulations for segmentation, classification, detections, tracking, or whatnot. Whatever we can think of and whatever we know what that people do, we found that there's a big gap between what happens in the Western datasets versus Indian datasets. The gap, challenges are understood, the problems were exposed, solutions were partly found. But what more interesting thing happened, unfortunately some of the animations are not playing here. So what happened was, we found there are a lot of interesting local problems that we can solve now. The first was the same technology that could be used for detecting objects, finding patches on the road can be used for identifying potholes and the damage on the road. So what's the status of our road infrastructure? What requires maintenance? Where we need intervention? What is that we are struggling on our roads could be identified, mapped at scale with ease. Today, if you go with the traditional civil engineering methods, things that could take surveying, ages of surveying could be done at scale with a simple camera-mounted car. So this was going on, and we had the standard academic achievements we had in terms of papers and other things, etc. So with the data set that came out during that period, had downloads, all the standard metrics of citations, downloads, indexing, all of them we were getting. So in 2021, we started asking these questions. So what can we do? Are accidents predictable? If AI can predict things, can we predict accidents before it happens? Can we predict accidents where it will happen? Can we predict accidents, who will get into accidents? So the hope was that if we can ever predict this, then there is a way for us to intervene. So this was the thinking in 2021, and that is where we thought we want to try out this prediction possibility. And so this was an effort with people from academia, industry, government, NGOs. Because even if you are able to predict accidents, we know that we can do nothing. We would like to have an ambulance driver who can take the patient or the person who is hurt into the hospital on time. If you can get even an ambulance on time, that saves life. So the prediction, how prediction is going to help is in a very different way than what we usually look in a typical AI solutions. So what the experiment was carried out is, so you may ask the question, how do we ever predict accidents before it happens? It's a simple analogy. If you look at if every vehicle is putting a sudden brake in a specific spot in a city, we know there is something wrong at that spot. So what we have done is an extremely simple way of collecting data across city, across time at scale. So we have the abnormal movement patterns of the vehicles, and they are mapped into the geolocations and accumulated over time to know that where this sort of abnormal events like braking is going to happen next as a potential accident. And then intervene in a systematic manner with civil engineering designs to training the panwala standing on the roadside in the first aid. And that is why we need all expertise, including the first aid expertise from the doctors. So what is that hi-fi technology that we can do? So there is an interesting lesson that we had seen. So people talk about, is it autonomous driving the way to go? Or is it a technology that is aiming to go to moon is the right thing to do? So the observation is that, so technology that is designed for autonomous driving is today helping ADAS. The design of most of our cars today got changed a lot because of the technology that was used for designing autonomous cars. Not that our cars are autonomous. How we brake. Various components of your today's vehicles are changed. So we ask the next question, if that is true, that is proven, which is well understood today, can ADAS technology be used to still more primitive, more fundamental, more critical issue like road safety? So this is where the signal harvesting at scale come into the picture. The pedestrian collision warning or the lane departure warnings, all these warning signals that are available in ADAS is what we are harvesting at scale. So if you might have seen these boards like accident-prone area, drive carefully. This happens after many years of observing accidents. So the challenge here is, can we keep this board, can we predict this accident before it happens? And that is what these signals and accumulating these signals on is giving us. So in nutshell, the project used data, huge data available from large fleets in these two cities collected over a couple of years. And using standard machine learning algorithms to predict by accumulating these signals where these accidents are going to happen, which vehicles are going to get into, and then intervening. Intervening in a more holistic manner, starting from driver training to civil engineering to tri-standards. And that led to ground impact, 40 to 50% of reduction in accidents by statistically studying on vehicles in this long span of time. And the tri-standards, who were available in the period towards the end of it, who had clear, explicit use cases of the people who were taken to the hospitals and lives were saved. In both Nagpur and Telangana. And these reports are publicly available, and lessons and our how to operate, what to do, what not to do is possibly better understood today. And so this was awarded, India was awarded the Best Government Tech Award in 2024, and many recognitions of various scales. But there are many fundamental questions which we still don't know how to answer. Who will help in scaling this project across the country? What is the cost? Yeah. What is the cost of carrying out such a project? So the two attempts that we have done in Nagpur and Telangana used ADAS, which is a costly entity which we cannot really scale. So what's the best way where we can get? So for example, is it possible for civilians to contribute? Can all of us use a specific app which can provide such signals and can be accumulated on a certain say, cloud server, so that just like the way we use maps, can provide the potential spots, potential warnings, and guide you for safe navigation. That can help the governance, the authorities for designing better roads, better infrastructure, improving the infrastructure, and thereby saving life. So there are many technological open questions to solve, and we don't know how we move and what we do. We still continue this sort of thing in whatever form we are able to do. But I'm sure all of you can find enough opportunities in a really, truly multidisciplinary problem space. Thank you.
Questions?
One was at the scale of a state, and the other one was the scale of a city. Nagpur and Telangana.
Nagpur was a city, so the way we did was, first was in Nagpur, it was a city scale experiment. We were dependent on the city fleets for experimentations. Then we were not sure whether the lesson from the city will be really true for highways. In Telangana, it was tested on highways, not in Hyderabad as a city.
So even with these two, you still have a lot of open questions to answer before extending it to other states.
It could be extended, so today, but today, say, who is the beneficiary? Because assume the accidents are reduced. Who is going to pay? If you have less accidents, it's not clear, is the government ready to pay or somebody else is going to pay for this? So as a result, so you don't know how to scale it. Who is going to invest on it?
Thanks for the talk. It's very interesting. I had a question about the data collection part. So did you have vehicles fitted with specialized equipment for this?
Yes, so vehicles were fitted with ADAS.
Okay.
Standard ADAS device was fitted, like a few hundred vehicles
I see.
were fitted for 3 years or so.
I see.
Low.
Okay. Yeah, okay, thanks.
There are no other questions? Oh, there's one.
You said that in your device you were harvesting data largely from the signals, etc., right?
Yes, yes.
But what about those places where we don't have that network of signals around?
So we are harvesting signal from the vehicle movements. So for example, if the ADAS signal is fitted with your car, your operations, for example, whether you're accelerating, decelerating, you're changing lane, you're sudden braking. So this information is what goes to the cloud, goes to our server.
Okay. And what is the cost of this ADAS?
It is somewhat costly today in scaling. So because we were using commercial like a ADAS. However, so we are presently looking at what is the cheapest, like a couple of thousand or 1,000 rupees, 2,000 rupees IoT sensor is what presently we are trying out.
Sir, I had a question on the impact and outcomes slide. Like you said, 36 lives were saved in Nagpur. So can you just bifurcate what kind of lives or accident were going to happen?
So okay, yeah. So what you talk about, the lives were saved, that is the last 6 months, etc. So what happened is now we trained on first aid, so we know where the accidents are going to happen. We train the people standing or shop, selling or whatever, the tri standards, including shops and the people who live nearby. And when these people were taken to the hospital. So the accidents happen, the emergency requirement come, they were all taken to the hospital, so this entire pipeline happens towards the end of it. Now one could always ask a question, save the life, like what if they were not taken to the hospital, what will happen to them? We don't know exactly, we cannot say. Yeah.
Okay, so for this you have like emergency services?
Yes.
Okay, thank you.
Sorry to interrupt, but we are really running short on time, so thank you, sir.
Thank you.
Small token of appreciation. Again, congratulations. Here. The second honorable mention goes to Tata Trust for developing the national portal for non-communicable disease. Again, let me quickly read out the jury comments. The impact that this team has had is training more than 2 lakh healthcare professionals, onboarding about 50 crore individuals across all 31 states. And this has been a phenomenal impact that the Tata Trust has had in terms of, it's a healthcare portal, but at the same time, it adopts a lot of technology to make sure that the non-communicable disease is addressed in the using the right kind of technology. It has established a gold standard in providing mission-critical national-scale digital infrastructure for healthcare, and that's what the jury felt was the unique contribution from this innovation. Of course, to hear more about this initiative, I'd like to invite Mr. HSD Srinivas, who he's a healthcare management professional and heads the health initiatives at Tata Trust, which has been where he has been leading this efforts for the last 10 years, since 2016. Let me invite Mr. Srinivas here to talk about this work. Mr. Srinivas, welcome and congratulations. The slides. Sure. These are slides.
Good evening, and thank you so much for this opportunity to present the project. And thank you for the award, recognition for what has been a very fulfilling project for all of us at Tata Trust. I know this is a technology conclave, and I was a little bit apprehensive what I would be able to present, because I'm not while by academics I was an engineer, but all my life I've spent only in healthcare. But I've been able to understand how healthcare can benefit a lot from the structured way in which engineering applications can be utilized. And what we hope to present today is one of those experiments that have actually become very successful and got scaled up nationally and got a lot of recognition even abroad in most of the CRO countries. As a philanthropy, the trusts have been at the forefront in trying to solve the challenges of the country. And this gentleman is our inspiration. Mr. J.N. Tata was one of the very first pioneers whose efforts have culminated, of course, not in his lifetime, but in the establishment of Indian Institute of Science. And that's where that's how the history of philanthropy from the Tata Group has started. Today, we are a total of about 16 trusts which have been established by various generations of Tatas. And we have a perpetual philanthropy model by way of ownership in the Tata Group companies, and all the proceeds of the shares coming to the trust and going back into the society. We work majorly on healthcare, education, nutrition, wash as in water and sanitation, rural livelihoods and urban poor related, and a little bit in arts and culture. But each of the trusts have all now been consolidated to be branded as Tata Trust, and the effort has been to solve problems at scale. And this is one such example that we've collaborated with Dell Technologies and were able to identify the issue of fragmented data in healthcare. What is it that we are, one of the major issues is that a country of 140 crores, we still don't have digital records anywhere being used at scale. Of course, the private sector is different. Every hospital owns the data. There is now effort to ensure that the patient actually is able to own his or her own data. But when we looked at it about 10 years ago, these were some of the issues that a country like ours, we are very poor and very disparate in using the available technologies. Now, back then, 2017, one of the reports which was conducted by 3 major institutions has actually told us that 65% of the country's mortality and morbidity is now due to non-communicable diseases. And this is simple. Diabetes and hypertension today is now absolutely rampant and prevalent, and back then, even a decade ago, they were the leading cause, underlying cause for a lot of diseases which are, resulting in more than about 50 lakh deaths in this country. But at a population level, we didn't have data. We don't know who's at risk. So we tried to look at a small POC, proof of concept, in 2 states, now 2 states. Even then, and about 5 million patients were screened for 5 different conditions. And this was done through, the major innovation, of course, was the application that was developed, and that was the core in ensuring that the healthcare workers actually left the manual way of doing things and started using tabs and the software embedded in that to collect data, and that made their lives easier, that brought a lot more coherence to policy, that gave a lot more patterns that the policymakers could identify, and where possible they were able to actually develop solutions for these locally. This got scaled up to cover the entire country, 31 states adopted it with the initiative taken by the central government. Our objective at that time was that all those above 35 years of age, we should be able to screen them and collect their data and provide the next logical treatment. That has met with some sort of a success. I won't say it's a super success, but what actually heartened us was that frontline health workers who are, probably 10th class pass or 12th class pass were able to actually leave their fear of technology and adopt, and it's now ubiquitous that they use either tabs or their cell phones, and then the patient's journey is continued to the next level and the next level wherever it was required. And this is especially true in the rural areas that we were able to actually make a difference. Of course, the cascading is that you need to understand the goal, you need to have a strategy, you need to develop systems, you need to have a structure that will support all these systems, fix accountabilities. And we were at some point monitoring almost 160 metrics at various stages across the multiple states that we were operating in. And these are some of the levels at which technology was able to integrate multiple data points and give a correct picture. On a daily basis, the government was able to actually, both the central, state, and the district government, down to the level of a PHC doctor, were able to monitor the health of people under there. So a state like Telangana knows exactly the 3 crore people, what is their status, whereas a PHC doctor knows exactly 3,000 people who are under his PHC, what are their health status at any given point of time. Of course, so these are some of the lessons, how we were able to achieve the scale up, and that's a very rigorous thing about discussions and compliance to the process. And wherever possible, the automation helped. The core process got automated, and that's what helped us a lot. In terms of finances, for about 50 crore Indian health records, the government gave an initial 1,500 crore as the IT-related infrastructure. That was the investment. And subsequent to that, the program itself got scaled up as and when it went to different parts of the country. The budgets got increased. Today we spend about, I think, 1,200 crores annually only on the NCD program. So this is some of the outcomes that we were able to achieve. And it's on a daily basis more than 1.5 lakh users who utilize this system, and majority of these are not so-called technical guys, but ordinary day-to-day users, and that is the success of how simplified the work can become and how technology has helped ease their lives. So these are some of the technologies used in the back end in continuously developing it. We had at least 3 to 4 cycles of development of the portal, and this is how we were able to demonstrate that in especially something like a crisis like COVID, exactly the government knew who are the people who should be looked out for and who should be given the first priority in terms of either testing or vaccination. And that's because they had line listing. They understood that these are the people with comorbidities with the highest level of chance of trying to, who will be succumbing to the virus. We'll be happy to take up any questions. Thank you. Yes, ma'am.
Yeah, so just checking, is this like open source? Like, how can we all contribute to this?
Yes, this is open source, and it's owned as, I don't know open source whether it can be owned, but it's now the property of Government of India. We have handed over the project to the government. we don't necessarily get into any further development as of now. This was a 8 years project which had 4 cycles, 3 to 4 cycles.
Okay, thanks.
Yeah.
So this is fantastic because we are always struggling with the fact that we don't have Indian data, whether it's for mean blood sugar, because of eating habits and all of that. So are the data available to researchers about all the 31 states that are collected? Because recently government also announced that data should be gathered for these very purpose across India.
So I don't know exactly to say yes or no. Anonymized data, you can actually get the large sets of data available on the portal of the Government of India. At the same time, the line listing is available with local authorities if they are able to share. As a private person, I don't think I have access to others' health status. So it's the government's prerogative how much they would want to give or share. We have tried our bit to try and analyze and see if we can get a lot more patterns out. We have been fairly unsuccessful.
Sir, thank you for this presentation, sir. I just wanted to know if you could comment maybe one or two of the greatest challenges which you faced while developing this project in Indian settings at this large scale.
Yeah, so we were the operation implementation partners, and the biggest challenge we faced was the initial resistance from the people on the ground. They didn't want to use tabs, they were more used to registers. And for some time, actually, we had concurrent both registers and the tabs to be filled up. That was number one. On the development front, I think Dell had a lot more challenges, and the multiple requirements from the top, from the Government of India versus the speed with which people were able to adapt to the multiple versions. There was, trying to get that was a little difficult. If you want, I have my colleague, Dr. Aman Singh, who headed the project. Anything more that you can add, sir? Yeah, you can go ahead.
I think most of the thing you have addressed, Srinivas. But while making this application, a lot of challenges actually came when there was some regulation-related issues came up. One was, initially we fed in that Aadhaar should be one of the identifiers while building this application, because at that time it was asked. Then suddenly there was a rule from Supreme Court that you cannot use Aadhaar as an identifier. Then we have to take it back. And again, that Satyanarayan committee report came, and then they partially allowed that, yes, this can be used in this way. Another aspect, what Srinivas said, that when this application started getting adopted, government has a lot of requests on this. They wanted to build in more and more layers on this application. So this also had a huge challenge. We were able to integrate many applications because a lot of states were having their own applications. So that also took us a lot of effort to ensure that one state's application gets integrated into this application. So, but other than that, what the best thing was the government's readiness to support at every stage. The entire IT infrastructure was built by government. They spended, and they issued orders, even in a state like Bihar and Uttar Pradesh, you will find tablets getting, procured in a month time. We can't even believe that. So overall, the experience was very good, and I can say that the current dispensation has a huge respect for adoption of digital technologies.
Thank you.
In the interest of time, sorry, we will have to park the questions. Of course, they are all here. We can discuss after the session. Thank you, Srinivas, again for being here. Congratulations to you and your team. A small token of appreciation for you. So with that, we come to the end of this session, and I'd like to, of course, thank the jury members for doing a wonderful job. I mean, they had a tough time picking from 20 submissions. They had to pick the top one, and of course, they picked 2 additional ones, very, very deserving ones. I'd like to take this opportunity to thank Dr. Yogesh Sabharwal for being here and representing the IBM team, and Professor Jawahar from IIIT Hyderabad for being here to represent his team, and Mr. Srinivas from Tata Trust for being here. So thank you again. Over to you.
Congratulations to all the awardees, and thank you, Chair, for steering this session so smoothly. So we'll take a break for 10 minutes, and we'll come back for some very fun-packed science slam and cultural events are scheduled for today. And just go and get your snacks and come back. And one more, please don't get the food inside. Eat outside and come and enjoy the performances here. Thank you.
We are almost at the end, but still we have one event left, actually 2 events left. One is technical, one is non-technical. The technical one is right now, but I promise you it will be fun. So we have Science Slam, where essentially we have 6 slammers who are going to talk about their work, even with some singing and dancing. And they promise that it is going to be entertaining. So let's give them a big hand, all 6 of them. And we have prize for the best slammer. So let the battle begin. First one in the line is Soham Poddar from IIT Kharagpur.
Yeah, I think you can hear me. Okay, so hello everyone. I am Soham, and I recently became a doctor from IIT Kharagpur. And but in actuality, I am actually somewhere in between a philosophical doctor and a medical doctor, and I'll explain what I mean by that. But before starting, so I have a disclaimer that I will not be politically correct. So some audience discretion is advised. Okay, so let's go back to 2020, when we were all stuck at home. What were you doing? Washing groceries with soap? Or maybe you were just one of those people who were, turning off lights in your home and banging some plates in the terrace of your house. I don't know, I'm not judging. But yeah, so I don't know. So what I'm talking, so I think you can...
Panels, coffee mug that you have received on the first day of ARCS, everything is made of some materials. And the quality of the product that you're using basically depends on how good the basic materials is. Now, let's take an example, and then the things will get even more crazy. So, for example, I have a very moderate, cheap phone whose battery dies very quickly, and my friend Soham, he's a very rich guy. He has a very expensive phone, and his battery stays long for 10 days. You know what is the basic difference between it? So my mobile's battery is made of a very poor quality of materials, and his battery is made of a very rich quality of materials. But the basic difference in the microscopic space is how these different atoms in that battery material is arranged. If it is arranged in the proper way, it can store more energy, and if it is not that way, then it will drain easily. So that's why, for example, the problem is that how can you find out a new material who can store more energy? Now, traditionally, if scientists have to solve this problem, they have to do a lot of chemical experiment in the lab, and then maybe they'll do trial and error. And this is something that will happen, that it will take a long time, 10 to 15 years. Soham was mentioning for drug discovery, it takes 10 to 15 years. Similar things will happen to find a new material. And it's like solving a password that have 10 to the power maybe 20 possibilities and all. So it takes long time in a traditional setting to find out a new material. And in my PhD, I tried of thinking that why not using AI to solving this particular problem. So I worked for AI for materials, so typically means that I train AI models to learn atomic patterns, not to learn images, not to learn tokens for like ChatGPT. I train the model to find atomic patterns. Now, you might be asking that, how AI will, understand atoms, because those are invisible, right? AI can understand images, AI can understand tokens, but how it will understand the atoms. So there is a nice thing in material science that the atoms and the bonds in the material can be thought of a graph. So the atoms are like, social media, if you consider in the social network, atoms are people and bonds are the friendship connection between them. So I use a graph generative AI model through which I have trained the AI framework, and I try to learn the atomic patterns. And then once it is learned, now it can sample me a new atomic arrangement that will give me a new atomic patterns. And basically, it's like you are training an AI model on a lot of images of cat and dogs, and then you are saying, give me another image of cat and dogs. So that's how AI can be used for not only material science, for any types of scientific experiments like molecules, protein. Probably you've heard about AlphaFold experiments. And what takes a lot of time in the lab for the experiments, that you can do maybe within few hours or few seconds. Thank you. And for technical details, come to poster number 2. So yeah, thank you.
Right, and you might also want to subscribe to his YouTube channel. Apparently, it's very popular. Okay, so the next in line, the next slammer is Prasitha from IIT Madras. You have to switch it on.
Hello. Hello, everyone. Thank you for that introduction. So I'm here to talk about a dilemma, which I call it as a bit flip dilemma.
One, but given that we have wildcard entry and 7 people, we decided to have 2 awards, right? And there is enough chocolate for 2, I hope. Yes, there is enough. Right, so first the honorable mention, the award goes to Prasitha. Congrats. Come in. So, this one is for your toddler.
Oh, at least I owe it to her after humiliating her so much here.
I think so. And this one is for you. Congrats.
Thank you so much.
Right, and now we have our winner. Any guesses? Give a big round of applause to Asresha Hota, our wildcard entry. That was a fantastic performance. Thank you.
As we near the closure of ARCS Day 1, it's time to shift gear from logic to rhythm, from analysis to expression. Welcoming to the cultural evening of ARCS 2026, as the first performance, we have a Bharatanatyam group performance from Tal Tarang. Rooted in the temples of Tamil Nadu, Bharatanatyam stands as one of India's oldest and most revered classical dance traditions, tracing its lineage back over 2,000 years. Once performed as an offering to the deities, it is known for its geometric precision, sculptural grace, and expressive storytelling through intricate footwork, mudras, and abhinaya. Each movement in Bharatanatyam resonates with devotion and discipline, making it both a spiritual and aesthetic experience that continues to inspire generations of dancers and audiences alike. Today's performance features a vibrant Kavadi Chinda, a devotional piece dedicated to Lord Muruga, embodying fervent bhakti and rhythmic vitality. This is followed by a dynamic segment of Nata Bhairavi Tilana, showcasing the beauty of different adavu and rhythmic patterns. The presentation concludes with a powerful Natesha Kautvam, a majestic ode to Lord Shiva as the cosmic dancer. This presentation is brought to you by the Tal Tarang, the classical wing of Dance Club at IIT Hyderabad. A completely student-led body, Tal Tarang supports and promotes all Indian classical dance forms, striving to nurture and sustain a vibrant classical dance culture on the campus. With a vision to preserve tradition while encouraging artistic growth, the team has been conducting weekly Bharatanatyam sessions, fostering dedication, discipline, and devotion among its members. From Tal Tarang, today we have on stage Adirathar Naveen, a master's student from chemical engineering, Megha M, a PhD scholar from biomedical engineering, and Manasa Suresh, master's student from electrical engineering. With a loud round of applause, let's invite Team Tal Tarang to grace the stage.
அழகு தெய்வமாக வந்து பழனிமலை மீதில் நிற்போம். அழகு தெய்வமாக வந்து பழனிமலை மீதில் நிற்போம். ஆதிசக்தி என்னை தந்தவாளன் அசுரர் தம்மை வென்ற வடிவேலன். அழகு தெய்வமாக வந்து பழனிமலை மீதில் நிற்போம். ஆதிசக்தி என்னை தந்தபாலன் அசுரர் தம்மை வென்ற வடிவேலன். அழகு தெய்வமாக வந்து பழனிமலை மீதில் நிற்போம். ஆதிசக்தி அன்னை தந்தபாலன் அசுரர் தம்மை வென்ற வடிவேலன். அழகு தெய்வமாக வந்து பழனிமலை மீதில் நிற்போம். ஆதிசக்தி அன்னை தந்தபாலன் அவன் அசுரர் தம்மை வென்ற வடிவேலன். நல்ல அமுதமென்னுமோ தமிழில் பாடிடும் அன்பர் வாழவே கருணை செய்குகன். அமுதமென்னுமோ தமிழில் பாடிடும் அன்பர் வாழவே கருணை செய்குவன். அரணுகந்த குருவாம் உயர் சீலன் என்றும் அருள் சுரந்தே காக்கும் அனுகூலன். tu தீம் ததர தத ரே தாரே ஆரே தாரே.
शशिरविभूषण रूप भयङ्कर डमरुकहस्त तृतीय सहस्र दीक्षितनाथ नटेश कौत्वं तगतगदां दिगिदिगिदै तक्कुदि कुतकिट तुंकिटकिट तगिदं दङ्गि किटतगधि कोत्ता ततदा
That was an absolutely captivating performance. Thank you so much for such a beautiful and graceful Bharatanatyam performance, Team Tal Tarang. We can't thank you enough. Within this short period of time, you guys have arranged this performance. So thank you very, very much. From the elegance of classical dance, we now move to the heartbeat of Indian rhythm. If Bharatanatyam speaks through movement, the tabla speaks through sound. Please join me in welcoming our next artist, Pratik Ravindra Katare, a PhD scholar from Biomedical Engineering, IIT Hyderabad, for a captivating tabla solo performance. Pratik will present a special tabla performance based on a few Bollywood songs. I can't read. On tabla, focusing on rhythm rather than lyric or melody. Through this act, Pratik will highlight the beauty energy and variety of tabla bolas and show how expressive the instrument can be. Let's welcome Prateek on stage with a loud round of applause.
See
सारा जहां तेरी बाहों में ख्वाब ख्वाब है गहरा हुआ रंग आशिकी गहरा गहरा दरिया
देखा एक ख्वाब तो ये सिलसिले हुए दूर तक निगाह में है गुल खिले हुए देखा एक ख्वाब तो ये सिलसिले हुए दूर तक निगाह में है गुल खिले हुए ये गिरा है आपकी निगाहों से फूल भी हो दरमियां तो फासले हुए देखा एक ख्वाब तो ये सिलसिले हुए दूर तक निगाह में है गुल खिले हुए मेरी सांसों में बसी खुशबू तेरी ये तेरे प्यार की है जादूगरी तेरी आवाज है हवाओं में प्यार का रंग है फिजाओं में धड़कनों में तेरे गीत है मिले हुए क्या कहूँ कि शर्म से है लब सिले हुए देखा एक ख्वाब तो ये सिलसिले हुए फूल भी हो दरमियां तो फासले हुए
Thank you, Prateek, for the remarkable performance with an extraordinary display of rhythm and artistry. Let's give Prateek another big round of applause. So we would like to express our heartfelt thanks to the Taltarang team and Prateek for arranging such a brilliant, mesmerizing performance at a very, very short notice. So I would like to welcome on stage Dr. Jyoti and Dr. Subramaniam Kalyanasundaram from the Department of CSE to hand over our token of thanks to the performers. And the Department of Computer Science extend our heartfelt thanks to the Taltarang team and Prateek. Thank you, ma'am. Yeah, with this, we can come to the end of day one. We request everybody to join us for dinner in the guest house, ground floor. Thank you so much. Enjoy, relax, have a good night. Shubhratri. Thank you.